Okay. So therefore, we studied center of mass and we studied moment of inertia. So next we are studying the very important topic which is called as rotational dynamics. Okay. So one of the toughest topics of physics, but we will try to understand in the most simplest way as possible. Clear. See here. So previously we studied about circular motion. No? Okay, now we are studying about rotational motion. Are you able to understand? Previously we studied circular motion, horizontal circular motion, vertical circular motion, all we have studied. No? So now we are studying rotational motion. So what is the difference between circular motion and rotational motion? Can you say? Difference between circular motion and rotational motion is what? Is there any difference or no difference? Yedo sardaga rendu perlu pettukunnava. Difference is there. What is the difference? ఏ బాడీ అయినా యాక్సిస్ చుట్టే తిరుగుతుంది. ఇదేమి డెఫినేషన్ రా బాబు? See, circular motion means we take a single point. Understood, no? Single body and it is moving in a circular path. This is called as circular motion. Are you able to understand? Rotational motion means we take a rigid body. Are you able to understand, ma? So rigid body. For example, disk is a rigid body, no? Disk is a rigid body. So if this total disk is rotating about this axis with an angular velocity of omega, then this type of motion we can call it as rotational motion. That is the difference. Understood, Nama? Circular motion means just a single particle if it is moving in a circular path. We are tying a stone to a thread and we are moving in a circular path. That is called as circular motion. Whereas if I take any rigid body and rigid body is rotating about an axis, then it is called as rotational motion. That is the difference between circular motion and rotational motion. Are you able to understand, Ma? Okay, now see. For example, if I take a disk, okay, no? So this is a disk. Understood, no? So this disk, it is rotating with an angular velocity of omega. Okay. So first of all, we will study some parameters. So consider here there is some point P. Okay, so this is a point P which is present and this is the radius of this disk. Now this disk is rotating with how much angular velocity? It is rotating with an angular velocity of omega. Then after a time of t seconds, same point P, it will reach up to here now. Are you able to understand? This point, it will reach here after some time, after some rotation. Are you able to understand? What is the angle covered by this particle? Angle covered by this particle is theta. Okay. Then what is this theta called as? This theta is called as angular displacement. That is what we call this, Noma. Theta is called as what? You can call it as angle rotated also, or you can call it as angular displacement also. So that is the angle rotated by the particle. Okay. So for this rotation, it will take some time of t also, no? Okay, ma? So body has rotated by an angle of theta, or angular displacement is theta. In how much time? In a time of t. Are you able to understand? So therefore, change in angle divided by time taken. Can you say what can I call this one? How much angle the body has rotated in a particular time. What is this called as? This exactly is what is called as angular velocity. Understood, Nama? So in linear motion we study, Nama. For example, this is a point mass, okay, and it has covered a displacement of s. What is s here? Displacement. What is theta here? Angular displacement. Both are same. Understood, no? Displacement in linear motion, angular displacement in rotational motion. Understood, Nama? Displacement by time is called what? How much body has displaced in how much time? That ratio is called as velocity. Understood, no? Similarly, same concept here also. How much angular displacement the body has covered in how much time? This ratio is called as angular velocity. This is linear displacement, linear velocity. Angular displacement, angular velocity. Okay? How much angle the body can cover in 1 second. That is called as angular velocity. Understood? No? So omega is called what here? Angular velocity. Are you able to understand? No? So now again you come to linear motion. If velocity of the body is not a constant, if velocity of the body is not a constant, then what we say? Body velocity constant ga ledu anukondi. What we call that kind of motion? Atvanti motion emantam? We call it as accelerated motion, or we can call it as non-uniform motion. Okay ma? So how can I define linear acceleration? A can be written as change in velocity divided by change in time. Okay? Instantaneous acceleration. Are you able to understand? Or if you want to calculate average acceleration or general acceleration, then how can you calculate delta V divided by delta T? I can calculate like this also, no? How much velocity is changing in 1 second? That is called acceleration, no? Acceleration ante meaning em is second ki body yokka velocity enta marutu undi. That is called as acceleration. Are you able to understand? Similarly, now coming to rotational motion. Are you able to understand? If omega is not a constant, what is meant by omega? Angular velocity is not a constant. Then what we write? Then we write that alpha is present. What is meant by alpha? Alpha instantaneous can be written as d omega divided by dt. Instantaneous change in angular velocity divided by small amount of time. That is called as angular acceleration, or you can call it as instantaneous angular acceleration. So this is called what? Angular acceleration. Are you able to understand? Clear now? Similarly, if I take alpha average, then how I can write delta omega divided by delta t. This is also angular acceleration. This is instantaneous, this is not instantaneous, this is for a particular interval of time or particular angle of rotation. Are you able to understand now? That's it. So you are able to understand now how we are comparing these two. So linear motion is always comparable with rotational motion as well as circular motion also. In circular motion also same type of comparison we have done now. Circular motion lo kuda ilage compare chestunnam kada manam. Here also same type of comparison. Okay. In circular motion we studied about two types of circular motions. Uniform circular motion, non-uniform circular motion. Similarly, in rotational motion also we will have same two types. Uniform rotational motion, non-uniform rotational motion. Are you able to understand? What is meant by uniform rotational motion? Uniform rotational motion means omega should be constant. Okay? Uniform velocity means what? V should be constant. That is called uniform motion. In linear motion, lo uniform motion ante meaning emi? Velocity should be constant, then it is called uniform motion. So in uniform motion, what is the acceleration? In uniform motion, what is the acceleration? Zero, there is no acceleration. Are you able to understand? Similarly, in rotational motion, when I can call it is uniform rotational motion? When omega is a constant. Are you able to understand? No? When omega is not a constant, then immediately alpha comes into action. Alpha means accelerated motion, no? Immediately it is non-uniform motion, or you can call it as accelerated motion. Are you able to understand the difference now? Whatever concept we study in circular motion, same concept we are studying in rotational motion also. Understood? Come on, make a note up to here. That's not it. See. So, next, already we discussed, let us write the equations also. Uniform rotational motion and non-uniform rotational motion. Clear number? For example, let us take a disk. Disk is a rigid body number, disk. So this disk is rotating about this central axis. Okay, no? This is the axis of rotation. Okay. So it is rotating with uniform rotational motion. It means omega value is a constant. Understood now? Omega is a constant. What is omega? Angular velocity. V means linear velocity. Omega means angular velocity. Angular velocity is a constant. Angular velocity means what? It is covering same angle in same time. In first second it is covering 30 degrees. Second also it will cover 30 degrees only. Third second also 30 degrees only. So it is rotating with same angular velocity. Understood? No? So omega is a constant. If omega is a constant, then what about alpha? What about angular acceleration? 0. How can you prove it is 0? 0 ela prove chestaru cheppandi. Because alpha is nothing but d omega divided by dt, or you can write a delta omega divided by delta t. Like this you can write, this is instantaneous value, this is general value. Understood? No? D omega means change in omega. Change in omega. Omega value, is it changing? Omega is a constant, no? So there is no change. So delta will become 0. If delta will become 0, delta omega also 0. So therefore alpha value will be how much? Alpha value will be 0. There is no acceleration. Which kind of acceleration? Angular acceleration is not present. Are you able to understand? Okay. So if angular acceleration is not present, then I can call it as uniform rotational motion. And in uniform motion, in linear motion, we have only one equation. No? What is that equation? So displacement is equal to velocity into time. In which motion? In linear uniform motion. Understood? No? So can you say the analogous equation of this equation in rotational motion, eternity equation in rotational motion lo cheppandi? Yes, badalu? Instead of yes, I will write theta. Instead of v, omega. Instead of time, time only. So theta is equals to omega into t. This is the only equation. Understood now? So in uniform rotational motion, this is the only equation which we have. Understood now? So everything we are trying to connect with linear motion. Understood now? Now once again you come to non-uniform rotational motion. So again take the same disk. Understood now? Now it is rotating with an angular velocity of omega, but omega is not a constant. Understood now? Omega value is not a constant. Understood? No? So same, this one is the axis of rotation. Okay. So if omega is not a constant, then what is alpha value? Alpha value is equals to d omega divided by dt, or you can write a delta omega divided by delta t. Okay. So omega is not a constant means? Omega constant kaadu ante meaning emi? It means it is varying. It is continuously varying. It means in first second it is covering 10 degrees. Second second it is covering 12 degrees. Third second it is covering 14 degrees. So in every second it is covering different angles. Then it is accelerated motion. Definitely it is not uniform motion now. It is accelerated motion. Understood now? It means d omega, is it 0? D omega, is it 0? Ma? It is not 0. What is d omega? Change in omega. Omega is changing, no? So it is not 0. If omega is not 0, alpha also it is not 0. So alpha also it is not 0. Alpha is not 0 means what? It is present. That is the meaning of this one, no? Meeku తెలివే లేదు అంటే మీనింగ్ ఏమి? లేదు అని అంతే ఇక్కడ కూడా. So alpha is not 0 means what? Alpha is present. That is the meaning of this one, no? So therefore alpha is present. Understood, no? Alpha means angular acceleration. So angular acceleration is present. Therefore this is definitely non-uniform rotational motion. Understood now? So in non-uniform linear motion, how many equations are there? 4. Linear motion, 4 equations are there. So here also we have 4 equations. Clear now? What are the equations we have? V is equals to u plus at. S is equal to ut plus half at square. V square minus u square is equals to 2as. Sn is equals to u plus a into n minus 1 by 2. Clear now? Same equations, how can you write in rotational motion? You can write omega is equals to omega naught plus alpha into t. Clear now? Next, instead of s, I can write theta. Theta is equals to omega naught t plus half alpha t square. Okay? Omega naught means initial angular velocity. Omega means final angular velocity. Clear? Similarly, v square minus u square is equal to 2as means omega square minus omega naught square is equals to 2 alpha theta. Clear? Similarly, Sn is equals to u plus a into n minus 1 by 2 means theta n is equals to omega naught plus alpha into n minus 1 by 2. That's it. These are the equations. Understood now? So same equations we have used in circular motion also, no? Here also exactly same equations. No change. Fine? That's it. Looking like a disc, no? So consider this is a disc only. Understood, no? So this disc is rotating with an angular velocity of omega. So from the center of the disc, I have drawn one line. So which becomes the radius of this disc. And on this radius, I have taken 3 points. So first point, second point, and third point. Okay, ma'am? Then after some time, what will happen after a time of t? Okay, ma'am? After a time of t, this point 3, let us consider it will reach up to here. Understood now? So therefore, let us consider that, okay, all these 3 points, they have reached up to here. Understood now? So this is point number 3. Okay. So where is point number 2? Point number 2 will be somewhere here. And this is point number 1. Okay, ma'am? So when this disc rotates, all these points, they will reach up to here. No? Understood now? So point 2 should have traveled in this path. Point 1 should have traveled in this path. Okay. Now in all these points, can you say some similarities and some dissimilarities? Theta is same, very good. Similarity is that all the points they have covered same angle, no? Correct only, no? So let us consider first particle covered 30 degrees. Second particle will cover how much angle? 30 degrees only. Third particle also will cover 30 degrees only. Understood, no? So whatever may be the distance of these points from the axis of rotation, all these points they have covered same angle. Okay, angle ne cover chesna kada. So therefore what I can say here, angle covered by particles is same. This is the similarity between them. Are you able to understand? Now can you say some dissimilarities? Distance traveled by the particles is different. How? Sima. First particle, it will travel only this much of distance, no? Correct only, no? First particle will travel very small distance. Second particle will cover a bit greater distance. Third particle will cover further very large distance. Are you able to understand? So distances covered are not same, they are different. So therefore what I say, distance covered by third particle is greater than distance covered by second particle is greater than distance covered by first particle. So this is one similarity. Angle covered is same. This is a dissimilarity. Distances are same. Time is also same, no? Time is also same, no? So what is the time taken by first particle? Same time taken is taken by second also. Same time is taken by third particle also. So therefore what I can say, time intervals are also same. Time intervals are same. Are you able to understand now? Now if you see here, angle covered by each particle is same, no? Time is same, no? Theta by time, omega is also same, no? Are you able to understand now? Every particle is covering same angle, no? And in same time. So therefore same angle, same time means omega value also same, because omega is nothing but d theta divided by dt, or delta theta divided by delta t. So therefore what I can say, okay, omega of first particle is equals to omega of second particle is equals to omega of third particle. Okay. So when a body is rotating, what is the point here we have understood by doing all this calculation? Listen very carefully. So when a body is rotating about any particular axis, angular velocity of every particle will be same. ప్రతి బాడీకి ఏది సేమ్ ఉంటుంది? Angular velocity will be same. Are you able to understand, ma? So consider this is the pen and I want to rotate this pen about this axis. Understood, no? then angle covered by every particle, this particle, this particle, this particle, this particle, this particle, angle covered by every particle will be same. Time taken also will be same, no? So therefore angular velocity also will be same. So every particle will cover same angle in same time. So that is the note point here we have to write. So therefore what is the note point I have to write? In rotational motion, clear ma? Every particle on the same body, will cover same, already we have written, nama? Every particle on the same body will have same angular velocity. Are you able to understand? So angular velocity of every particle will be same in rotational motion. So this is the most important point which you should remember. ప్రతి పార్టికల్కి ఒకే యాంగులర్ వెలాసిటీ ఉంటుంది, అంతే కదా. ఒక్కొక్క పార్టికల్ ఒక్కొక్క యాంగిల్ తిరగలేదు కదా. ఎవ్రీ బాడీ విల్ కవర్ సేమ్ యాంగిల్ ఇన్ సేమ్ టైం. సో యాంగులర్ వెలాసిటీ విల్ బి సేమ్ ఫర్ ఎవ్రీ పార్టికల్. అండర్స్టూడ్ అమ్మా? Now if I observe one point here, time taken by all the three particles is same, no? Time taken is same, no? Okay, time taken is same. But the first particle is covering less distance, second particle is covering a bit greater distance, third particle is covering still greater distance, but time taken is same. What do you understand? Huh? First arthamatunda, distances covered is not same, but time taken is same. What do you understand? Velocity is different. Velocities are different, no? I am traveling in a cycle with 2 km/h speed. Okay? Himanish is riding a cycle with a speed of 20 km/h. Who will cover more distance in same time? He will cover more distance. No, why? Because his velocity is greater. Understood, Nama? So time taken by all the three particles is same, but distances covered are different. So therefore this particle is having highest tangential velocity. Which velocity is highest, ma? Tangential velocity will be highest. So therefore we know what is meant by tangential velocity, no? Velocity in tangential direction is called tangential velocity. We studied in circular motion, no? So therefore I will say this is VT3, tangential velocity of third particle. Okay, ma? And what is this one? This is a tangential velocity of second particle. And what is this one? This is tangential velocity of first particle. Understood, no? This particle is covering greater distance, no, ma? Time taken is same. It means its velocity must be greater. So therefore I say tangential speed of third particle is greater than tangential speed of second particle is greater than tangential speed of first particle. Understood, no? Therefore what do you understand? Which body will have highest tangential speed, ma? The body which is at a large distance from the axis of rotation. Body which is at a large distance from the axis of rotation, that body will have highest tangential speed. Okay? This body, it has a very large distance from axis, no? So it will have highest tangential speed. Next tangential speed is followed by this one, next followed by this one. Understood? This is another important point which we should make a note. So therefore what is the note point we have to write? The point which is at a large distance, from axis of rotation will have highest tangential speed. Understood, Nama? Particle axis నుంచి ఎంత దూరం ఉంటే దాని tangential speed అంత ఎక్కువగా ఉంటుంది. Understood, no? That's it. Clear, Nama? Completed up to here? Shall I rub this? So these are the most important points which you should carefully understand in rotational dynamics. If you don't understand this one, then there is no logic in entering into this topic. అర్థమవుతుంది కదా, ఏబిసిడీలు రాకుండా ఇంజనీరింగ్లోకి వెళ్ళినట్లు అన్నమాట. ఏమి లాభం లేదు. ఈ బేసిక్ కాన్సెప్ట్ అర్థం కాకుండా మనం చాప్టర్లోకి ఎంటర్ కావడమే లాభం. క్లియర్ నో? దట్స్ ఇట్. ఓకే. So therefore, what are the terms which are same? What are the terms which are not same between 1, 2, 3 ma? Time taken is same. Angle covered is same. Angular velocity is same. Understood no? Distances are not same. Tangential speeds also they are not same. So these are the similarities and dissimilarities present between first point, second point and third point. Understood no? Okay. Now, what is the equation for tangential speed? Do you remember? What is the equation for tangential velocity or tangential speed? V tangential is equals to omega into r. Do you remember this one? V tangential is equals to omega into r. Gurtundi kada idi? Tangential speed depends on angular velocity and the distance of the point from the axis of rotation. R doesn't means only radius. R represents distance of that particular point from the axis of rotation. Okay ma? See ma, for all particles 1, 2, 3, omega is a constant no? ఇప్పుడే చదువుకున్నాం కదా. For all these particles which is a constant? Omega is a constant because they are covering same angle in same time. Okay. Because omega is a constant, can I say tangential speed is directly proportional to radius ma? Can I say? Tangential speed is directly proportional to radius. What is the meaning of that? Directly proportional to radius means? Same point here. If a particle is present at a large distance, then its tangential speed will be maximum. That's what we have proved with the help of equation also. No? Understood, Dama? Sima, this point is present at a lesser distance. R value is lesser. So its tangential speed also will be lesser. It is present at a greater distance, so its tangential speed will be greater. It is present at a further large distance, so its tangential speed will be further greater. Understood no? So V tangential is directly proportional to R. So in the form of an equation, how can I write? I can write Vt1 divided by Vt2 is equals to R1 divided by R2. So I can write like this also. Okay ma? In which condition, if omega is a constant, if bodies are rotating with same angular velocity, understood no ma? Then tangential speeds and radiuses I can relate like this. Vt1 by Vt2 is equals to R1 divided by R2. Clear no? That's it. Now whatever equations we use in kinematics, same equations again you can use in circular motion also, you can use in rotational dynamics also. If it is uniform motion, displacement is equal to velocity into time. Theta is equals to omega into t. If it is non-uniform motion, 4 equations. In rotational motion also, 4 equations. Clear no? That's it. Very simple topic. Equation for tangential speed no? Okay ma? For example, this is a body rotating about any axis. Understood no ma? Then, for example, if you take this point will have some tangential speed no ma? Speed in tangential direction. And if it is rotating with an angular velocity of omega and distance is r from the axis of rotation, then we know tangential speed is omega into r. Okay. Sima, if it is rotating with same angular velocity, if it means if it is in uniform rotational motion, then omega will be constant no? If it is rotating with same, Subara, ఇదే నీకు వచ్చింది చెప్పినప్పుడు వినాలి, అర్థం చేసుకోవడమే మన కాన్సెప్ట్, నోట్స్ రాయడము ఇది కాదు. ఓకేనా? వినండి, కేర్ఫుల్గా వినండి. ఇప్పుడు అర్థం కాకపోవచ్చు, వచ్చే సంవత్సరానికైనా అర్థమవుతుంది అనమాట. ఓకే, లిసన్ వెరీ కేర్ఫుల్. Sima. So Sima, omega, if it is rotating with same angular velocity, then omega is a constant, just like uniform motion. In uniform motion, velocity is a constant. No? Here angular velocity is a constant. So if omega is a constant, tangential speed also will be constant because V tangential is equal to omega into r. Omega is a constant, r is also a constant. Then tangential speed also will be constant. But if omega is not a constant, then it is non-uniform rotational motion. immediately alpha comes into action. Immediately ఏది action లోకి వస్తుంది? Alpha, angular acceleration. Just like in linear motion. In linear motion, if body is traveling with a different velocity, acceleration comes into action. Here angular acceleration comes into action. So therefore, if you differentiate this one with respect to time, dvt by dt, change in velocity by time is called what? Acceleration. So this is linear velocity, linear tangential velocity. This is linear acceleration. Understood now? Similarly, omega also is not a constant, but radius is a constant. Body is present at same distance, so r is a constant. So r you take out of differentiation. So r into d omega divided by dt. Change in velocity by time? Acceleration. Change in angular velocity by time? Angular acceleration, alpha. So A tangential is equals to r into alpha. So these equations already we have studied in circular motion. Once again we are studying. Clear now? Now same equations how can I write in vector form? Velocity and acceleration, they are vector quantities only. Clear now? So therefore V tangential is equals to omega dash cross r dash, and A tangential is equals to alpha dash cross r dash. Understood now? And theta, angular displacement, alpha, angular acceleration, omega, angular velocity, torque, angular momentum, all they are which vectors? They are axial vectors. It means they are present along which direction? They are present along the axis of rotation. Are you able to understand? Seema. So, open the window. So consider this is the axis of rotation, this pen, and this is a body which is rotating about this axis. Understood, Nama? Body is rotating like this about this pen. Then this is the rotating body and this is the axis of rotation. This is the axis only, no? Clear, no? So angular displacement will be along which direction? In the direction of axis. Clear, no? Alpha in the direction of axis. Omega in the direction of axis. Torque in the direction of axis. L also. Angle means angular momentum. That also will be present in the direction of axis only. That is why they are called which vectors? Axial vectors. They are present along the direction of axis. And how to see their directions of vectors? We have studied now by using a right hand rule for cross product. This is cross product only, no? So to find out the direction, what I have to do? A right hand rule for cross product. Okay, ma? Let us see. See, ma, consider this is the axis of rotation. Clear, no? And the body is rotating like this. Understood, no? It is rotating in this direction, like this. Now can you say tangential speed is in which direction? Is it present above the axis or on the upside or on the downside? Which side? Upside. How can you say? How can you say? ఎలా చెప్తారు? రైట్ హ్యాండ్ రూల్ ఫర్ క్రాస్ ప్రొడక్ట్ వెక్టర్స్ చదివాం కదా మనం. ఏం మాట్లాడుతున్నాం సార్? మేము అన్ని బట్టీనే కొడతాం, చదవమేమి. మళ్ళీ తగలయ్యా, చెప్పండి. ఒమేగా డాష్ క్రాస్ ఆర్ డాష్. ఆర్ ఏబుల్ టు అండర్స్టాండ్ నౌ? So therefore V tangential is equals to omega into r. If body is moving in this direction, tangential speed will be in this direction. Give one more pen. See ma, this is the body, rotating body. Understood now? Tangential speed will be in this direction. This is the direction of tangential speed, no? Understood now? If this should be the direction of Vt, what is the direction of radius vector? This is the direction of radius vector. From here to here. Tail will be here, head will be here. That is radius, no? Radius vector. So r dash is in this direction. V tangential is in this direction. So therefore, if you curl your fingers, thumb should be in which direction? Thumb should be in Vt direction. Okay? It means thumb should be like this. Are you able to understand, no? Because this is the direction of tangential speed, no? Are you able to understand? See. This is the axis of rotation and this is the rotating body. Are you able to understand, no? Body is rotating like this. It means the tangential speed is present inside the board, no? Tangential speed is in which direction? It is not present like this. It is present inside the board. Understood, no? Same concept I am explaining here also. So this is the axis of rotation. This is the rotating body. This is the rotating body. Understood, no? It is rotating like this. Then tangential speed will be in which direction? Tangential speed will be in this direction. If it rotates like this also rotates like this. Are you able to understand, ma? Okay. So therefore, if you do omega dash cross r dash, I should get Vt. Are you able to understand? If I do omega dash cross r dash, I should get Vt. Okay. Tangential speed direction I know, no? This is the direction of tangential speed. This is the direction. And this is the r direction. Okay. So place your right hand on first vector, rotate towards the second vector. Thumb gives the direction of resultant vector. That's what we studied in cross product. No? Place your right hand on first vector, rotate towards second vector. Thumb should give the direction of resultant vector. Now I know r dash direction, I know v direction. Then what is the direction of omega? Omega direction. It is possible only when, clear no? When I place my right hand like this. Clear no? This is the axis of rotation. I should place my right hand also in axis direction. This is the radius vector, no? Rotate towards the radius vector. Rotate towards the, are able to see? This is the axis of rotation. This is radius vector. Omega r. Omega dash cross r dash. What is the thumb direction? See the thumb direction. Tangential only, no? That is the direction of Vt. Understood, no? So therefore, theta, alpha, omega, torque, angular momentum, all of them, they are present on the axis of rotation. Okay? It may be in upward direction, it may be in downwards direction, but definitely on the axis itself. Understood, no? That is why they are called as axial vectors. Arthamaindi kada? Directions also very important, because questions may be given in vector form also. Without directions, you cannot do anything. Clear? Come on, make a note. Okay? So therefore, what I write? Directions can be calculated. Directions can be calculated by what? Calculated by right hand rule for cross product. RHRCP. Right hand rule for cross product. Understood, no? That's it.
Alpha by T naught.
Same. Let us see this question. కొంచెం తగ్గించు. Okay. So Seema. So a uniform rod of length L is rotating about its one end in the horizontal plane. Horizontal plane means how, for example, this is the rod. Rod is rotating like this. This is horizontal plane only, no? If it is rotating like this, it will become vertical plane. But it is rotating like this, horizontal plane. Understood, no? So where is its axis of rotation? The axis of rotation is present at one end of the rod. This is the axis of rotation. How can I say this is the axis of rotation? Around this axis, this rod is rotating. Understood, no? So under constant acceleration alpha, angular acceleration is given as alpha from rest position. It means initial angular velocity is how much, ma? 0. Initial angular velocity is 0. Initial tangential speed also 0. Initial tangential velocity, angular velocity also will be 0. It means it is starting from rest position. That is the meaning of this. Omega naught.
Initial and
okay. Initial angular velocity is 0. Okay, ma? So find its linear velocity at the midpoint after a time t0. What is the length of the rod, ma? Length of the rod is given as L. Okay. Then the midpoint means somewhere here, no? So its length will be how much? Its length will be L by 2. So at this point, what I want to find out? I want to find out linear velocity after a time of t0. Okay. So after time t0, I want to find out tangential velocity also. And also I want to find out tangential acceleration also. Similarly, I want to find out normal acceleration, or you can call it as centripetal acceleration, or you can call it as radial acceleration also. Okay, ma? This is the given question. So these three values I am supposed to calculate. Okay. Rod is starting from rest position. Understood, no? But it has some angular acceleration. What is the angular acceleration? Alpha. I want to calculate these values where, for which point? For a point which is present at the midpoint of the rod. Understood, no? Okay, now see. So first, V tangential is equals to omega into r. So what is the r value of this point, ma? R means the distance of the point from the axis of rotation. This is the axis of rotation, no? This point is present at how much distance? L by 2 distance. So I know that r value is equals to L by 2. Clear, no? But angular velocity, do I know? Initial angular velocity is 0. Initial angular velocity is 0 because it is starting from rest position. But it has angular acceleration, no? So therefore after some time body will get some angular velocity. Just like linear motion, compare this one with a linear motion. Body is starting from rest position. Sunna to main. Body is starting from rest position. Are you able to understand? It has some a value, acceleration is there. Therefore after some time body will get some final velocity, no? Initial velocity is 0, but if acceleration is there, what happens to velocity? Velocity continuously increases. Then after some time body will have some velocity. Same concept here also. Initial angular velocity is 0, but there will be some final angular velocity, no? How can I calculate? First of all, is it uniform motion or non-uniform motion? Non-uniform. How can you say non-uniform? Because alpha is there, no? Alpha on the kabatti, non-uniform. So therefore, which relation I can use? I can use V is equals to U plus AT, no? Because after a time of t naught, I want to find out velocity. I can use V is equals to U plus AT. What is the analogous equation of this one in rotational motion? Omega is equals to omega naught plus alpha into t. This is the analogous equation. Understood, no? So therefore omega is equals to omega naught is 0, alpha value is alpha only, and what is the time taken? Time taken is t naught. So final angular velocity is alpha into t naught. That's all, no? Okay, no? It means after a time of t naught, this total rod will be rotating with how much angular velocity? With an angular velocity of alpha into t naught. And we studied that every point will have same angular velocity, no? In rotational motion, what are the similar points? Every point on the rod will have same angular velocity. Chavinanga already. Alpha values are same, omega values are same, angle covered is same, time taken also is same. So every point will have same angular velocity. Okay. So once I know angular velocity, now just substitute in this equation. So V tangential is equals to omega into r. Omega value is how much? Alpha t naught multiplied by radius is how much, ma? L by 2. Clear, no? So therefore what is the answer I got? Alpha L t naught divided by 2. So this is my tangential speed of which point? Tangential speed of midpoint of the rod. After how much time? After a time of t naught. That's very simple. Understood, Nama? So this is the equation I have used. R value I know L by 2, but omega I don't know. No? Omega value is continuously changing because rod is accelerating. Okay? So I have calculated by using kinematics and I have done the calculation. Okay? Next, what he is asking, tangential acceleration. What is the equation for tangential acceleration? A tangential is equals to alpha into r. We have this direct formula, no? A tangential is equals to alpha into r. What is alpha value? Alpha value is alpha only. And what is the distance of that point? L by 2. So alpha into L by 2. So alpha L by 2 is the tangential acceleration of that point. That's all. Understood, Nama? Now what is the third point he is asking? Normal acceleration, or you can call it a centripetal acceleration. Okay. So what is the equation for centripetal acceleration, ma? We have two formulae, omega square into r also I have, and v square by vt square by r also I have. Two equations are there, no? For centripetal acceleration. You can use omega square by r also, omega square into r also, or vt square by r also. Circular motion gurtunda? Okay. So therefore, centripetal acceleration. Omega value how much? Omega value already we have calculated, no? So alpha square t naught square multiplied by L by 2. That's all. So this is my equation for centripetal acceleration. Calculated all the three. Understood, Doma, how we are doing? So we are taking the help of kinematics also, because rotational motion and circular motion, they are just analogous to kinematics. Equations of motion in one dimension. Understood, no? That's it. Okay, ma? So directions also we can study, ma. What is the direction of centripetal acceleration? For example, if you take any point here, centripetal acceleration will be towards the center of the circle. This is the direction of centripetal acceleration. Understood, no? or you can call normal acceleration, or you can call it as radial acceleration also. Normal acceleration will be in which direction? Where is that? No, tangential acceleration will be in which direction? So this point, it is moving in a circular path, no? This point is moving in a circular path. So tangent to that side. So this is the direction of tangential acceleration. For example, if he asks what is the total acceleration experienced by this point, then what you will do? That's all. Clear now? For example, if this is the rod rotating about this axis, and this is the point which we are studying now. So centripetal acceleration will be in this direction, tangential acceleration will be in this direction. Then total acceleration experienced is how much? This is the total acceleration, no? A. Clear now? And angle is 90 degrees, no? So therefore, what is the total acceleration? A is equals to square root of AT square plus AC square. AT already I have calculated, no? AC also calculated, no? Just substitute here. Then I will get total acceleration experienced by that point. Understood? That's it. Okay, ma? So, this is the given question. So, angular position of a swinging door is described by this equation. Okay. So here I can say angular position means what? The angle covered by the particle. So angle covered by this door, it is dependent on time. No? It means if time is changing, this angle is also changing. Clear? No? Then you are supposed to determine the angular position, angular speed and angular acceleration at t is equal to 2 seconds. So first of all, angular position. Okay. Angular position means what? Just angle covered by the particle. How much angle the particle is covering, that is nothing but angular position. So how can I calculate? Just substitute t is equal to 2 seconds. So 5 plus 10t plus 20t square. Clear now? So 5 plus 10 into t value 2 seconds, 20 into 2 square. So how much it is? 5 plus 20 plus 4 2s are 80. So total how much? 105 radians. Clear? So this is the angle covered by the particle or angle covered by this swinging door. So it is covering how much angle? 105 radians in how much time? In a time of 2 seconds. That's it. No? Similarly, next is asking about angular speed. Angular speed. What is meant by angular speed? Omega, no? So omega value how can I calculate? Omega is equals to, we know it is d theta divided by dt. This is the equation of angular speed, no? So just differentiate this one. So therefore d by dt of, what is the theta value which is given? 5 plus 10t plus 20t square. Okay. Differentiation of 5? 0. 5 is a constant number, its differentiation is 0. Differentiation of 10t? 10. Differentiation of 20t square? 20 into 2 t power 2 minus 1. This is am I right now? Differentiation of x power n is n into x power n minus 1. Clear now? Now do this calculation. So it is a 10 plus 40t. That's all now. So this is the angular velocity equation. But he is asking us to find out angular velocity at t is equal to 2 seconds. So substitute 2 there. So omega is equals to 10 plus 40 into 2. So how much? 90. 90 radians per second. That is the angular speed which I got. Okay. Then he is asking us to find out angular acceleration also. No? So how can I calculate angular acceleration? Angular acceleration nothing but alpha, no? So how can I calculate alpha value? Alpha is again differentiation of angular velocity with respect to time, d omega divided by dt. So this is a displacement, velocity, acceleration. Angular displacement, angular velocity, angular acceleration. That's all. So omega value already I have now. What is the omega equation I got? 10 plus 40t. Clear now? So 0 plus the differentiation of 40t will become 40. So alpha is equals to 40 radians per second square. Okay. So we know the unit of displacement, no, it is meters. In angular motion it is radians. Clear now? For velocity it is meters per second. In angular motion it is radians per second. In linear motion acceleration is meters per second square. Here it is radians per second square. That's it. Understood now? Just like a linear. So see here. So a solid body is starting rotation about a stationary axis. Any body, any regular body or irregular body. Okay ma? So consider any disk, ring, anything. So it is rotating about this axis of rotation. Are you able to understand? So with varying angular velocity, because acceleration is there, no, angular velocity will be continuously changing. Okay. So with an angular acceleration, alpha value is how much given? Alpha value is equal to k into t. It means if time is changing, angular acceleration also is changing. So this is not uniform motion. Similarly, this is not a linearly accelerated motion also. Because alpha, is it a constant? Acceleration, is it a constant? If it is a constant acceleration, we can say it is uniformly accelerated body. But alpha value is also changing. No? So it is a non-uniformly accelerated body. Definitely accelerated body. Are you able to understand? Accelerated motion. Uniformly accelerated or non-uniformly accelerated? Non-uniformly accelerated, because alpha value is also changing with respect to time. Are you able to understand? Then what he is asking, how soon after the beginning of the motion will the total acceleration vector of any point or any arbitrary point form an angle 60 degrees with the velocity vector? What is meant by velocity vector? Velocity vector means tangential velocity. No? This is called velocity vector. For example, if you take this point will have two accelerations. Already we studied in circular motion. No? One acceleration is it will have centripetal acceleration, and one more acceleration is it will have tangential acceleration also. Two accelerations are present. Are you able to understand? No? So body will have two accelerations. Then what is meant by total acceleration? Total acceleration means what? Total acceleration means resultant of these two accelerations, centripetal acceleration as well as tangential acceleration. Clear now? So if you take the resultant of centripetal and tangential, then we can say this is the net acceleration. This is the total acceleration, A. And how can I calculate A value? A is equals to square root of AC square plus AT square. Already we studied many times now. Total acceleration is square root of AC square plus AT square. Now this is the net acceleration. So this net acceleration should make how much angle? It should make an angle of 60 degrees. That's the meaning of this one now. So this acceleration, it should make an angle of 60 degrees. So angle between total acceleration and velocity vector. Okay, ma? Then what is that time taken that I want to calculate? Time only now he is asking. How soon? It means what is the instant of time at which the angle between acceleration and velocity vector is 60 degrees. That is the question. Are you able to understand? Arthamavutundi kada, or shall I draw a bigger diagram? Clear ma? So this is velocity vector, this is centripetal acceleration, and this is tangential acceleration. Clear na ma? This is the total acceleration, net acceleration. So angle between net acceleration and velocity vector should be how much? 60 degrees. So for that thing to happen, what is the time taken that I want to calculate? Understood now? So what is the equation of centripetal acceleration ma? Centripetal acceleration. Centripetal acceleration is omega square into r, or you can write v square divided by r. These are the two equations of centripetal acceleration. Tangential acceleration, we can write dvt divided by dt, how tangential speed is changing with respect to time. Or also you can write alpha into r also. These are the two equations. These equations you should by heart now. You should learn them very carefully. Okay. So these are the two equations which I have. Are you able to understand? But omega value, is it given? No. Tangential speed, is it given? No. Alpha, is it given? Alpha is given. Clear no? But omega is not given, V also not given. So what can I do? What can I do? So from alpha value, can't you find out omega value? Ma? How can you find out? So already we have a relation, no? What is the relation? What is alpha? Alpha is equals to d omega divided by dt. Change in angular velocity by time is called as alpha. Clear? No? So from alpha I want omega. So therefore what I will do? So it is changing with respect to time only, no? So I have written with respect to time. So therefore k into t is equals to d omega divided by dt. So therefore d omega is equals to kt into dt. I can write like this now. If I want omega, what I have to do? Integrate on both sides. If you integrate on both sides, then what I will get? Integration and differentiation will get cancelled. So therefore omega is equals to integration of kt with respect to dt. Omega k is a constant number, take it out of integration. So integration of t dt. Integration of t dt is how much? T square by 2. That's all. No? So I calculated omega value. No? So what is omega value? Kt square divided by 2. So once I calculate omega value, now I can calculate a centripetal acceleration. No? Similarly, if I know centripetal acceleration, at also I can calculate number because alpha value already it is present. Are you able to understand? Now substitute. So therefore, so centripetal acceleration is how much? Omega square into r. Omega value kt square by 2 whole square multiplied by r. Clear number? So therefore k square t power 4 divided by 4 multiplied by r. This is centripetal acceleration. Similarly, tangential acceleration is alpha into r. Alpha value k into t. So k into t multiplied by r. Are you able to understand? Then what is the total acceleration? Total acceleration a is equals to square root of ac square plus at square. So a is equals to square root of centripetal acceleration is how much more? So k square t power 4 divided by 4 into r whole square. Okay, plus at square. At is kt into r whole square. Clear no? So this is the total acceleration. Are you able to understand? So therefore we will try to simplify this one. Then what he is asking, what will be the total acceleration angle between so see now. So this is the 60 degrees which he is asking, no? Are you able to understand? No? Now this 60 degrees is the angle between what? This is the angle between total acceleration, velocity vector as well as tangential acceleration also. If this is AC, this is also AC, no? If this is AC, this is also AC. According to which rule? Parallelogram rule of addition. Are you able to understand? So if you want to tan 60, just you can do one thing, no? Without calculating all this value, can you take AC divided by 80? Definitely I can take AC divided by 80. This is a right angle triangle. Opposite side divided by adjacent side. So AC divided by 80. What is the centripetal acceleration? What is that? Centripetal acceleration. So it is k square t power 4 into r divided by 4 divided by tangential acceleration is kt into r. Now what are the terms which can get cancelled? So r and r get cancelled. Tan 60 value is root 3 number. So root 3 is equals to k and square also get cancelled. T and here I will get cube. So k t cube divided by 4. That's all, no? This is the value which I can get. So therefore t cube value is how much more? T cube value is 4 root 3 divided by k. So therefore t value is cube root of 4 root 3 divided by k. That's all. 4 root 3 divided by k. So in that time, definitely I can say the angle between total acceleration and velocity vector will be how much? 60 degrees. Understood now? That's all. Like serious question. So a solid body starts rotating about a stationary axis with an angular acceleration alpha is equals to alpha naught into cos theta. Okay, this alpha naught you can take it as a constant, and so here one thing you can see now, if theta changes, alpha also changes. That's all. So angular acceleration is dependent on what? Theta. Displacement, angular displacement. Theta is angular displacement only. Okay. Then find angular velocity of the particle as a function of theta. Omega value we are supposed to calculate. Now let us study about linear motion. In linear motion, okay, we have acceleration. In straight line motion we have acceleration. And what is acceleration? dv divided by dt, change in velocity by time. We have one more equation for acceleration. No, what is that one? v dv divided by dx. This also we have. Two equations ఉన్నాయి కదా acceleration. We use this equation in which condition and we use this equation in which condition? We use this one when velocity is changing with respect to time. And this relation when velocity is changing with respect to position, displacement of the particle. Time తో పాటు velocity మారుతూ ఉంటే ఈ equation. If velocity is changing with respect to displacement, then we use this equation. Already we studied. Similarly, same equations, how can I write in rotational motion? In rotational motion, how can I write? Instead of A, what I can write? Chapali, alpha. Clear, no? D, instead of V, omega. Divided by dt. Clear, no? Similarly, second equation, again instead of A, alpha. So instead of V, omega. dv, d omega. dx, d theta. That's it. Clear, no? Ante kada. So this is a displacement, this is angular displacement. Are you able to understand? Now this equation we are supposed to use, this equation we are not supposed to use. Because if you see in the equation, alpha is dependent on theta. It is not dependent on time. Okay? Now use the relation. So therefore I will use alpha is equals to omega d omega divided by d theta. I want omega only, no? So alpha into d theta is equals to omega into d omega. Okay. So integrate on both sides. So integration of alpha value is how much more? A naught into cos theta into d theta is equals to integration of omega into d omega. Understood? So therefore A naught is a constant. Take it out of integration. So integration of cos theta is sin theta. Clear, no? So sin theta is equals to, and A naught also we have, no? Alpha naught to sin theta is equals to integration of omega square divided by 2. That's all, no? And he is asking omega value only, no? So omega square is equals to 2 alpha naught sin theta. So omega is equals to plus or minus square root of 2 alpha naught into sin theta. That's all. That is my answer. Okay. So answer may be plus also, answer may be minus also. Because minus 2 into minus 2 plus 2. Plus 2 into plus 2 also, plus 2. Are you able to understand? So plus root 2a naught into root 2a naught sin theta, again you will get this value. Minus value also will give same value. No? So answer may be plus also, answer may be minus also. That's it. Very simple. So point is that which equation you are selecting, that is very important. So here in this equation, alpha is not depending on time, no? So this equation you cannot use. Alpha is dependent on displacement, angular displacement. So this value and this values only you are supposed to use. Clear? That's it. So the next topic in rotational dynamics is torque. What is meant by torque? It is the effect of rotation. Effect of rotation. Or you can say it is the cause of rotation also. Okay, ma? So a body will start rotation or a body will stop rotation only because of torque. Understood, no? Sima, consider this is a body of mass m. Vinali, chala careful ga vinali. This is a body of mass m. On this body, if I apply some force, then what will happen? ఏమవుతుంది? మూడో తరగతి లెక్కలు కాకుండా ఇంటర్మీడియట్లో ఏం చెప్పాలో చెప్పండి. If I apply force on a body, what will happen? Body will accelerate. Body will accelerate according to Newton's second law. We know A is equals to F by m, no? So this is the acceleration which is produced in the body. It means its velocity starts increasing continuously. Are you able to understand, ma? So therefore, what force will do? Force can accelerate a body. Similarly, if body is moving in one direction, if I apply force in opposite direction, then body can stop also. Clear number? So force can start a body, force can stop a body also. This is about the function of force. Clear no? Similarly, this is in linear motion. This is in linear motion. Okay, no? So what can I do right here? Force can accelerate a body. Force can accelerate the body. Clear number? Similarly, for example, if I take a rotating body and this is the axis of rotation. Okay, ma? So this body I want to rotate about this axis. Okay. Then what I do is, if I apply force in this direction, then this body starts rotation. No, ma? This is consider this is a disc which is rotating about this axis. Clear? No? If I apply force on this body, then this body starts rotation. Starts rotation means definitely alpha value should be present. No? Clear number? Angular acceleration must be present, because initially its angular velocity was 0. Initially body was not rotating, its angular velocity was 0. It was not covering any angle. But once I start applying force on this body, the speed of the body increases, the angular velocity increases, tangential velocity also increases. Are you able to understand? Ma? And from the axis of rotation, I am applying force at what distance? I am applying at a perpendicular distance of r. What is this r, ma? R is the perpendicular distance from the axis of rotation to the point of application of force. Are you able to understand? Then I write torque is equals to R into F. Are you able to understand? Ma? Torque is equals to R into F. Now what is the use of this torque? What is the use of this torque, ma? Torque is responsible for rotating this body, or torque is responsible for producing angular acceleration. Angular velocity perugutu veltundi kada dindi. Are you able to understand, ma? So initially it covers only 10 degrees. Second it will cover 22 degrees. Third second it will cover 24 degrees. So it means alpha value is present. Okay. So what a torque will do? Torque produces angular acceleration in rotational motion. What a force will do? Force will produce linear motion. Linear acceleration. Torque produces angular acceleration. But what is the formula of torque? R into F. In which condition? When this angle is equals to 90 degrees. What is this angle, ma? Angle between radius vector and force. If it is 90 degrees, then the equation of torque is R into F. అర్థమవుతుందా టార్క్ ఏం చేస్తుందో? ఫోర్స్ ప్రొడ్యూసెస్ లీనియర్ యాక్సిలరేషన్, టార్క్ ప్రొడ్యూసెస్ యాంగులర్ యాక్సిలరేషన్. Able to understand, ma? So if torque is greater, angular acceleration also will be greater. If force is greater, acceleration is greater, no? Same concept. Are you able to understand? You apply more torque, the angular acceleration of the body also will be very large. Okay. So therefore what I write? Therefore I will write torque produces angular acceleration. Angular acceleration. Are you able to understand? So torque is dependent on how many quantities, ma? It is dependent on R also, it is dependent on F also. Okay. It means if radius vector increases, torque also increases. Are you able to understand? Let us try to understand one example. So consider this is a door. Okay, ma? Consider this is a door. So we have fixed the door, no? Okay, ma? To this axis of rotation. By using these clamps, we have fixed this door. Now I want to open this door. I want to open this door. So door will rotate only, no? If I apply force on the door, will it move in a straight line or will it rotate? It will rotate, no, ma? So where is it better to apply the force to open that particular door? Where it is easier to open this door, to make this door to rotate? For example, let us take 2 points. I will take first point at the middle of the door. I will take second point at the end of the door. Are you able to understand? Where it is easier to open this door? By applying very less force. Second point. Why? Because if you take this second point, this is the axis of rotation, no? About this axis only door will rotate. For example, if this is the door, this is the axis. So it is rotating about which axis? It is rotating about this axis. Clear, no? So from the axis of rotation, it is present at a very large distance. Which point? Second point. So its distance is r1. What about for the point number 1? Its distance is only r2 and r1 is greater than r2. Okay. So if radius vector increases, automatically torque also increases. Are you able to understand? So door madhyalo మీరు force apply చేసినారు అనుకోండి, మీరు ఎక్కువ force apply చేయాలి. Okay. But if you apply the same force at the end of the door with very less force, you can open that door. Are you able to understand, ma? So torque depends on force also, it depends on radius vector also. Is it clear? So therefore what I write? Therefore it is easier to open the door, clear, ma? If force is applied, at a large distance, from axis of rotation. Are you able to understand, ma? So this is one very important point about torque. Okay, come on, make a note up to here. అర్థమవుతా ఉంది కదా? Pull in real life. చెప్పండి. Sima, you should have seen tires of a bus, no? And nuts will be present to the bus, to the tires of the bus. Nuts will be there, no? Nuts ఉంటాయి కదా, and they will be very big in size, and because of friction they will be very tightly attached to those nuts. Are you able to understand? బోల్టాలు ఉంటాయి కదా టైర్కి. See, if you want to open these bolts with your hand, is it possible? లారీ టైర్ కాడ పోయి దాన్ని పట్టుకొని తిప్పే ప్రయత్నం చేయండి. జయంతి తప్ప ఎవరు ఓపెన్ చేయలేరు అన్నమాట. ఓకే. సో టు ఓపెన్ దిస్ బోల్ట్స్ వాట్ వీఆర్ సపోజ్ టు డూ, చూసినారు ఎప్పుడన్నా టైర్ పంచర్ అయినప్పుడు బస్సు టైరు, వాట్ దే విల్ డూ ఈజ్, so they will place some arrangement like this and a very long rod will be present. Okay ma? దాన్ని ఏమంటాం భాస్కర్ మనం? స్క్రూ డ్రైవర్ కాదు కదా, అదేంటది? స్క్రూ డ్రైవర్. క్లియర్ అమ్మా? సో a type of screwdriver will be placed and length of the rod will be very large. Okay ma? So the bus driver or conductor, he will start jumping on this rod. Then you can see that you can open this bolt. Okay. But if the person starts here and starts jumping, he can never open this one. He will start at a very large distance. Here he will stand on the rod and he starts jumping. You should have seen this scenes, no? When your bus or tire or car is punctured. Clear, no? So can you say why he is standing at the edge of this rod? This bolt is rotating about this axis, no? Bolt is rotating about this axis of rotation. Okay. And if man is standing here, it means a force is applied at a very large distance. No? So from the axis of rotation, what is this distance? This distance is r. Understood? No? If radius vector is very large, automatically torque also will be very large. So with very little force, you can open this, what you call this bolt. Are you able to understand, ma? Because the equation of torque is r into f. Okay. So we too have bolts, no? We use always a screwdriver to close the bolt. What is the reason? Because the length of the screwdriver will be very large. If length increases, R value increases. Once R value increases, very easily you can close and open the bolts. That is the application of torque. Understood, Nama? That's it. Now see, ma'am. So if this is the axis of rotation and if body is rotating here, consider this is a point mass. Okay, ma? It is rotating around this axis and we are applying this force F. Okay, and this is the radius vector R. Are you able to understand? Now radius vector and force both are vector quantities, no ma? So radius vector I will indicate by this arrow here. So angle between force and radius vector, if it is 90 degrees. Now the question is where I have to take 90 degrees? 90 degrees ekkada teesukovali? See, now force is not present in the plane of this board. Force is inside the board because body is rotating like this, no? Are you able to understand? This is the rotating body. We are applying force like this. Ila apply chestam. Okay. But here how it is shown? It is shown like this. Force is not shown like this. Force is inside the body. Then this force can rotate this body. Are you able to understand? So what is the angle between force and radius vector? Where can I indicate? How can I indicate? రెండు వెక్టర్స్ మధ్యన యాంగిల్ ఎక్కడ తీసుకోవాలి? Between two tails only. I cannot take angle between one tail and one head. So what I have to do? So displace this radius vector forward. Clear no? Now here we have two tails. No? Here you can say this angle should be how much? 90 degrees. If this is 90, definitely this angle also will be 90. In this condition, what is the formula of torque? Torque is equal to R into F. Okay, ma? In which condition? When angle between radius vector and force is 90 degrees, then you can say torque is equal to R into F. Okay. So instead of applying force at an angle of 90 degrees, what I will do is, I will apply force at another angle. Clear, ma? Now, so this is the body which is rotating about this axis, and a radius vector is R, but I am applying force in this direction. Okay. Now angle is definitely not 90 degrees, no, ma? So what I have to do? What I have to do? So angle between radius vector and force, is it 90 degrees? No. Then can I apply this equation of torque? No. This equation of torque I cannot apply. So what I have to do? Split this force into two components. Clear, no? For example, if this angle theta is given, clear, no? Then split this force into two components. Clear? This is F cos theta and this is F sin theta. Again, which two vectors I am supposed to take? I am supposed to take a radius vector and F sin theta, not F cos theta. Because we are supposed to take only those vectors which are perpendicular to each other. Are you able to understand? So in this condition, torque will be how much? R into F sin theta. This is the radius vector. Are you able to understand? And if this is R dash, this is also R dash only, no? So angle between R dash and F is how much? Theta. So torque is equals to RF sin theta. So this is the general relation which you can do. And this relation you can use for any angle. So it is better you remember this one instead of this one. Understood, no? This is the equation you can apply for any angle, 0, 90, any angle. Are you able to understand? So torque is equal to RF sin theta. See, not only force, you can split radius vector also. Again the formula remains same. So all those applications are not necessary, just you remember this equation. And what is theta here? Theta is the angle between R and F. Angle between radius vector and force is theta, then torque equation is RF sin theta. Are you able to understand? Same. Now what I will do is, I will take a pendulum. This is a pendulum. Okay. So here at this point I am applying a force of 10 Newton. Clear? And length of this pendulum is 1 meter. Now can you say what is the torque acting on this pendulum? Anybody? Only intelligent students only can answer.
0.
Why 0? Angle between force and radius vector is 0. So torque is 0. Very good. Sima, if you are applying force here, you are pulling this pendulum, no? Are you making this pendulum to rotate? Then how torque is present here? Torque is 0 here. Force avani pakkana pettukunnam first. Here you are pulling the pendulum, no? Ekku force apply cheste pendulum tegutundi gaani rotate aithe avvadu. So in this condition, torque acting is how much? 0. Are you able to understand? So in terms of angle, how can you say? In terms of angle, you can say angle between radius vector. Radius vector will be in this direction, no? And force also is in the same direction. So angle between both of them is how much? 0. Sin 0? 0. So total torque acting is 0. So every force cannot produce torque. Able to understand, ma? Every force cannot produce torque. force should be such that there should be one component perpendicular to the radius vector. Then only torque can be produced. Understand? See, for example, this is the pendulum. If I am applying force like this, are you able to understand now? Now, can this force, can it produce torque? This force, can it produce torque or not? Definitely it can produce torque. How can you say it can produce torque? Because this is the radius vector, no ma? So take this radius vector here also. Now angle is theta, no? So split this force into two components. Okay? So this is F cos theta and this is F sin theta. F cos theta cannot produce torque. F cos theta cannot produce torque because F cos theta is pulling the pendulum downwards. But F sin theta can produce torque. This F sin theta I can draw here also, no? Are you able to understand? F sin theta is making the pendulum to rotate. So definitely this force can produce torque. It means at least there should be some component perpendicular to radius vector. Which is the component perpendicular to radius vector? F cos theta or F sin theta? F sin theta. So this force can produce torque. Understood, no? So therefore, what is the note point I have to write? Note point is that at least a small component, perpendicular to radius vector, if is present, then torque can be produced. Otherwise you cannot produce torque. Understood, Nama? కనీసం ఒక చిన్న కాంపోనెంట్ అన్న రేడియస్ వెక్టర్కి పర్పెండికులర్గా ఉండాలి. Then only you can produce torque. Is it clear? Now see. Now let us see one more important. So write all these points very, very carefully. Whatever I write on the board, you should be writing in the notes also. Okay? Now see. So consider this is a rod. Are you able to understand? Or instead of rod, I will take a disc. Consider this is a disc. This is the axis of rotation. Understood now? Now here if I apply force, will this disc will it rotate or not? ఇక్కడ ఫోర్స్ అప్లై చేస్తే రొటేట్ అవుతుంది. ఇక్కడ చూడండి సుబ్బారావు, అక్కడ కాదు. ఇఫ్ ఐ అప్లై ఫోర్స్ హియర్ అండ్ దిస్ ఇస్ ద రేడియస్ వెక్టర్ ఆర్ డాష్, టార్క్ విల్ ఇట్ బి ప్రొడ్యూస్ ఆర్ నాట్? దిస్ ఇస్ ద యాక్సిస్ ఆఫ్ రొటేషన్. చెప్పాలి. Definitely not with this disc will rotate, no? Okay. Same force if I apply here, what will happen? Here I am applying a force of 10 Newton for example. Same 10 Newton if I apply here, will the rod rotate or not? Definitely rod will rotate because there is some perpendicular distance from the axis of rotation, no? So here torque produced, let it be tau 1, here torque produced, let it be tau 2. Which torque will be greater? Tau 1 will be greater than tau 2 because force is same, 10 Newtons only. But radius vector is lesser, no? So torque will be lesser. Okay, ma? So tau 1 will be always greater than tau 2. Is it clear? Now see. Now what I am doing is, I am applying force on the axis of rotation itself. Now where I am applying force, I am applying same force of 10 Newton on the axis itself. Now will this disc, will it rotate or not? This disc cannot rotate. Why? So from the axis of rotation, perpendicular distance is 0, no? Are you able to understand? No? Because we are applying force where? We are applying force on the axis itself. So from the axis R value is how much? 0. If R is 0, torque cannot rotate. Sorry, this disc cannot rotate. Are you able to understand? So if you are applying force on the axis itself, then body cannot rotate. Torque cannot be produced. Are you able to understand? No? Clear now what is happening here? So this is the axis of rotation. We are applying force on the axis itself. Then R value is how much? 0. There is no perpendicular distance. Okay, ma? But if I am applying force here, then there is some perpendicular distance. But if you apply here, R value is 0. So in that condition, torque will be how much? Torque also will be 0. Are you able to understand what is happening? Clear now? So therefore, what is the second note point I have to write? Second note point is that, okay ma? So if force is applied on the axis of rotation, then torque cannot be produced. Are you able to understand? See, but this is also one such example only, no? This point also same example, no? Where we are applying force is directly acting on the axis itself. This is a pendulum, no? Pendulum is rotating about this axis, no? This is the axis of rotation. Understood? Where we are applying force directly on the axis itself, then can the body rotate? Body cannot rotate. That's it. So these are the points which you should rotate about, which you should remember about torque. Clear, no? Okay. So direction of torque. This is also very important. What is the direction of torque? Torque is a vector quantity. Torque is a vector quantity. Okay. So torque is an axial vector. Okay. In vector form, how we write? We write tau dash is equals to r dash cross f dash. This is the equation to calculate the direction of torque. Torque is equals to r dash cross f dash. Understood now? Now see. For example, consider this is a disc and we are applying force like this, and this is the radius vector. This is the axis of rotation. Understood now? Now in this condition, can you say what is the direction of torque? It is perpendicular and out of the board. How can you say? Right hand rule for cross product. Place your right hand on first vector. Right hand rule for cross product gudutundi kada. Place your right hand on first vector. Which is the second vector? F dash. Rotate towards the second vector. What is the direction of thumb? Perpendicular and outside the board. And that is the direction of axis also, no? Clear now? That is why torque is called a axial vector. So therefore we write here torque is perpendicular and out of board. Okay, ma? For example, if I give one more condition, see, ma, force is applied like this, and this is the radius vector, this is the axis of rotation. Now in this condition, can you say what is the direction of torque? R dash cross F dash. That's all. R dash cross F dash. What is the direction of thumb? Perpendicular and inside the board. Clear now? So here torque is perpendicular and inside the board. Understood now? So this is the basic discussion about torque. Okay. Now it is clear now. Torque will be present in which condition, absent will be in which condition, and how to measure torque. So always you have to take a radius vector and force which are perpendicular only. Elagaina split cheyandi mee ishtam. However you want to split, you can split. But which two components I have to take? Only those two components which are perpendicular to each other. Then you will get torque. Clear now? Okay. Okay. Completed. ప్రతి డయాగ్రాము క్లియర్గా వేసుకోండి. ఇక్కడ ఏ చెత్త వేసినా ఆ చెత్త అంతా మీ చెత్త బుక్కుల్లో కూడా ఉండాలన్నమాట. చెత్తేసే చెత్త బుక్కే కదా, అర్థమవుతుంది కదా. అదర్వైజ్ యూ కెనాట్ అండర్స్టాండ్ వాట్ ఈస్ హ్యాపనింగ్. Okay, now see. So analogy of Newton's second law in rotational dynamics. Okay, ma? Analogy of Newton's second law in rotational dynamics. Okay. See, ma, Newton's second law, F is equal to ma. This is the equation of Newton's second law, no ma? F is equal to ma. And this equation we use in which condition? In linear motion. Force is applied on a body, force produces acceleration, and F is net force minus. Net force produces acceleration on a body. Clear, no? So the analogy of same Newton's second law in rotational motion, how can I write? Instead of force, I can write a torque. Okay, ma? Because force produces linear acceleration, torque produces angular acceleration. They are analogous to each other, no? They are comparable to each other. Okay, ma? Similarly, mass. Mass is the reason of inertia, no? Mass ekku unte inertia kuda ekkuga. So if mass is comparable to moment of inertia in rotational motion, mass in linear motion, moment of inertia in rotational motion. If moment of inertia of a body is greater, you cannot easily rotate a body, you cannot easily stop a rotating body also. Clear, no? So A means acceleration. In angular motion, instead of A, I will write alpha. So this is an equation of torque, another equation of torque, in which condition? In rotational dynamics. Understood, Nama? So there is some derivation also. We are not going towards the derivation. Just we are trying to understand this one with the help of analogy. Okay, ma? Even comparable values say kada? Force comparable to torque, mass comparable to moment of inertia, acceleration comparable to alpha. So torque is equal to I into alpha. So therefore totally how many equations of torque are there? Torque is equal to R into F. This is one formula. Another formula is I into alpha. This is one more formula. Okay, ma? But R into F in which condition we can use, ma? That you should not forget. Only when angle between R and F is 90 degrees. If it is other than 90 degrees, you have to write RF sin theta. Okay, where theta is the angle between R and F. Fine? That's it. So, now see. So the next topic in torque is couple. Couple, we know couple means two. Okay. So two equal and opposite forces producing torque in same direction is called as couple. Understand, no? Seema. For example, for opening a cap of a bottle. This is a cap of a bottle, no? So how we apply force on this one? We hold with one finger, we hold with another finger, we produce torque. We try to open this one. Clear, no? This is couple. So definitely this finger will apply force in this direction. This finger will apply force in opposite direction. But both of them, they are producing same effect, you know? They are responsible for rotating this cap. So forces may be different, but torque produced will be in the same direction. With one finger, can I open this cap, ma? No, I have to apply two forces. That is called a couple. Clear? Now let us try to understand this one by taking an example. Okay, see here. So consider this is a cap of a bottle. So this is the axis of rotation. One force we are applying in this direction, another force we are applying in this direction. So this is also F, this is also F, this is also R, this is also R. Clear, no? So torque produced because of this one is tau 1, torque produced because of second force is tau 2. Now you see what is the direction of tau 1, ma? R dash cross F dash, positive torque. Okay, ma? See, ma, if any force is able to produce anti-clockwise rotation, such a torque is taken positive. This is anti-clockwise rotation, no? Clock will rotate like this. Clock doesn't rotate, needles of the clock rotate. Clear, no, ma? This rotation is called as clockwise rotation, and this rotation is called as anti-clockwise rotation. So if any torque is producing anti-clockwise rotation, such a torque is taken as positive torque. Remember this point. Clear, no, ma? If a force is able to produce clockwise rotation, then it is negative torque. You should remember these values. Understood, no? Now see here. So R dash cross F dash, torque produced because of first force. Is it giving clockwise rotation or anti-clockwise rotation? Anti-clockwise rotation, no? So here I can say this torque is plus tau 1. Clear, no? Now what about second force? Student. What about second force? Clockwise rotation or anti-clockwise? This is also producing same anti-clockwise rotation only. ఇక్కడ ఫోర్స్ అప్లై చేసిన బాడీ ఇలాగే రొటేట్ అవుతుంది కదా. క్లియర్? నౌ యూజ్ రైట్ హ్యాండ్ రూల్ ఫర్ క్రాస్ ప్రోడక్ట్. R dash cross F dash. Again it is perpendicular and out of the board. If torque is perpendicular and out of the board, again it is positive torque. Understood, no? So this is plus total. Clear, no? So therefore total torque or net torque is how much? Tau 1 plus total. Okay, no? Because both of them they are acting in same direction, no? Tau 1 and tau 2, both of them they are perpendicular and out of the board. They are positive torques. Clear, no? So torque direction you can see by rotation, ma, and you can see by thumb direction also. Okay. So if torque is perpendicular and out of board, then it is what torque? It is positive torque. Torque is a radial vector, no? Thumb gives the direction of torque. Okay, ma? Torque ela undali board lopal ke baitiga. It should be perpendicular and out of the board. Such a torque is positive. Or you can say if a force is producing anti-clockwise rotation, such a torque is also positive. Understood, no? That's it. So therefore these two torques, they are responsible for rotating this cap. Okay, and definitely I can say tau 1 is equals to tau 2, no? Tau 1 and tau 2 they are equal. So therefore I can write 2 tau 1 or I can write 2 tau 2 also, because tau 1 and tau 2 they are equal. So this is the concept of couple. Artha avutundi kada? That's it. Okay, ma? So let us do some more calculations. So net torque is how much? I can write F into R, or I can write R into F plus R into F. Clear, no? So net torque is how much? It is 2 times of R into F. So therefore how can you write net torque can be written as 2R into F also you can write, or you can write F R into 2F also you can write. So this is the net torque which is acting in a couple. Okay, ma? So both the torques they are in same direction, no? So this is torque due to one force, torque due to another force. So 2 into RF. So can you write 2R into F? What is meant by 2R into F? 2R is the total distance between forces, no? And you take one force. Then also you will get total torque, net torque. Are you able to understand? Or you can do one thing. You can take only one distance and you take the double of this force. Then also you will get the same. So you can take 2R into one force. Or you can take one distance multiplied by 2 times of one force. Anything will give same torque. So this is the total torque acting on a couple. Is it clear, ma? So this is about couple. We are adding 2 torques and magnitude of torques and directions are also same, no? So I can write 2R into F or R into 2F, or just you can write 2 into RF also, anything you can write. Okay. Okay. So this is the question which is given, na? So calculate a torque about point O. It means this is the rod, here is the axis of rotation. Okay, ma? And this also is the axis of rotation. So rod is rotating about this axis. Clear? So we are supposed to find out torque about this point because of this force. See, ma, here this is the radius vector, no? Radius vector R dash. So radius vector and force exactly they are perpendicular, no, ma? If this is R dash, what is this one? This is also R dash, no? Just I am displacing the vector. So what is the angle between them? Angle between them is 90. So this angle is also 90 degrees. Clear? So therefore if angle is 90 degrees, then what is the equation of torque? R into F. So radius vector is 3 meters. Force is 10 newtons. So therefore 30 Newton meter is the torque. Okay. Similarly, if I want to find out the direction of this torque, can you say what is the direction of this torque? Magnitude we have calculated. What about direction? Torque is along which direction? Perpendicular and inside the board. How can you say? So we have to do R dash cross F dash now. Place your right hand on first vector. Rotate towards the second vector. Thumb gives the direction of the resultant vector. Able to understand? So R dash cross F dash. So thumb is perpendicular and out of the board. Clear now? So therefore, torque is perpendicular and out of board. So, or you can very simply say without using right hand rule for a cross product also. See, listen. ఈ ఫోర్స్ ఏం చేస్తుంది? దిస్ ఫోర్స్ ఈస్ రెస్పాన్సిబుల్ ఫర్ యాంటీ క్లాక్ వైజ్ రొటేషన్. ఈ ఫోర్స్ రాడ్ని పైకి రొటేట్ చేస్తుందా కిందికి రొటేట్ చేస్తుంది? ఇట్ రొటేట్స్ ఇన్ అప్వర్డ్స్ డైరెక్షన్. సో ఇట్ ఈస్ క్లాక్ వైజ్ ఆర్ యాంటీ క్లాక్ వైజ్? యాంటీ క్లాక్ వైజ్. యాంటీ క్లాక్ వైజ్ ఈస్ ఆల్వేస్ పాజిటివ్ టార్క్ అండ్ పాజిటివ్ టార్క్ ఈస్ ఆల్వేస్ అవుట్ ఆఫ్ ద బోర్డ్. పాజిటివ్ టార్క్ బోర్డు బయటకు ఉంటుందా లోపలికి ఉంటుంది? అవుట్ సైడ్. లైక్ దట్ ఆల్సో యూ కెన్ సే. ఓకే, forces are making the body to rotate in which direction. By using that also you can say whether torque is positive torque or negative torque. Clear now? So therefore, what is the another note point here you can write? You can write that force is responsible for anti-clockwise rotation. Okay ma? Therefore torque is positive. Positive means it is perpendicular and it is coming out of the board. That is the meaning of it. Clear now? Next, let us see the second question, this question. Okay, ma? So here totally 3 forces are present. So one is 5 Newton, 10 Newton and another 10 Newton force is present. So we are supposed to calculate the net torque because of all these forces. Are you able to understand? So therefore, let us consider torque due to 5 Newton force is tau 1, torque due to 10 Newton force is tau 2 and torque due to another 10 Newton force is tau 3. Okay. One thing which I can say is tau 3 will be 0. Is it correct? Torque due to 10 Newton force, it will be 0. What is the reason? Endukala? Same? Angle with respect to what? Denito angle 0. Force is in this direction, radius vector is in this direction. So torque and force, they are at an angle of 180 degrees. Sin 180 is also 0. No? Are you able to understand? No? See ma, from this axis of rotation, radius vector will be in this direction. Vinali. Force is in this direction, 10 Newton of force. So they are exactly at what angle? 180 degrees. What is the equation for torque? Rf sin 180. Sin 180 value is also 0 now. So therefore torque due to tau 3 will be 0. Are you able to understand? Or you can explain like this also. This 10 Newton directly it is acting on the axis, no? 10 Newton force ekkada act avutundi? It is directly acting on the axis of rotation. If any force acts on the axis of rotation, it cannot produce any torque. Are you able to understand? So this is one explanation. Another explanation is what? Another explanation is that 10 Newton force is directly acting on where? It is directly acting on axis. Clear now? Therefore torque due to 10 Newton force will be 0. Okay. Let us calculate tau 1. Torque due to 5 Newtons of force. So how much is the torque ma? Tau 1 is equals to again R into F only. Okay. Why R into F? Because angle between radius vector and force is 90 degrees. Able to understand? Now just do the calculation. R value is how much? 1. Force is how much? 5. 5 Newton meters of torque. Now the question is it plus 5 Newton meter or minus 5 Newton meter? Plus. How can you say plus? This force, if only this force is present, it will rotate the rod in anti-clockwise direction. Anti-clockwise direction means it is positive torque. Understood now? Okay ma? So therefore, next let us see the for torque due to next one, tau 2. Okay. See ma, this tau 2, it is making how much angle? It is making an angle of 37 degrees. No? So you can do one thing, split this 10 Newton force into 2 components. Clear ma? So this is how we can split. What is this angle? 37 degrees. So this is 10 cos 37. This is 10 sin 37. Understood now? So out of 10 sine 37 and 10 cos 37, which angle I have to take? Which force I have to take? 10 cos 37 or sine 37? Cos 37. Why cos 37? Because this is the force which is perpendicular to radius vector, no? So take 10 sine 37. So sorry, cos 37. So therefore tau 2 is equals to r into f. So radius vector up to here, what is the distance, ma? 2 meters multiplied by 10 cos 37 value 4 by 5. So 5 1s are 5 2s are. So 4 4s are 16 Newton meters of torque. Clear, no? Now the question is plus 16 or minus 16? Plus 16 or minus 16? Minus 16. Why minus 16? Because if you see this 10 cos 37, it will make the rod rotate in clockwise direction. Clear, no? Ila rotate just. So therefore it is negative torque. So therefore I will write minus 16 Newton meters of torque. Understood now? So therefore what is the net torque then? Net torque is how much? Net torque is one is positive value, another one is negative value, another value is 0. So minus 16 plus 5. So total how much, ma? Minus 11 Newton meters of torque. So that is the net torque acting on the system. Understood, no? Now this net torque, is it responsible for a clockwise rotation or anti-clockwise rotation? Clockwise rotation, because we got negative value, no? Negative value means negative torque, it is responsible for producing clockwise rotation. So therefore, finally, rod rotates in which direction? In clockwise direction. So that is how we do this calculation. Understood, ma? Okay, ma? So see this question, ma? So a particle of mass m is projected with a speed v0 at an angle of projection theta with respect to horizontal. So find the torque of weight of the particle about the point of projection after a time of v0 sin theta divided by g. That is the question. So let us try to understand what he is asking, ma. So from here a particle is thrown with an initial velocity of v0 at an angle of theta. Clear, no, ma? So we are supposed to find out a torque because of weight of the particle. And what is the mass of the particle, ma? Mass of the particle is m. So weight will become mg. Okay. So at which position after a time of v0 sin theta divided by g, after this much amount of time. So time is equals to v0 sin theta divided by g. So if you observe this time, what do you understand? ఈ టైంని చూస్తే మీకేం అర్థం? ఇంకా when you look at this time, what do you understand? This is a two-dimensional motion, this is a projectile motion. So initial velocity is v0, angle is theta. So after this much of time he is saying, what is this time? What do you understand by looking at this time? ఈ టైంని చూస్తే ఏం గుర్తు రావడం లేదా? అంత తొందరగా మర్చిపోయినారా ఇది? సీమా, time of flight, what is the formula? 2u sin theta divided by g, no? Where u is the initial velocity. This is the time of flight, no? Time for which total particle will be present in air. Okay, suba kainali. So if particle travels like this, total time taken is how much? 2u sin theta divided by g. Now if you look at this time, it is exactly half of this time, no? This time is exactly half. Actually time of flight for this condition should be how much? 2v0 sin theta divided by g. But it is only half. Half means where particle will be present? Particle will be present at the highest position. For total time it will start here and it will reach here. But at the half time, particle is present at the highest position. That's all. So therefore, after this time, where particle is present, particle is at highest position. Clear, no? Are you able to understand, no? Particle is present here. Okay. Now when particle is present here, its weight mg will be acting downwards, no? Mg will be always acting in which direction? Mg will be always acting directly towards the center of the earth. Understood, Dhamma? Now he is asking torque about which point? Torque ekkada kanukommani aduguta unnadu. Torque depends upon the axis of rotation. Clear, Dhamma? He is asking to calculate a torque because of weight about the point of projection. It means this is the point of projection, Dhamma? Ide kada point of projection. So this one if you consider as your axis of rotation. Are you able to understand? This point if you take your axis of rotation, then what is the torque acting on this particle because of its own weight about this point? Are you able to understand? Torque we have to calculate about axis of rotation, no? Which is the axis of rotation? Point of projection. Torque because of which force? Weight. Weight is also a kind of force, no? Clear, no? So I want to calculate a torque because of weight of the body about this point. How can I calculate? Can you say anybody? Range is how much? What is the torque formula? R into F. If radius and force they are perpendicular. Okay. So up to this point, so weight mg will be acting like this, Nama. Weight mg will be acting like this. From the axis of rotation, what is the perpendicular distance? Huh? Axis of rotation nunchi perpendicular distance enta? Total distance is range, no? Half of the distance r by 2. That's all. Clear now? So therefore, torque is equals to range by 2 multiplied by force is mg, because mass of the particle is m. Understood, Nama? And what is the formula for range of a particle? U square sine 2 theta divided by g. This is the equation for range, no? But here what is the initial velocity? V naught. So V naught square. So torque is equals to V naught square sine 2 theta divided by g into 2 multiplied by mg. That's it. Clear now? So if you do this calculation, then I will get the required answer. So g and g get cancelled. So torque is equals to how much? So m v naught square sine 2 theta divided by 2. So this is the torque acting on that particle because of its own weight. About which point? About the axis of rotation. That's it. Are you able to understand now? So these questions will be very interesting to solve if you have the habit of thinking. Okay? వంట చేసే అలవాటు ఉన్న వానికి బిర్యానీ చేసుకొని తినడంలో మంచి ఆనందం వస్తుంది. నాలాంటి వానికి అన్నమాట. అలాగే ప్రాబ్లమ్ని ఆలోచించేవాడికి ప్రాబ్లమ్ని చేయడంలో ఆనందం వస్తుంది. ఆలోచించాలి. ఆల్ఫా ఎంత? ఎప్పుడు కనుక్కున్నాను? అదేం ఫార్ములా? చూడండి సీమా. See, this is a solid disc. Around this solid disc, we are winding some wire. Some wire is wrapped around that solid disc. Clear, no? And this point is the axis of rotation. Around this axis, this disc can rotate. Okay, no? Consider all frictional forces are zero. There is no friction. Okay, no, sir. So if I start pulling this rope downwards, this disc starts rotation, no? Rope ne chuttestunam disc ki. If I start pulling the rope, disc starts rotation, no? Okay. So then what he is asking? He is asking angular velocity omega and how much angle is rotated by this disc. That is what he is asking. Okay. Sima, definitely this is non-uniform motion, no? One thing which you can say this is a non-uniform motion. Is it a non-uniform motion or not? Non-uniform rotational motion. How can you say it is non-uniform rotational motion? Initially disk is in rest. If you apply force, force will apply some angular acceleration because torque is acting, no? Torque produces angular acceleration. So once torque produces angular acceleration, its angular velocity continuously increases. Acceleration apply with the velocity perugutundi kada. Angular acceleration is applied. So definitely omega value also increases. Okay, now let us see. So therefore he is asking final angular velocity. Initial angular velocity is 0, no? Initial angular velocity is 0, it is in rest position. So final angular velocity he is asking. Non-uniform motion, how many equations? 4 equations. So omega is equals to omega naught plus alpha into t. I can use this equation. Omega is equals to omega naught plus alpha into t. Analogous to which equation? V is equals to u plus at in linear motion. In rotational motion, this equation. They are analogous, no? So omega naught, I know 0. Time I know. Time is given 10 seconds. Just alpha value I don't know. So how to calculate alpha value? Alpha value, how can I calculate? Sima, let us go with the given details. Details ఏమి ఇచ్చినాడో చూడండి, దాని ప్రకారం వెళ్దాము. Force produces torque, no? Force produces torque. So therefore torque is equal to R into F. This is the formula, no? Torque is equals to I into alpha also, no? Yesterday only we discussed, no? Newton's second law analogy. In Newton's second law analogy, we have written F is equal to ma, no? So instead of force I can write torque. Instead of mass I can write moment of inertia. Instead of A I can write alpha. నిన్ననే కదా రాసింది మరి. So torque is R into F also, it is I into alpha also. So from this you can calculate alpha, no? Alpha is equal to R into F divided by moment of inertia. So what is the radius of this body where we are applying the force? Force we are applying at the circumference, no? So therefore radius vector is nothing but 0.5 meter. So do the calculation 1 by 2 multiplied by force is how much? 25 divided by what is the formula for moment of inertia of a disk? Half mr square. Half m r square. So half into mass is how much? 2 kg. Radius is 1 by 2 whole square. Clear, no? So 1 by 2 into 1 by 4. So 2 ones are 2 twos are 1 by 4 kg meter square. This is the moment of inertia. That's all, no? Substitute 1 by 4. So therefore 1 by 2 into 25 into 4. So 2 ones are 2 twos are. So alpha value is 50 radians per second square. That is the alpha value. Are you able to understand how we are doing? So by using torque equation, first we are calculating alpha. Once I calculate alpha, now this is very easy calculation of final angular velocity after a time of 10 seconds. Okay, now substitute. So therefore omega is equals to omega naught plus alpha into t. So omega is equals to 0 plus alpha value. Alpha value is 50. Time taken is 10 seconds. So omega is how much? 500 radians per second. That's all. Clear, number? So therefore what is the angular velocity obtained by this disk? Angular velocity will be 500 radian per second. Okay. One more calculation also he is asking, no? Angle rotated. Theta. Theta value how can I calculate? Theta means angular displacement. అంత అవసరం లేదురా. యాంగులర్ డిస్ప్లేస్మెంట్ ఈస్ థీటాను. హౌ కెన్ ఐ క్యాల్కులేట్? ఎస్ ఈజ్ ఈక్వల్ టు యూటీ ప్లస్ హాఫ్ ఎటీ స్క్వేర్ ఇస్ దేర్ నమ్మా. నాన్ యూనిఫామ్ మోషన్ అంటూనే ఆ 4 ఈక్వేషన్స్ బుర్రలోకి రావాలి మీకు. ఆర్ ఏబుల్ టు అండర్స్టాండ్? సో హీఈస్ ఆస్కింగ్ థీటా. వాట్ ఈస్ థీటా? థీటా ఇస్ నథింగ్ బట్ యాంగులర్ డిస్ప్లేస్మెంట్, నో? యాంగులర్ డిస్ప్లేస్మెంట్. క్లియర్ నమ్మా? సో వై డోంట్ యూ యూస్ ద రిలేషన్ ఎస్ ఈజ్ ఈక్వల్ టు యూటీ ప్లస్ హాఫ్ ఎటీ స్క్వేర్? So theta is equals to omega naught t plus half alpha t square. So theta is equals to omega naught is 0, half. Alpha value is 50. Time taken 10. So 100. Clear, no? So therefore 25 into 100. So 2500 radians. That is my answer. Clear? Very simple calculation. So total concept is based on this equation. ఇక్కడ మీరు అప్లై చేసిన ఈ ఫోర్స్ ఏం చేస్తూ ఉంది? వాట్ ఈస్ దిస్ ఫోర్స్ డూయింగ్? దిస్ ఫోర్స్ ఈస్ రెస్పాన్సిబుల్ ఫర్ రొటేషన్. Rotation means a torque is developed, no? So without a torque you cannot do the calculation. First calculate torque, you will get alpha, then you apply the equations of kinematics. That's all. So here this is the given question, man. So this is a solid disk. So initially it was rotating in clockwise direction. What is the initial direction of rotation? Clockwise direction with some angular velocity of omega naught. Okay. Then we are switching off the motor. మోటార్ని స్విచ్ ఆఫ్ చేసేసి. ఇట్ మీన్స్ దెర్ ఈస్ నో ఎక్స్టర్నల్ ఫోర్స్ యాక్టింగ్ ఆన్ ద సిస్టమ్. సో ఆఫ్టర్ స్విచ్చింగ్ ఆఫ్ the motor also it will rotate with same angular velocity only. But what we are doing in opposite direction, we are applying a force. Okay? In opposite direction we are applying a force so that motor should stop rotation. Motor should stop rotation after how many revolutions? 4 revolutions. Are you able to understand? And what is the initial angular velocity? 120 rotations per minute. So therefore you are supposed to calculate how much force I have to apply so that I can stop this motor in 4 rotations. Okay, now let us see. So first of all, Sima, time is not given, no? So first of all, let us take this omega naught. How much it is given? 120 rpm. rpm, is it the unit of measuring angular velocity? Angular velocity ni measure cheyadaniki unit edi? Radian per second. In linear motion, velocity is measured in meters per second. Here it is measured in radians per second. But he gave in rpm. So how can I do? How can I calculate? He gave in rpm. How can I calculate? Huh? See, actually, this is rotations per minute. I can convert this one into rotations per second. If I divide this by 60, it converts into rps, no? Clear, no? Per minute, how many rotations? 120 rotations. It means per second 2 rotations, no? So if I divide by 60, it converts into rotations per second. So therefore 2 rotations per second. And what is this 2 rotations per second? This is nothing but a frequency. 2 rotations per second is nothing but frequency, no? What is meant by frequency? How many oscillations a particle is performing in 1 second? That is called frequency, no? A second particle ఎన్ని సార్లు oscillate అవుతుంది అనేది frequency. So it is oscillating how many times? 2 times. So that is the frequency which is given. Are you able to understand? And what is the relation between a frequency and angular velocity? Omega is equals to 2 pi f. This is the equation, no? Are you right? Omega is equal to 2 pi by capital T R. So therefore omega is equals to 2 pi into what is the frequency? 2. So omega is equals to 4 pi radians per second. This is the initial angular velocity. అర్థమవుతుందా ఎలా చేస్తున్నాము? So initial angular velocity of the particle is how much, ma? 4 pi radians per second. First we got one calculation, no? Okay. So let us keep this aside. Now let us see 4 revolutions. 4 revolutions. 4 revolutions means what is the total angle covered, ma? For each revolution it is 360. 4 revolutions? 4 into 360. But degrees, is it the unit of measuring angle? Which is the unit? Radians is the unit. For one rotation, how many radians? Okay, rotation ki enni radians ayya? 2 pi radians. Maths lo chadvaleda? One rotation will make 360 degrees or 2 pi radians. Clear, no? So total angle is 4 into 2 pi. Understood, no? For each rotation, angle covered is 2 pi. Degrees is not the SI unit, ma. Degrees SI unit kaadu. Radians is the SI unit. Okay? So therefore how much? Theta is equals to 8 pi radians. That is the total angle covered by the particle before stopping. Are you able to understand? So omega I have converted into SI units. Theta also I have converted into SI units. Now see. So he is asking us to calculate a force. Force can be calculated by using torque equation, no? R into F is equal to I into alpha. But alpha value do I know? Alpha value తెలియదు కదా. So therefore what I can do? I can use V square minus U square is equals to 2AS. Finally this disc should stop, no? అదే కదా వాడు ఇచ్చింది. Comes to rest in 4 revolutions. Disc should stop means final angular velocity is how much? 0. So if I write in circular motion equations, omega square minus omega naught square is 2 alpha into theta. That's all, no? So final angular velocity is 0 because the disc should stop, no? Initial angular velocity 4 pi. So 4 pi whole square. 2 into angular acceleration I don't know. But I don't know, I know what is the angle rotated, no? Angle rotated is how much? 8 pi. Clear, no? Now do the calculation. So therefore we will neglect this negative symbol, ma. So 16 pi square is equals to 2 into alpha into 8 pi. Clear, no? 1 pi and 1 square get cancelled, 2, 8, 16, 16 get cancelled. So what is the alpha value I got? Pi radians per second square. Okay. What is this alpha? Angular acceleration produced. Are you able to understand? Once I calculate angular acceleration, now it is very easy to calculate force number, because torque produced is R into F is equal to I into alpha. That's all. No? Substitute in this relation. What is the radius? 1 meter. What is the force? I don't know. What is the moment of inertia? Half mr square, because it is a disk. Alpha value is how much? Pi. That's all. So therefore force is equals to half into mass of the body. Mass of the body 5. Radius 1 meter into pi. Okay, ma? So F is equals to 5 pi by 2 newtons. That is my answer. So that is the amount of force which I have to apply so that the body stops in 4 revolutions. So here time is not given, no? So I will choose that equation which is independent of time. And what is that equation? V square minus U square is equals to 2AS. That's alpha value I don't know. So first calculate alpha. Omega value I don't know. Omega not already given. Alpha theta, that is also given. Clear, no? That's so just I have used this equation and I have used this equation. Only 2 equations. Okay. So whenever a question is given, you have to analyze what is happening here. ఏం జరుగుతుందో ఆలోచించాలి. Initially disk was rotating in this direction. If you apply force in this direction, what will happen? This force will produce some torque. If force negative torque istundi kada. Negative torque means torque which is responsible for stopping this one. Okay? And we know the equations of torque. Okay? It's very simple. So horizontal rod of mass m and length L rotating about a vertical axis. So this is a rod, ma. Clear? And it is rotating about a vertical axis. This is a vertical axis and rod is rotating horizontally. Are you able to understand? It means you need not consider weight of the rod, because weight is acting downwards, no? But it is rotating in horizontal direction. Okay. So mass of the rod is capital M, length of the rod is L, about a vertical axis through its end. Horizontal force F acts at another end. Horizontal force means this force which I apply here, it may be either inside the board or outside the board. Because if rod is horizontal, force should be either like this or force should be like this. But I cannot draw that on the board, no? So what I will do, I will consider this is the force. Okay, ma? Don't think this force is in the plane of the board. Force is either inside the board or outside the board, because he said what is the kind of force? Horizontal force. Arthamavutundi kada arrangement. So find angular velocity of the rod. Omega value I am supposed to calculate by the time it has rotated by an angle of theta. Theta is equals to pi by 2. So this is what he is asking us to find out. Clear, no? So therefore definitely I can use the relation omega square minus omega naught square is equals to 2 alpha into theta. This is the relation which I can use now, because theta is given. Okay, ma? Initial angular velocity is 0. Initially it is in rest equation, no? Omega naught is 0 and omega naught I have to find out. Theta is also present, but alpha is not there. How can I calculate alpha? So torque is equals to R into F is equals to I into alpha. That's all, no? So alpha is equals to R into F divided by I. So R means what? Perpendicular distance from the axis, no? This is the axis of rotation. Perpendicular distance is nothing but length of the rod. L multiplied by how much force we are applying? F amount of force. Now what is the moment of inertia of this body? Moment of inertia of a rod, when rod is present at one axis, it is ml square by 3. Clear now? So substituting ml square divided by 3. Okay. So 3LF divided by ml square. So square and L get cancelled. So 3F divided by ml. That's all done. So this is the angular acceleration which is produced in this rod. So once I calculate angular acceleration, I can substitute here, no? Clear now? So therefore omega square minus omega naught square is equals to 2 alpha into theta. So omega square minus 0 is equals to 2 into alpha value is 3F divided by ml multiplied by theta. Theta value is how much? Pi by 2. 2 and 2 get cancelled. So omega is equals to square root of 3 pi f divided by ml. That's it. That is our answer. Understood? No? Root 3 pi f by ml. 1 by 4. How can you place 1 by 4? No. Angle should be in terms of radians only, no? Radians only. Only in pi by 2s only you have to write. Clear? That's it. This question, ma? So this is a wheel, ma? So to this wheel, a wire is wound here, and that wire or that rope is attached to 2 kg body, and 2 kg body is again pulled by a force of 10 Newton. Understood, no? So what is the moment of inertia of the wheel? Moment of inertia of the wheel is 2 kg meter square, and its radius is 0.25 meters. So if you are pulling by a force of 10 Newton, this wheel will rotate with how much angular acceleration that I want to calculate. Okay. So first of all, let us see what this force is doing. Okay, ma? So we will draw the free body diagram of 2 kg body. Clear, no? So if I take this 2 kg body, so here there is a force of 10 Newton, no? Clear, no? So once I start pulling this one, this 2 kg body will move because there is no friction here. Immediately tension starts developing, no? Clear, no? So on this side tension will be in this direction, on the other side tension will be in opposite direction, because already we discussed that tension is always a double-sided force. Okay, ma? And it is always away from the tied end. Kattesina vaipu nunchi bayatiku untundi. Clear, no? So therefore here force and tension, they are acting in opposite direction. That's it, no? So body will definitely accelerate in this direction. So therefore which force is greater than which force? Definitely F is greater than tension, because acceleration will be in this direction, no? Acceleration will be always in the direction of bigger force. So definitely I can say F is greater than tension. So therefore how can you write the net force? F minus T is equal to mass into acceleration. That's all, no? What is the applied force? 10. Tension I don't know. Mass of the body is 2 kg. Acceleration also I don't know. Okay. So 10 minus T is equals to 2 into A. This is my first equation. So I got one equation, no? Kanisa vidana rasnara? Chepinaru, okay. So 10 minus T is equals to 2 into A. This is our first equation. Are you able to understand, ma? Okay. Now if you see here, same tension, it should be rotating this wheel also, no, ma? So on the wheel, tension is acting in this direction. This is the direction in which tension is acting, no? And what is tension? Tension is a kind of force. So tension will pull the rope. Rope starts rotating with an angular acceleration. So therefore torque equation, how can I write? Torque is equals to Rf into F is equals to I into alpha. This is the equation now. R into F is equal to I into alpha. So what is the radius? 0.25, and here force is nothing but tension. No? Don't be confused here. This force doesn't refer 10 Newton. What is this force here? Force acting on the pulley. Pulley paina a force act avutundi. Tension is acting, no? So instead of F I have to write tension here. And what is the moment of inertia? Moment of inertia already given, no? 2, and alpha value is alpha. Clear, no? So 0.5 T is equals to 2 into alpha. Now this is my second equation. Are you able to understand? So here I have first equation and this is my second equation. Now you count the number of unknown quantities. Tension, one unknown quantity. A, one unknown quantity. Clear, no? Tension, already it is present. Alpha, another unknown quantity. How many unknown quantities are there? 3 unknown quantities are there. But how many equations I have? 2 equations. So it is not possible to solve. I require another equation, because number of unknown quantities and number of equations should be equal. Then only I can solve a problem. So can you say from where can I get another equation? Another equation I can get from constraint relations. Okay, ma? Third equation I can get from where? I can get from constraint relations. What is meant by constraint relations? Let us see. Ma. So consider this is a wheel or a disc, okay, ma? To which 2 bodies are attached like this. Are you able to understand? So therefore, if this body is going downwards with an acceleration of A, okay, ma? What is A here? Acceleration of the mass is how much? Acceleration of the mass is A. ఈ మాస్ కిందికి ఏ యాక్సిలరేషన్తో వెళ్తూ ఉంది అనుకుందాం. క్లియర్ నమ్మా? సేమ్ థింగ్ ఈస్ హ్యాపెనింగ్ హియర్ నో. దిస్ మాస్ ఈస్ ట్రావెలింగ్ ఇన్ దిస్ డైరెక్షన్ విత్ అన్ యాక్సిలరేషన్ ఆఫ్ ఏ. ఓకే, దెన్ వాట్ విల్ బి ద యాక్సిలరేషన్ ఆఫ్ దిస్ పాయింట్ మా? ఈ పాయింట్ యాక్సిలరేషన్ ఎంత ఉంటుంది? ఏ ఓన్లీ నో. సో దేర్ ఫోర్ ఐ కెన్ సే యాక్సిలరేషన్ ఆఫ్ ద రోప్ ఈస్ ఆల్సో హౌ మచ్? యాక్సిలరేషన్ ఆఫ్ ద రోప్ ఈస్ ఆల్సో ఏ ఓన్లీ. క్లియర్ నో? అంతే కదా. యాక్సిలరేషన్ ఆఫ్ ద రోప్ ఈస్ ఆల్సో ఏ ఓన్లీ. And along with the rope, this pulley is also rotating. He said that it is not a slipping, no? Rope is not slipping on the pulley, or rope is not slipping on this wheel. Pulley is rotating, rope is also rotating. They are not slipping on each other. Arthamautundi kada? In Newton's laws, what we studied, their pulley was not rotating. In Newton's laws, pulley was not rotating. Just bodies, they were moving up and down. But here, along with the rope, pulley is also rotating. Are you able to understand? Okay. So if pulley is also rotating, if I take one point on this pulley paina oka point తీసుకుంటే, what will be the tangential acceleration of that pulley will be how much? Tangential acceleration of the pulley will be how much? Pulley, if it is rotating, it will have some angular acceleration also, no? Similarly, it will have some tangential acceleration also. Acceleration in tangential direction. So how much will be that tangential acceleration of this point on the pulley? What is the acceleration of the rope? A. Then acceleration of the pulley also A only. Why? Because pulley is not slipping on the, rope is not slipping on the pulley. Are you able to understand? So therefore what we understand here, acceleration of the mass is also equal to acceleration of the rope is also equal to tangential acceleration of the pulley, and all of them it is equal to A. Can I say like this? Ela cheppachu kada? Are you able to understand ma? If I take one point on this pulley, that point will be accelerating, no? It will be accelerating with acceleration of rope only, because rope and pulley, they are moving simultaneously. They are not slipping on each other. Arthamautundi kada? So therefore here in this concept also, so this one up to here it is clear. Now similarly you can write velocity equation also. So if velocity of a mass is present, then I can say it is velocity of rope also. It is tangential velocity of pulley also. Are you able to understand? What is the velocity of rope? Mass. Same will be the velocity of rope also. Same will be tangential velocity of the pulley also. What is meant by tangential velocity already we studied. అర్థమవుతుంది కదా? క్లియర్ నమ్మా? సో దిస్ ఈస్ ఎ కన్స్ట్రైంట్ రిలేషన్. యాక్చువల్లీ దిస్ ఈస్ నో కన్స్ట్రైంట్ రిలేషన్, క్వశ్చన్ ఆఫ్ కామన్ సెన్స్, దట్స్ ఇట్. క్లియర్? నౌ కమింగ్ టు దిస్ పాయింట్. సో వాట్ ఈస్ ద యాక్సిలరేషన్ ఆఫ్ దిస్ మాస్? Acceleration of this mass I have assumed to be A, no ma? So its acceleration is E. Okay. Then what is the acceleration of the rope? Rope acceleration is also A only. Clear, no? Then what is the tangential acceleration of the pulley? Tangential acceleration of the pulley is also A only. Understood, no? Therefore what I can say? Therefore I can say tangential acceleration of pulley is equal to A. And we know that tangential acceleration is equals to R into alpha, no? Already we studied this relation. The relation between tangential acceleration and alpha is how much? AT is equals to R into alpha. ఇప్పటికే 14 సార్లు చదివినాం. Are you able to understand, ma? So therefore, actually what I want alpha, no ma? So therefore you can do one thing. So instead of A, I can substitute R into alpha in first equation. Are you able to understand, ma? And which is my second equation? Here already alpha is present. Then solve first equation and second equation, then you will get the required answer. That's it. So I got third relation. No? So how many unknown quantities? Here 2 unknown quantity, here 1 unknown quantity. And here there are no unknown quantity, already present there. 3 unknown quantities, 3 equations. Solve it. Okay. So this is my third equation. So third equation from where I got from constraint relations. If acceleration of mass is A, acceleration of rope is also A, tangential acceleration of the pulley is also A only. And we know tangential acceleration is R into alpha. That's all. Clear? So take the first equation. So from first equation, 10 minus t is equals to 2 into A. Instead of A I can write R into alpha. Clear, no? Similarly, already I have this second equation, which is the second equation, 0.5t is equals to 2 into alpha. So therefore t value is how much ma? 2 into alpha is divided by 0.25. So take this t, substitute here. So 10 minus 2 into alpha divided by 0.25 is equals to 2 into r into alpha. R value is already given, no? 0.25. So substitute here. So 10 minus 2 into alpha divided by 0.25 is equals to 2 into 0.25 multiplied by alpha. Now everything is present in terms of alpha only, no ma? So just to calculate that alpha value, that is my required answer. That's all. Understood, no? Okay. So alpha value which you should get is 20 by 7 radians per second square. 20 by 7 or 17? 70. 20 by 17 radians per second square. That is our answer. So have you understood ma how we have done the calculation? So one relation for 2 kg body, one relation for pulley. Two equations I got. Okay. Then I am trying to derive a relation between acceleration and alpha. Okay. What is the acceleration of the mass? Same will be the acceleration of rope. Same will be the acceleration of pulley. And pulley acceleration is called what? Tangential acceleration. So relation between tangential acceleration alpha is this one. So I got three equations. So I have solved and I got the equations. That's it. Okay. So there are two types of equilibrium. Okay, ma? First one is translational equilibrium, and the second one is called as rotational equilibrium. Okay, ma? Translational equilibrium as well as rotational equilibrium. So what is meant by translational equilibrium? Okay, ma? So here I will write separately. So translational equilibrium. Okay. So if net force acting on the system is zero, then such type of equilibrium is called as translational equilibrium. That's okay. System paina net force zero undi anukondi, then I can say body is in translational equilibrium. Okay, let us try to see some example. Consider this is a body of mass m. It is resting on this ground. Okay. So is this body in translational equilibrium or not? Is it translational equilibrium lo unda leda? Undi. Ela cheptaru? How can you say? Forces are definitely present. Weight of this body mg is acting downwards, no? Normal reaction is acting in upward direction, no? So n and mg, they are getting balanced with each other. Clear? When they are getting balanced with each other, net force is zero. Are you able to understand? Let us see one more example. See, ma. So this is a jeep. Okay. So which is traveling on a road with uniform velocity. Uniform velocity. Clear, no? Now this body, is it in translational equilibrium or not? Jeep traveling on a road with a uniform velocity. Is it in translational equilibrium or not? Unda leda? Undi. Ela cheptaru? Translational equilibrium lo unda leda? Uniform velocity means acceleration zero. If acceleration is zero, net force, mass into acceleration zero. So definitely it is in translational equilibrium only. So translational equilibrium means what? Net force acting on the system should be zero. Here there is no net force, no? If there is net force, jeep will accelerate. Net force unte bodies em chestayi? Accelerate avutayi. Jeep, is it accelerating? No. So definitely it is in translational equilibrium. Are you able to understand? Similarly, let us see, this is a rod, uniform rod, resting on two knife edges. Clear Nama? It is resting on two knife edges. Okay. Now is it in translational equilibrium or not? Is it in translational equilibrium or not? Chapandi. Oh, how can you say? How can you say? Which forces are balanced? Weight of the body will be acting at its center of mass, no? So weight mg is balanced by which forces? ఏ ఫోర్సెస్ బ్యాలెన్స్ చేస్తున్నాయి ఇక్కడ? దిస్ నైఫ్ ఎడ్జ్ ఇట్ విల్ గివ్ వన్ నార్మల్ రియాక్షన్ n1 నో. ఈ నైఫ్ ఎడ్జ్ ఒక నార్మల్ రియాక్షన్ ఇస్తుంది కదా. రాడ్ విల్ అప్లై సమ్ ఫోర్స్ ఆన్ ద నైఫ్. Knife edge also will give a normal reaction. Every reaction has an equal and opposite reaction. Clear, no? Similarly, same rod is resting on this knife edge also. Are you able to understand? It also gives a normal reaction of N2. So because rod is not moving in upward direction, it is not going in downward direction. I can say that N1 plus N2 should be balancing the weight of this rod. So N1 plus M2 is equal to N3. So therefore, what is the net force? Net force acting on the rod is 0. So definitely this is also in translational equilibrium. Are you able to understand? Okay. Similarly, let us take a body rotating in a circular path with same constant uniform velocity. V tangential is equal to constant. It is moving in a circular path. Tangential speed, it is a constant. Are you able to understand? Now can you say, is the body in equilibrium or not? Translational equilibrium or not? No. How can you say? అయితే ఇది కూడా మూవ్ అవుతుంది కదా. ఇది సర్కులర్ అయితే డిఫరెన్స్ వాట్ ఈస్ ద డిఫరెన్స్? ఈజ్ ఇట్ ఇన్ ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం ఆర్ నాట్? నో. హౌ కెన్ యూ సే? విచ్ యాక్సిలరేషన్? Centripetal. See ma, for a body to move in a circular path, centripetal acceleration is always required, no? ఇది ఎప్పుడు ఉండాలి కదా. So net acceleration, is it 0? No. If net acceleration is not 0, then net force is also, it is not 0. Centripetal force ఎప్పుడు ఉండాలి కదా దీనిపైన. For any body to move in a circular path, what force is required? Centripetal force is required. Clear now? And centripetal force is present, so net force is not 0. So this body is not in translational equilibrium. Net force is not 0. Okay. So it is not in translational equilibrium. Okay, ma? This body is not present in translational equilibrium because net force is present here. Understood, no, ma? So therefore, wherever net force acting on the system is 0, then I can say that the body is in translational equilibrium. Okay, that's it. Similarly, let us see what is meant by rotational equilibrium. Okay, rotational equilibrium. Now can you say what can be rotational equilibrium? Translational equilibrium already explained, you know. Similarly, what can be rotational equilibrium? Net torque acting on the system is 0. Net torque acting on the system, if it is 0, then it is called rotational equilibrium. Net force 0 the translational. If net torque is 0, then it is called as rotational equilibrium. Are you able to understand? Sima. So consider this is a disc. Are you able to understand? So it is rotating about this axis and disc is in rest position. It is not rotating. It means angular velocity is 0. Now is it in rotational equilibrium or not? This rotational equilibrium lo unda leda? Disc, it has to rotate about this axis, but it is in rest position. Angular velocity is 0. Okay. Is it in rotational equilibrium or not? Definitely it is present in rotational equilibrium. Why? Because net torque acting on the system is 0. Is any force acting on this body? If no force is acting, torque also will be 0. No? Clear? If torque is 0, it is in definitely rotational equilibrium. Understood? Let us see one more example. ఇవన్నీ రాసుకుంటాను కదమ్మా, రాసుకోండి క్లియర్గా. Next, see one more case. So let us take the same disk. Are you able to understand, ma? This is the axis of rotation, and now it is rotating with an angular velocity of omega, and omega is a constant. Okay, it is rotating with same angular velocity. Are you able to understand? Angular velocity is a constant. Now can you say, is it in translational equilibrium or not? Rotational equilibrium or not? Rotational equilibrium. How can you say? Very good. That's it. See, omega is a constant, no? Angular velocity is a constant. If velocity is a constant, acceleration will be zero, no? Velocity constant undi ante meaning emi? Acceleration is zero. Which acceleration? Alpha. Angular acceleration is zero because alpha is d omega divided by dt, no? Alpha value is how much? D omega by dt. Change in omega, is it present? No, because omega is not changing. So therefore 0 divided by dt will be 0. So therefore alpha value is how much? 0. Okay. What linear force, what force will do? Force will accelerate a body. Torque will produce angular acceleration. But angular acceleration is how much? 0. It means net torque acting on this body is also 0 because net torque is I into alpha. That's all. This is the Newton's second law analogy, no? F is equal to ma, Newton's first law, Newton's second law in straight line motion. Torque is equals to I into alpha, same Newton's second law in rotational motion. Gurtunta unnaya? Entarledu sariga. Okay. So therefore if alpha is 0, net torque also will be 0. Are you able to understand? Let us see one more example. Okay. See now. So consider this is a rod which is present on two knife edges, resting on two knife edges. Are you able to understand, ma? Okay. Now can you say this body is in rotational equilibrium or not? Already we studied it is in translational equilibrium. No? Now is it present in rotational equilibrium or not? Rotational equilibrium antune meer em adagali first a axis o cheppandi sir ani adagali ante kada. You can take any axis. For example, you take this axis. About this point, is the rod rotating? Rotate avutunda leda? No. So therefore what you can say, net torque is 0. So therefore definitely this body is in rotational equilibrium. Are you able to understand, ma? If you take axis about this point, ee point chuttu emanna tirugutunda rod ledu. So about this point also net torque is 0, body is in rotational equilibrium. Clear? Same rod, is it rotating about this point? Avutha unda leda? Rotate avutha unda leda? Endo IAS question adigattu face pedtare indi. Is this rod rotating about? So there are two types of equilibrium. Okay, ma? First one is translational equilibrium and the second one is called as rotational equilibrium. Okay, ma? Translational equilibrium as well as rotational equilibrium. So what is meant by translational equilibrium? Okay, ma? So here I will write separately. So translational equilibrium. Okay. So if net force acting on the system is 0, then such type of equilibrium is called as translational equilibrium. That's okay. System paina net force 0 undi anukondi, then I can say body is in translational equilibrium. Okay, let us try to see some example. Consider this is a body of mass m. It is resting on this ground. Okay. So is this body in translational equilibrium or not? Is translational equilibrium lo unda leda? Undi. Ela cheptaru? How can you say? Forces are definitely present. Weight of this body mg is acting downwards, no? Normal reaction is acting in upward direction, no? So n and mg, they are getting balanced with each other. Clear? No? When they are getting balanced with each other, net force is 0. Are you able to understand? Let us see one more example. See, ma. So this is a jeep. Okay. So which is traveling on a road with uniform velocity. Uniform velocity. Clear, no? Now this body, is it in translational equilibrium or not? Jeep traveling on a road with a uniform velocity. Is it in translational equilibrium or not? ఉందా లేదు? ఉంది. ఎలా చెప్తారు? ట్రాన్స్లేషనల్ ఈక్విలిబ్రియంలో ఉందా లేదా? Uniform velocity means acceleration 0. If acceleration is 0, net force, mass into acceleration 0. So definitely it is in translational equilibrium only. So translational equilibrium means what? Net force acting on the system should be 0. Here there is no net force, no? If there is net force, jeep will accelerate. Net force unte bodies em chestayi, accelerate avutayi. Jeep, is it accelerating? No. So definitely it is in translational equilibrium. Are you able to understand? Similarly, let us see, this is a rod, uniform rod, resting on two knife edges. Clear now? It is resting on two knife edges. Okay. Now is it in translational equilibrium or not? Is it in translational equilibrium or not? Cheppandi. How can you say? How can you say? Which forces are balanced? Weight of the body will be acting at its center of mass, no? So weight mg is balanced by which forces? ఏ ఫోర్సెస్ బ్యాలెన్స్ చేస్తున్నాయి ఇక్కడ? దిస్ నైఫ్ ఎడ్జ్, ఇట్ విల్ గివ్ వన్ నార్మల్ రియాక్షన్ n1, no? ఈ నైఫ్ ఎడ్జ్ ఒక నార్మల్ రియాక్షన్ ఇస్తుంది కదా. రాడ్ విల్ అప్లై సమ్ ఫోర్స్ ఆన్ ద నైఫ్. Knife edge also will give a normal reaction. Every action has an equal and opposite reaction. Clear, no? Similarly, same rod is resting on this knife edge also. Are you able to understand? It also gives a normal reaction of n2. So because rod is not moving in upward direction, it is not going in downward direction, I can say that n1 plus n2 should be balancing the weight of this rod. So n1 plus m2 is equal to mg. So therefore, what is the net force? Net force acting on the rod is 0. So definitely this is also in translational equilibrium. Are you able to understand? Okay. Similarly, let us take a body rotating in a circular path with same constant uniform velocity. V tangential is equal to constant. It is moving in a circular path. Tangential speed, it is a constant. Are you able to understand? Now can you say, is the body in equilibrium or not? Translational equilibrium or not? No. How can you say? అయితే ఇది కూడా మూవ్ అవుతుంది కదా, ఇది సర్కిల్. అయితే డిఫరెన్స్, వాట్ ఈస్ ద డిఫరెన్స్? ఈజ్ ఇట్ ఇన్ ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం ఆర్ నాట్? నో. హౌ కెన్ యూ సే? విచ్ యాక్సలరేషన్? Centripetal. See ma, for a body to move in a circular path, centripetal acceleration is always required, no? ఇది ఎప్పుడు ఉండాలి కదా. So net acceleration, is it 0? No. If net acceleration is not 0, then net force is also, it is not 0. Centripetal force ఎప్పుడు ఉండాలి కదా దీనిపైన. For any body to move in a circular path, what force is required? Centripetal force is required. Clear now? And centripetal force is present, so net force is not 0. So this body is not in translational equilibrium. Net force is not 0. Okay? So it is not in translational equilibrium. Okay, ma? This body is not present in translational equilibrium because net force is present here. Understood, no, ma? So therefore, wherever net force acting on the system is 0, then I can say that the body is in translational equilibrium. Okay, that's it. Similarly, let us see what is meant by rotational equilibrium. Okay, rotational equilibrium. Now can you say what can be rotational equilibrium? Translational equilibrium already explained, you know. Similarly, what can be rotational equilibrium? Net torque acting on the system is 0. Net torque acting on the system, if it is 0, then it is called rotational equilibrium. Net force is 0, the translational. If net torque is 0, then it is called as rotational equilibrium. Are you able to understand? Sima. So consider this is a disc. Are you able to understand? So it is rotating about this axis and disc is in rest position. It is not rotating. It means angular velocity is 0. Now is it in rotational equilibrium or not? ఇది rotational equilibrium లో ఉందా లేదా? Disk, it has to rotate about this axis, but it is in rest position, angular velocity is 0. Okay, is it in rotational equilibrium or not? Definitely it is present in rotational equilibrium. Why? Because net torque acting on the system is 0. Is any force acting on this body? If no force is acting, torque also will be 0, no? Clear? If torque is 0, it is in definitely rotational equilibrium. Understood? Let us see one more example. ఇవన్నీ రాసుకుంటాను కదమ్మా, రాసుకోండి క్లియర్గా. Next, see one more case. So let us take the same disk. Are you able to understand, ma? This is the axis of rotation, and now it is rotating with an angular velocity of omega, and omega is a constant. Okay, it is rotating with same angular velocity. Are you able to understand? Angular velocity is a constant. Now can you say, is it in translational equilibrium or not? Rotational equilibrium or not? Rotational equilibrium, how can you say? Very good, that's it. See, omega is a constant, no? Angular velocity is a constant. If velocity is a constant, acceleration will be 0, no? Velocity constant undi ante meaning emi? Acceleration is 0. Which acceleration? Alpha. Angular acceleration is 0 because alpha is d omega divided by dt, no? Alpha value is how much? D omega by dt. Change in omega, is it present? No, because omega is not changing. So therefore 0 divided by dt will be 0. So therefore alpha value is how much? 0. Okay. What force will do? Force will accelerate a body. Torque will produce angular acceleration. But angular acceleration is how much? 0. It means net torque acting on this body is also 0 because net torque is I into alpha. That's all. This is the Newton's second law analogy, no ma? F is equal to mv, Newton's first law, Newton's second in straight line motion. Torque is equals to I into alpha, same Newton's second law in rotational motion. గుర్తుంటా ఉన్నాయా? వినటం లేదు సరిగా. Okay, so therefore if alpha is 0, net torque also will be 0. Are you able to understand? Let us see one more example. Okay, see now. So consider this is a rod which is present on two knife edges, resting on two knife edges. Are you able to understand, ma? Okay. Now can you say this body is in rotational equilibrium or not? Already we studied it is in translational equilibrium, no? Now is it present in rotational equilibrium or not? Rotational equilibrium antune meer em adagali, first ఏ యాక్సిస్ చెప్పండి సార్ అని అడగాలి, అంతే కదా. You can take any axis. For example, you take this axis. About this point, is the rod rotating? Rotate అవుతుందా లేదా? No. So therefore what you can say, net torque is 0. So therefore definitely this body is in rotational equilibrium. Are you able to understand, ma? If you take axis about this point, ఈ పాయింట్ చుట్టూ ఏమన్నా తిరుగుతుందా రాడ్? లేదు. So about this point also net torque is 0, body is in rotational equilibrium. Clear? Same rod, is it rotating about this point? అవుతా ఉందా లేదా? రొటేట్ అవుతా ఉందా లేదా? ఏదో ఐఏఎస్ క్వశ్చన్ అడిగినట్టు ఫేస్ పెడతారేంది? Is this rod rotating about this point or not? No. If it is not rotating, net torque is how much? 0. So body definitely it is in rotational equilibrium. Are you able to understand, ma? See, ma, in this type of conditions you can take axis about any point. That is your wish. ఏ పాయింట్ చుట్టూ తీసుకున్నా ఇది రొటేట్ అవ్వటం లేదు. సో rotation about any axis is 0. So for calculation purpose, for your simplicity, you can take any body to be your point of rotation for calculating torque. Are you able to understand, ma? So what is the note point here which we have to remember? So in this type of conditions, clear, ma? What can I say? Torque can be calculated. Torque can be calculated about any axis of rotation. About any axis of rotation. Are you able to understand, me? You can take any axis and around that axis you can calculate the torque due to different forces. Understood? No? So this is what is called as translational equilibrium and rotational equilibrium. So translational equilibrium means net force acting on the system should be 0, and rotational equilibrium means net torque acting on the system should be 0. That's it. Fine. So let us see this problem. So uniform rod of mass m and length L is suspended through two vertical strings of equal lengths fixed at ends. So a small object of mass 2m is placed at a distance of L by 4 from the left end. Then find the tensions in the two strings. Clear? Let us try to draw a diagram of this one. Okay, ma? So this is a rod. What is the length of the rod? Length of the rod is L, mass of the rod is m. Clear, ma? So it is suspended by two strings, and what are the lengths of the strings? Length of the strings are equal. Clear, no? So it is suspended like this, and they are attached at the ends of this rod. Okay, mass of the rod is m, length of the rod is L, and what is the mass? Mass is m already given. Okay, then small m let us write. Then what is happening? A small object of mass of 2m, it is placed at a distance L by 4. L by 4 means where? Let us take somewhere here. Okay, ma? So this distance I can call it as L by 4. Okay. At that distance we are placing one point mass. Are you able to understand, ma? So what is this total distance? This total distance is L by 4. And what is the mass of this point mass which is present? Mass is 2m. Then you are supposed to find out if tension in the first string is T1, tension in the second string is T2, T1 comma T2 values you are supposed to calculate. That's it. Understood my question? Now can you say how can I do this calculation? Rod suspended by two strings, mass of the rod is m, okay, ma? And there is a mass of 2m at a distance of L by 4. See, ma, first of all, this total rod, it is in translational equilibrium. Rod translational equilibrium lo unda leda? Undi kada? Net force, is it acting on the rod? Rod is in rest position, no? Rest position means net force acting on the rod is 0. So therefore I can say first point is, so if you solve according to translational equilibrium, okay, ma? So what are the different forces which are acting on this rod bar? See, ma, its own weight, small mg, will be acting downwards, no? Weight of the own rod. Rod weight ekkada untundi? Where will be the weight of the rod? At its center of mass. At its center of mass. So weight mg will be acting downwards. Then at a distance of L by 4, we are placing one more mass, no? And what is the weight of that mass? Weight of that mass is 2 mg. Mass is 2m, weight is 2 mg. So these are the two forces which are pulling the system in downwards direction. Clear, no? Then how it is in balanced condition? Tensions are acting in upward direction, no? Tension T1 and tension T2, they are acting in upward direction. So for a rod to be in translational equilibrium, net force should be 0, no? Net force should be in 0. So all the upward forces will be balanced by downward forces. So I can say T1 plus T2 is equals to 2 mg plus mg, which is equal to 3 mg. Can I write like this? Upward forces evi ikkada? T1, T2. Downward forces 2 mg, mg. They are balancing, no? So therefore this is my first equation. Are you able to understand? So I want T1 and T2, both of them, no? Two unknown quantities are there. It means definitely I require one more equation. So second equation from where can I get? Inkoki equation ekkada nunchi vastadi? Second, one equation I calculated from translational equilibrium. Are you able to understand? Second equation from where can I get? Second equation ekkada nunchi vastadi? This rod is present in rotational equilibrium also, no? Rotate avutunda emanna? Ledu. It is not rotating, no? It means definitely it is in rotational equilibrium. Rotational equilibrium about which axis? Any axis. If you take this axis, this point, any point you take, always it is in rotational equilibrium. Are you able to understand? So therefore, take the equation of rotational equilibrium. Okay. What is meant by rotational equilibrium? Net torque acting on the system should be 0. Are you able to understand, ma? Okay. Now can you say, I will take axis of rotation to be which point? A point తీసుకుందాం చెప్పండి. So here how many points are there? Let us take this is first point, let us take this is second point, let us take this is third point, and let us take this is a fourth point. Okay. So it is better to take axis of rotation about which point? A తీసుకుంటే బాగుంటుంది. About first point. Okay. Okay. Let us try about first point. Are you able to understand, ma? So taking point number 1 to be the axis of rotation. Okay, ma? Taking point number 1 to be my axis of rotation. Okay. So about point number 1, net torque should be how much, ma? Net torque should be 0. Okay. Now totally how many forces are acting on the system, ma? How many forces are acting on the system? చెప్పండి, ఫాస్ట్గా ఉండాలి. ఏందా కప్పను మింగిన పాము మాదిరి ఉంటే ఎట్లా? మీరు కప్పను మింగిన పాము చూసినారా? పాము ఎంతుండి ఇంత పెద్ద కప్పను మింగుతుంది అనమాట. ఇంకా అట్లా పడుకొని ఉంటుంది. అట్లా ఉన్నారు మీరు. చెప్పండి ఫాస్ట్గా. హౌ మెనీ ఫోర్సెస్ ఆర్ యాక్టింగ్? 1 2 3 4 ఫోర్సెస్ ఆర్ యాక్టింగ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్, మా? సో క్యాల్కులేట్ టార్క్ బికాస్ ఆఫ్ ఆల్ ద ఫోర్సెస్ and add all of them. Total should be how much? Total should be 0 because net torque is 0. అర్థమవుతుంది కదా? Now see. So first calculate torque due to T1, this force. Okay. And I am taking axis here only, no? Where I am taking axis? I am taking axis to be point number 1. Okay. And force is directly acting on point number 1 only, no, ma? Force ఎక్కడ యాక్ట్ అవుతుంది? యాక్సిస్ పైన యాక్ట్ అవుతుంది. Force is acting on the axis itself. Then such force can it produce torque? In last class what we studied, if a force is directly, last class absent కదా, డబ్బా రేకుల్లో డబ్బాలు కొట్టినట్టు ఉంటుంది, అందుకే absent అవ్వకూడదు. అర్థమవుతుంది కదా? So if force is directly acting on the axis, it cannot produce any torque. Already we studied, no? So torque due to T1 is how much? 0. Understood, Nama? Next force let us take. Torque due to 2 mg is how much? Very good. So from the axis of rotation, what is the perpendicular distance, ma? Already given, no? Perpendicular distance is L by 4. That's all. So torque formula R into F. So radius is how much? Radius is L by 4. Force is how much? 2 mg. Are you able to understand, ma? So torque due to 2 mg is this much, L by 4 into 2 mg. Now the question is it positive torque or negative torque? అది కూడా చూడాలి కదా. Torque due to 2 mg, is it positive torque or negative torque? Negative torque. How can you say? So R dash cross F dash. వినాలి చాలా కేర్ఫుల్గా వినాలి. R dash cross F dash. Thumb is inside the board, no? So definitely negative torque. Or you can say this force, if it is only this force is present, then this force will make the rod to rotate in clockwise direction, no? ఈ ఫోర్స్ ఏం చేస్తుంది చెప్పండి? రాడ్ని ఎలా రొటేట్ చేయాలని ప్రయత్నం చేస్తూ ఉంది? ఇట్ ఈస్ ట్రైంగ్ టు రొటేట్ ద రాడ్ ఇన్ క్లాక్వైజ్ డైరెక్షన్. క్లాక్వైజ్ డైరెక్షన్ మీన్స్ నెగటివ్ టార్క్, సో మైనస్ L by 4 into 2 mg. Understood? Similarly, torque due to mg is how much? Next, this force, torque due to mg. చెప్పండి, what is the distance from the axis of rotation? L by 2. Clear, Nama? So L by 2 multiplied by what is the force? Force is mg. Now is it positive torque or negative torque? Definitely negative torque. This is also producing clockwise rotation, no? So negative torque, minus L by 2 into mg. Understood, Nama? Next, torque due to third force. So torque due to T2 is how much? So from the axis, what is the total distance? From the axis, total distance is L. Clear, no? So L into, now what is this force? This force is a T2. Now this is producing positive torque or negative torque? Positive torque, because this force will make the rod to rotate in anti-clockwise direction. Clear, Nama? So plus L into T by 2. Now add all of them. So therefore net force is how much, ma? Net force should be 0 because rod is in equilibrium. Okay, so add all of them. So 0 plus, what is the torque due to 2 mg? So minus, I will write, minus L by 4 into 2 mg plus torque due to mg is how much? It is also minus. So minus L by 2 into mg plus L into T2. Okay, ma? So this is the total net torque. So this is my second equation. Understood now? So from translational equilibrium, I got one equation. Are you able to understand, ma? From translational equilibrium, I got one equation. Here, how many unknown quantities are there? 2 unknown quantities are there. And from rotational equilibrium, I got one more equation. Here also I have T2, no? So take this T2, substitute here. Then I will get T1. No? That's all. That is my answer. Clear? Now come on to the calculation. So ఎవరి హెల్ప్ తీసుకున్నాం ఇక్కడ చెప్పండి. ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం హెల్ప్ కూడా తీసుకున్నాము, రొటేషనల్ ఈక్విలిబ్రియం హెల్ప్ కూడా తీసుకున్నాము. అంతే కదా? దట్స్ ఇట్. ఎంత వచ్చిందిరా? T1 ఎంత వచ్చింది చెప్పు. T1 2mg, T2 దట్స్ ఇట్. అంతే ఆన్సర్స్. ఇలా ఈక్విలిబ్రియం ప్రాబ్లమ్స్ ఇలా చేయాలి. ఓకేమా? సో ఇటువంటి ప్రాబ్లమ్స్ మీరు ఇస్తూనే ఫస్ట్ ఏం చేయాలి, ఇవి ట్రాన్స్లేషనల్లో ఉన్నాయా రొటేషనల్లో ఉన్నాయా చెక్ చేసుకోండి. క్లియర్మా? చెక్ చేసుకొని ఒక్కోసారి ఒక ఈక్వేషన్ ఉంటే మీకు ఆన్సర్ వస్తుంది, రాకపోతే సెకండ్ ఈక్విలిబ్రియం కూడా తీసుకోండి. దీన్ని ట్రాన్స్లేషనల్ ఈక్విలిబ్రియం తీసుకోకుండా కూడా చేయొచ్చు. ఎలా చేయొచ్చు? ఇప్పుడు మనము ఫస్ట్ పాయింట్ దగ్గర యాక్సిస్ తీసుకున్నాం కదా, ఒక ఈక్వేషన్ వచ్చింది. సెకండ్ పాయింట్ దగ్గర ఇంకొక ఈక్వేషన్ రాసుకుంటే సెకండ్ ఈక్వేషన్ వస్తుంది కదా, ఆ రెండింటిని సాల్వ్ చేసిన ఆన్సర్ వస్తుంది. అర్థమవుతుంది కదా? కాకపోతే కొంచెం కష్టం. అదే ట్రాన్స్లేషన్ అయితే చాలా ఈజీ కదా, జస్ట్ ఫోర్సెస్ని బ్యాలెన్స్ చేస్తే చాలు, ట్రాన్స్లేషన్ వస్తుంది మనకు. ఓకేనా? ఎంతరా టైము? 9:02. ఓకే, యాడ్ చేయండి మరి. ఏంది ఇది రన్ అవుతానే ఉందా ఇది మాత్రం? ఓకేమా? సో లెట్ us do the calculation. So what I got there? So minus L by 4 into 2mg minus L by 2 into mg plus L into T2 is equal to 0. So L I can cancel, 2z. So therefore minus mg by 2 minus mg by 2 plus T2 is equal to 0. So T2 is equal to mg. Okay, ma? Now here I have this equation, no, from first equation T1 plus T2 is equal to 3mg. So take this T2 and substitute here. So T1 plus mg is equal to 3mg. So therefore T1 value is 2mg. That is my answer. Clear now? That is how we can do the calculation. So this is a ladder. Length of the ladder is L, and what is the weight of the ladder? Weight of the ladder is W. Clear now? So on this ladder, a man is also standing, and where the man is standing at a distance of L by 3, man is standing, and weight of the man is 3W. Clear now? And there is a friction between ladder and the ground. There is friction between ladder and the ground. Clear now? But there is no friction between ladder and the vertical surface. This wall, vertical wall will be there, no? vertical wall is smooth. Here it means coefficient of friction is how much? It is 0, but here coefficient of friction is not 0. Understood, Nama? Here. Then these are the values which you are supposed to find out. Find the normal reaction and force on the ladder at its base. Find the minimum coefficient of static friction needed to prevent slipping at the base. Understood, Nama? Okay, now let us see. First of all, let us study about ladder is in rest position. No? Ladder is in rest position. It means it is in translational equilibrium. Okay, ma? Ladder is in which kind of equilibrium? It is in translational equilibrium because this ladder, it is not slipping. It is in rest position. Okay. Now let us see how many forces are present along x-axis. Along x-axis, how many forces are present? Okay. See how many forces are present, ma? See here, ladder will be pushing this wall, no? Ladder will be pushing the wall. Then what wall will do? Wall will give a normal reaction. Clear, no, ma? So let us call that normal reaction to be N1, N2, anything. Clear, no, ma? How I got this normal reaction? Because ladder will be pushing the wall. Wall will give a normal reaction. Ante kada? Clear, no, ma? Similarly, because of this force, ladder will try to slide. No? Because of this force and some another forces also, weight of this ladder also, man of this ladder also, ladder will try to slip. Slip avalani chustundi kada. If ladder tries to slip, friction will act in which direction? Friction will act in opposite direction. FL will act in opposite direction. So consider ladder is ready to slip. Therefore, what is the friction which is acting? Friction is acting is FL, limiting friction. Okay, ma? Still, are there any other forces ma along x-axis? X-axis pe inka emana forces unnayemo chudandi. Okay. Ladder will push the wall, vertical wall. Wall will push the ladder. End. Are you able to understand? Similarly, this ladder will try to slip. Friction will act in opposite direction. It means friction is preventing the ladder to slip. Ladder slip avakunda friction pattukonundi da. Clear, nama? So along x-axis, how many forces are there? Only 2 forces are present, and they must be balanced. No, they must be balanced. Balance avakapothe. If they are not balanced, ladder will slip. Okay. So this is the force which is pushing the ladder, and this is the force which is pulling the ladder. Both the forces must be balanced along x-axis. Arthamatunda? We are studying which concept? Translational equilibrium. So therefore, what I will write N2 and FL, they are equal. This is my first statement. Okay. Similarly, let us see what are the forces which are acting along y-axis. Along y-axis, what are the different forces which are acting? Now can you see? Along y-axis, what are the forces which are acting? Come on. So first weight of the ladder will be there, no? Weight of the ladder will be acting at its center of mass. Are you able to understand, ma? Or shall I draw a separate diagram? Okay, we will write here only. Clear, no, ma? So therefore, weight of the ladder will be acting exactly at its center of mass, no? And what is the weight of the ladder given? W. Are you able to understand? So W. Still? Weight of the man is also acting, no? Weight of the man is how much? 3W. It is also given, no? So weight is also acting in downward direction. Still? Adeka Subbaka gravitational force ante. He did not give mass ma here, directly he gave weight. If he gave mass, you multiply with the G value and you get weight. But he gave already weight, no? You need not multiply with the G value. Understood, no? Weight of the ladder in downwards direction, weight of the man also in downwards direction. Still any other forces? See, this ladder will be pushing the ground, no? Then what ground will do? Ground also will give a normal reaction, and that normal reaction I will call it as N1. Are you able to understand? Still any other forces are there in y direction? Only 3 forces are present. Are you able to understand, ma? So therefore I can say which forces are balancing which forces? N1 is balancing 3W plus W, which is equal to 4W. So therefore N1 is equals to 4W. One answer already I got. Are you able to understand? One reaction already I got. N1 is equal to 4W. Are you able to understand? Okay. So normal and friction acting on the ladder at the base. So normal I have calculated. One value I have calculated. No? So normal reaction acting at the base of the ladder is how much? 4W. Okay. Now I want to calculate FL. This also he is asking now friction which is acting at the base. Okay. N2 is also unknown quantity. Normal reaction given by the vertical wall, that is also unknown quantity. No? Limiting friction is also unknown quantity. Two unknown quantities are there. I require one more equation. Are you able to understand? Ma? So this angle I forgot you to give. Ma. This angle is 53 degrees. Angle made by the ladder is 53 degrees only, I think. 53 degrees. Are you able to understand? So therefore now what can I do? Evarni split cheyali enduku? Now I have two unknown quantities, but I have only one equation. Now what I have to do? Cheste emautundi? Already we discussed now. Take now rotational equilibrium equations. Rotational equilibrium. Ladder is it rotating, ma? Ladder garran tiruta unda. So it means it is in which equilibrium? Rotational equilibrium. So write one equation for rotational equilibrium, then you will get second equation. Solve first equation, second equation. That is my answer. That's it. Okay. Now the question is, which axis shall I take? So how many points are there? See, I will draw this diagram here. So if this is the ladder, how many forces are acting? So one force is acting here, which is called as N1. Okay, ma? One force is Fl. And here, which is the force which is acting, here it is 3W. And at the middle, which is the force which is acting, this is W. Clear, na, ma? And one more force which is acting is N2. Okay, ma? So this is what we were doing now. Bhaskar. Okay. So taking torque equation about point A. So this is point A. So if I take torque equation here, okay, then torque due to N1 and torque due to Fl, they will become 0. No? Why? Enduku? Because if I am taking this point to be my axis of rotation, then N1 is also directly acting on the axis, no? Fl is also directly acting on the axis itself. So already we discussed that when force is acting directly on the axis, then torque due to that force will be 0. So torque due to N1, torque due to Fl, both are 0. So therefore at point A, how many forces are giving torque? Only 3W, W and N2, only these three forces they are giving the torque. Are you able to understand? Okay. Now let us calculate each of them and we will equate to 0. Then let us see if we can get the required answer or not. Okay. So first of all we will calculate torque due to 3W. Clear, ma? 3W. So this is the axis of rotation. Are you able to understand, ma? And what is the perpendicular distance from the axis of rotation to this force? 3W is a kind of force only, no? Perpendicular distance is this much. Are you able to understand? So how can I calculate this distance, ma? This distance where man is standing, it is already given as L by 3, no? Okay. So from the axis of rotation, man is standing at what distance? L by 3. At what angle? At an angle of 53 degrees. So split that L by 3 into two components. Are you able to understand, ma? So this is angle 53 degrees. So this is L by 3 cos 53 and this is L by 3 sin 53. Are you able to understand, ma? So where this 3W is acting like this. So which is the perpendicular distance, ma? L by 3 cos 53 or L by 3 sin 53? L by 3 cos 53 is the perpendicular distance. So therefore torque due to 3W is equal to R into F. Radius vector is L by 3 cos 53 and force is nothing but 3W. Clear, no, ma? So L by 3, okay, we will substitute afterwards. Okay. Then let us go to torque due to W. Okay, ma? So W, weight of the ladder will be acting at which position? Exactly at the center of mass, no? So this total distance will be how much? This total distance will be, total distance is L, no? So this distance will be L by 2. So split that L by 2 again into two components. Clear now? Angle is again 53 only, no? So L by 2 cos 53 and this is L by 2 sin 53. Okay. Now where W is acting somewhere here. Okay. So therefore which is the perpendicular distance once again? L by 2 cos 53. So therefore torque due to W is how much? R into F. So radius vector is how much ma? L by 2 cos 53 multiplied by force is nothing but weight of the ladder W. Clear now? Similarly we will calculate a torque due to N2. Are you able to understand ma? N2 also can provide a torque at point A, no? This is also responsible for rotation. Clear now? But this N2 is acting at what distance from the axis of rotation? Total distance is L. But we want only perpendicular distance, no? So again take this total L, split this one into two components. So angle is how much? Angle is 53 degrees. So this is L cos 53 and this is L sin 53. Clear now? But where N2 is acting somewhere here, no? Clear now? N2 is acting here. So which is the perpendicular distance? L cos 53, L sin 53. L sin 53 is the perpendicular distance from the axis of rotation. Are you able to understand ma? So therefore torque due to N2 is equals to again R into F. Radius vector is L sin 53 multiplied by force is N2. Clear now? Now first torque, second torque and third torque. Add all of them, total should be how much? Total should be 0. Now see if you get total value to be 0 or not. Okay ma? Shall I rub this one? Which one is positive torque and which one is negative torque now ma? So torque due to 3W, positive torque or negative torque? So this is responsible for clockwise rotation now ma? Student ikkada ee force em chestundi responsible for clockwise rotation. Clockwise rotation means definitely this should be negative torque. Clear no? Torque due to W, this also clockwise rotation. So again negative torque. Clear no? Then torque due to N2. See about this axis how this N2 will rotate this rod. It will rotate in anti-clockwise direction. So this torque is positive. Clear no? So add all the torques. So therefore, adding all the torques. So minus L by 3 cos 53 multiplied by 3W minus L by 2 cos 53 into W plus L sin 53 multiplied by N2. Total should be how much ma? Total should be 0. Clear no? So shall I rub this one? Now do the calculation here. So here also I have divided by 5, divided by 5, divided by 5. So divided by 5 I will remove. Similarly L is also common number, L also you can remove. So in the numerator what I am left with? I am left with minus 3 by 3. 3 by 3 into 3W minus L got cancelled, no? So 1 by 2 into, in cos 53 again 3 got cancelled. 5 got cancelled, we have 3 into W plus L is already cancelled, 5 is cancelled, 4 into N2 is equal to 0. That's all number. So therefore minus 3W minus 3 by 2W plus 4 N2 is equal to 0. Clear no? So therefore 3 2s are how much ma? 6. 6 minus 6 minus 3 minus 9W by 2 is equal to minus 4 N2. So therefore N2 value is how much ma? 9W divided by 8. So that is my answer. Understood now? N2 value we have calculated 9W divided by 8. That is my answer. Okay, come on, make note. So the second question which he is asking is minimum coefficient of friction for the ladder not to slip. Clear now? So this relation already we have written, no? So if you see translational equilibrium, so FL should have been balancing by N2. So FL and N2 they are equal. So substitute. Clear now? So therefore FL is equal to N2. So FL is equal to, what is N2 value? N2 value is 9W divided by 8. So minimum coefficient means limiting friction should have been already maximum, no? That is called minimum coefficient of friction. So coefficient of friction if it is minimum, it means ladder is ready to slip. Okay ma? Ladder is ready to slip means what? Friction has already reached the maximum value. That is why instead of friction I have written FL here, maximum limiting friction. Understood now? And what is the equation of FL? Mu s into n. Here what is the normal reaction? Normal reaction is n1. So mu s into n1 is equals to 9W divided by 8. So because of n1 only this friction is developing now. Clear? Now limiting friction depends on what? It depends on normal reaction. What is the normal reaction at this position? n1. And n1 value already I have calculated now, 4W. So substitute. So mu s into n1 value is 4W is equals to 9W divided by 8. So W if you get cancelled. So mu s value is how much? 9 divided by 8 4s are 32. So that is my answer. Understood now? సో లేట్ వస్తే ఆ బయట డోర్ వేసేస్తామా నేను ఎక్కువ మాట్లాడితే కింది డోర్ వేసేస్తాం లేట్ వస్తే అట్లా వెళ్ళిపోండి ఇంకా రావాల్సిన అవసరం లేదు ఓకే mass 1 kg moves translationally with acceleration. So what is the acceleration in the rod? A is equal to 2 meter per second square, and it is not rotating, it is moving translationally. For example, if this is the rod, it is moving like this. That is the translational motion, moving in a straight line. Rotation is not present. So these are the two forces F1 and F2 which are given. The distance between the points at which these forces are applied is equal to D is equal to 20 centimeter. Are you able to understand? It means the distance between these two forces is 20 centimeter. So besides it is known that F2 is equal to 5 Newton, which is F2, this one. This force is equal to 5 Newton. Then find the length of the rod. Are you able to understand? So write equation for translational motion. Translational motion. Okay, ma? So in translational motion, we just study about net force only. No? In rotational motion, we study about net torque. But in translational motion, we study about net force. Clear? No? Rod is translating with acceleration. It means definitely rod is not in translational equilibrium. No? Is it in translational equilibrium? No. Because acceleration is present. If acceleration is present, net force also will be present. So therefore acceleration, if I consider in this direction, then F2 should have been greater than F1. So therefore what I can write? So therefore I can write net force is nothing but F2 minus F1. Clear, ma? See ma, here F1 cannot be greater than F2. Direction of acceleration he did not give. Direction of acceleration vadem ivalledu. Nenu anukuntavanu ee vaipu veltundi. How did I assume that rod is moving in this direction? Why can't I say rod is moving in opposite direction? No, question is this acceleration direction he did not give. I have assumed that body is moving in this direction. How did I assume? Why can't I say acceleration is in this direction? See, point is that if you consider this is the center of the rod, if F1 is greater, then F1 will produce more torque when compared to F2. So the force which is at a large distance from the axis of rotation, if I consider this one to be my axis of rotation, center of the rod, clear no? Then F1 is present at a large distance. No? So F1 will produce more torque when compared to F2. So automatically rod will rotate. But rod is it rotating? No, it means definitely F2 is greater than F1. So the torques are getting cancelled with each other. One is producing anti-clockwise torque, another force is producing anti-clockwise torque. So clockwise, anti-clockwise, they should get cancelled with each other. It is possible only when F2 should be greater than F1. So that is why I have taken acceleration to be in this direction. అర్థమవుతుంది యాక్సిలరేషన్ ఈ వైపు ఎందుకు తీసుకుంటాం? If F1 is greater, F1 is already greater, distance is already greater, no? It will produce more torque. So rod will start rotation. But rod is not rotating. It means F2 is greater than F1. Understood, no? That's it. So F2 minus F1 produces net force, and net force is equal to mass into acceleration. Clear, no? So F2 is how much? 5 Newton. F1 is how much? I don't know. Mass of the rod is how much? 1 kg. acceleration is 2. So therefore what is F2 value? F2 value is 5 minus 2, it is equal to 3 Newton. So one force I have calculated by using which equation? Equation of translational motion. Okay, ma? Sorry, F1. F1 value is how much? F1 value is F1 I think. Sorry. This is F1, not F2. F1 value is how much? 3 Newton. So by using which method we have calculated? By using the statement of translational motion. Net force always produces acceleration. Understood, no? Okay. Now, rod is not rotating, no? It means it is present in which equilibrium? It is present in rotational equilibrium. Are you able to understand? Rotational equilibrium means what? Net torque acting on the system is 0. How many forces are present? 2 forces are present. What are they? F1 is also present, F2 is present. One more force is there. Weight of the rod is also there, no? Are you able to understand? So, F1 is present, F2 is present, weight is also present. But I am taking axis to be here. No, you can take axis anywhere. Meer ekkadaina teesukochu axis. Nenu ikkada teeskunna. Are you able to understand, ma? So, but weight is acting where? Weight is acting on the axis itself, because weight acts on the center of mass, no? So weight cannot produce any torque. Are you able to understand? Weight ekkada act avutundi? Center of mass. Axis also at center of mass only. So weight cannot produce any torque. Okay, ma? So let us call this point as point O. Okay. So taking axis at point O. Okay, ma? Therefore what I can say, net torque will be 0. So therefore torque due to F1 plus torque due to F2, total should be how much? Total should be 0. Understood, ma? Now what is this distance, ma? This distance I know it is 20 centimeter. But what is this distance? This distance let us call it as x, ma. Can I call this distance as 20 plus x? I can call it 20 plus x. Similarly, F2 is acting at a distance of x only. So substitute. So torque due to F1 will produce positive torque or negative torque? F1, responsible for anti-clockwise rotation, no? It will produce positive torque. So therefore I will write minus F1 into, and what is the distance? 20 plus x. Okay, ma? Plus a torque due to F2. Torque due to F2 will produce negative torque only, no? Sorry, this is anti-clockwise, no? Positive torque. This is clockwise, negative torque. So minus of F2 into x, total should be how much? Total should be 0. F1 and F2 values already we know, no, ma? If you know F1 F2 values, x is the only unknown quantity. So derive x value, that is my answer. Understood, no? So what is F1? F1 is 3. 3 into 20 plus x minus F2 value is 5. 5x is equal to 0. Clear, no? So 60 plus 3x minus 5x is equal to 0. So 2x is equal to 60. So x is equals to 30. Okay, ma? So therefore total length of the rod is how much? Total length of the rod is 50 plus 50, which is equals to 1 meter. That is my answer. Okay. So this distance is 20, no, ma? X value is 30. So 20 plus 30, 50. So half of the rod is 50. Remaining half will be another 50. So 50 plus 50, 1 meter is the length of the rod. Weight of the door is how much? W. So this door is held in air by 2 hinges. So this is hinge number 1 and this is hinge number 2. Okay, ma? Total length of the door is 4L, width of the door is L, and hinges are present at L and L from the edges of the door. That is the arrangement of these hinges. Okay. Then what he is asking, if each hinge gives equal force, then find the forces by each of the hinges. That is the question. Now let us see. This door, definitely it is in translational equilibrium, no? Yes or no? So, it is in translational equilibrium. Door is not moving, no, ma? Door will be at same position. It is not moving. So therefore I can say net force acting on this door should be 0. So weight of the door is W, no? Where weight will be acting, ma? Weight will be acting exactly at its geometrical center. Okay. So with the help of this weight, door is trying to come down. But why door is not coming down?
డోర్ గాల్లో ఉంటుందా, భూమి పైన ఉంటుందా? డోర్ విల్ బి ఇన్ ఎయిర్ ఓన్లీ, నో?
So with the help of its weight, it is trying to come down. But why it is not coming down? Because hinges will be opposing the weight of this door.
That's all. How many hinges are there?
2 hinges are there. So let us consider one hinge will give a force of F1 and one hinge will give a force of F2. Clear, no? If weight is acting in one direction, hinges should give force in opposite direction.
And he said that forces applied by each hinge is same. So therefore, can I say that
F1 is equal to F2?
definitely both of them they should be equal number. Weight is acting in downwards direction, hinges should give force in opposite direction.
So therefore I can say W is equals to, weight of the door is nothing but F1 plus F2,
Or I can write it is either 2F1 or I can say that it is 2F2. That's all, number, because F1 F2 they are equal, no?
So therefore I can say F1 is equals to W by 2. Also I can say F2 is equals to W by 2.
F1 is also W by 2, F2 is also W by 2 because forces are equal. Okay?
Now is this my answer? This is not my answer. Why?
Why? Because
weight of the door will be trying to rotate this door also
about any hinge. Okay? No? For example, if I take this hinge to be my axis of rotation, this weight W, it has a perpendicular distance from the axis of rotation. No? What is the perpendicular distance? L by 2. Okay? From the axis of rotation, what is the perpendicular distance?
L by 2. So therefore what is the torque? L by 2 multiplied by W. So torque is present.
So with the help of that torque, door will try to rotate. Rotate avvadaniki try chestundi kada. If door tries to rotate, there should be some opposite torque which should oppose this rotation. And who will give that opposite torque? Again hinges only. Are you able to understand? Now let us do one thing. So let us draw the door once again. Clear, no? So this is the door. Okay. So here there is hinge number 1 and here there is hinge number 2. Okay. Weight of the door is acting somewhere here. So this is the weight of the door and perpendicular distance from the axis of rotation is how much? L by 2. Are you able to understand, ma? So therefore, torque given by door is how much? Which one shall I take to be my axis of rotation? First of all, let us take this one to be my axis of rotation. Are you able to understand, ma?
This one I will consider to be my axis of rotation.
Okay. So torque about this axis is how much? Torque due to door is how much? R into F. Torque formed R into F only, no? Torque given by which door I am, which force I am taking here? Torque given by door. About which axis? About this axis of rotation. From this axis, perpendicular distance is L by 2. Force is nothing but W. So positive torque or negative torque? Clockwise rotation, no? So definitely this is negative torque. Okay. But door, is it rotating? No? Door rotate avutunda? No. It means somebody is giving another opposite torque. No? Some force is giving positive torque. Who is that force who is giving the positive torque? So that total torque will become 0. Second hinge. Second hinge will give positive torque. So that total torque will become 0. Are you able to understand? Okay. Now this is the axis of rotation. No? What is the distance between two hinges? Distance between two hinges is how much? Total 4L, nama? L. Then remaining distance will be 2L. So this distance is 2L. Understood? No? Now can you say
this hinge should give force in which direction so that torque because of the door will get cancelled?
In this direction.
In this direction.
So R dash cross F dash. Correct one. This is outside the board, no? Positive torque. Are you able to understand, ma? Door is giving negative torque. About which point? About this axis of rotation. Or you can take this one also. I am taking this one. Okay, ma? Then the second hinge should give which torque? Positive torque. It means it should produce anti-clockwise rotation. Positive torque means which rotation? Anti-clockwise rotation. About which axis? About the selected axis. So therefore, this hinge should give force in this direction. Let us call it as F3. Okay. Now see, about this axis, this hinge will try to rotate door in which direction? Anti-clockwise direction. Correct only? ఈ యాక్సిస్ చుట్టూ ఈ ఫోర్స్ ఏ డైరెక్షన్లో రొటేట్ చేసే ప్రయత్నం చేస్తుంది డోర్ని? యాంటీ క్లాక్ వైజ్. ఇట్ మీన్స్ ఇట్ ఈస్ పాజిటివ్ టార్క్. సో దేర్ ఫోర్ టార్క్ గివెన్ బై ద హింజ్, విచ్ హింజ్? సెకండ్ హింజ్. దిస్ is second hinge. Is how much ma? Again it is r into f. So radius vector, what is the perpendicular distance from the axis? 2l. So 2l multiplied by, what is the force? Force I don't know, it is F3. But one thing which I know is definitely this is positive torque, because the door is giving negative torque. Now what about this first hinge? What about first hinge? Adi torque ne vada? Ivadu. Endukala? Because it is present on the axis only, no? First hinge in this condition cannot give any torque because axis is present on the hinge itself. Okay, so therefore what I say, torque due to first hinge is how much ma? Torque due to first hinge is 0. Okay, so this is torque due to second hinge, this is torque due to door. Net torque should be how much? 0. Why net torque is 0? Because door is not rotating, no? Door garra ne evana tiruta unda, తిరగడం లేదు కదా, ఇట్ మీన్స్ నెట్ టార్క్ ఇస్ క్లియర్ నమ్మా. యాడ్ ఆల్ ద టార్క్స్. సో టార్క్ డ్యూ టు డోర్ ప్లస్ టార్క్ డ్యూ టు ఫస్ట్ హింజ్ ప్లస్ టార్క్ డ్యూ టు సెకండ్ హింజ్, టోటల్ షుడ్ బి హౌ మచ్ మా? టోటల్ షుడ్ బి 0 బికాస్ నెట్ టార్క్ ఇస్ 0. సో టార్క్ డ్యూ టు డోర్ హౌ మచ్ మా? L/2 into W. Torque due to first hinge, this is minus, no? Minus L/2 into W. So torque due to second hinge, 2L into F3. Clear number? Torque due to third hinge, 0. Total it is equal to 0. Okay. So L get cancelled. So therefore 2 into F3 is equal to W/2. Okay ma? So therefore F3 value is how much? W/4. Understood? So I got one more force. So therefore if I am studying about this second hinge, it is giving two forces, F/2, F2 in upward direction and F3 in perpendicular direction. ఒక హింజ్ రెండు ఫోర్స్లు వేస్తుంది కదా. వన్ ఫోర్స్ టు బ్యాలెన్స్ ట్రాన్స్లేషనల్ మోషన్, వన్ ఫోర్స్ టు బ్యాలెన్స్ రొటేషనల్ మోషన్. అర్థమవుతుంది కదా రెండు ఫోర్స్లు ఎందుకు వచ్చినాయి? వన్ ఫోర్స్ ఈజ్ ప్రెసెంట్ టు బ్యాలెన్స్ డోర్ కిందికి రాకుండా, ఇంకొక ఫోర్స్ డోర్ రొటేట్ అవ్వకుండా, అందుకని ఆ హింజులు వేస్తాం. అర్థమవుతుంది కదా. సో దేర్ ఫోర్ వాట్ ఈస్ ద టోటల్ ఫోర్స్ గివెన్ బై ఈచ్ హింజ్ మా? సో వన్ ఫోర్స్ F2 is in upward direction, one force F3 is in perpendicular direction. So what is the net force then? Net force is, I have to take parallelogram rule of addition number, net force. So F net is how much? It is equal to square root of F2 square plus F3 square. So square root of F2 value already we have calculated, no? W/2. Okay ma? And F3 value is how much? W/4. So W/2 whole square plus W/4 whole square. So whatever answer you will get, that is the net force given by each hinge. ఒక్కొక్క హింజ్ ఇంత ఫోర్స్ని ఇస్తుంది. Is it clear ma how we have calculated? Now that's it. Okay. So now you can calculate this one, no? So how much ma this one? So square root of W square by 4 plus W square by 16. So take LCM as 16. So 4W square plus W square divided by 16. So root 5 W divided by 4. That's it. So that is the force given by each hinge. So he said that forces are equal, no? If second hinge is giving this much force, first hinge also will give same force. That's it. అర్థమవుతుందా ఏం చేస్తున్నాము? సో ట్రాన్స్లేషనల్ ఈక్విలిబ్రియంని బ్యాలెన్స్ చేయడానికి హింజ్ ఒక డైరెక్షన్లో ఫోర్స్ని ఇస్తుంది. ఓకేమా? రొటేషనల్ ఈక్విలిబ్రియం మెయింటైన్ చేయడానికి ఫోర్సు హింజ్ ఇంకొక డైరెక్షన్లో ఫోర్స్ని ఇస్తుంది. సో జస్ట్ యూ టేక్ ద వెక్టర్ సమ్ ఆఫ్ బోత్ ఆఫ్ దమ్, దట్ ఈస్ మై ఆన్సర్. ఓకే, you can take axis of rotation here also. I have selected this point. Understood, no? You can take anything to be your axis of rotation. So next concept which we are studying is kinetic energy in rotational motion. Okay ma? So see here, for example, this is a body of mass m and it is moving with a velocity of v. Okay ma? Then what will be its kinetic energy? So kinetic energy of translation, Noma, this one, what kind of kinetic energy? Translational kinetic energy is half mv square. Clear, no? Kinetic energy because of motion of a body in a straight line. So kinetic energy is equal to half mv square. Clear, no? Similarly, for example, if I take a disk, clear, no? So consider this is a disk rotating about this axis of rotation, okay, with an angular velocity of omega. Angular velocity of this disk is omega. Then its rotational kinetic energy can be written as half I omega square. This is the formula. Clear, no? So half mv square is the kinetic energy of translation and half I omega square is the kinetic energy of rotation. Okay. Now similarly, if I consider that this is a disk, okay. Now see my here, this disk is rotating about center of mass only, no? This is the center of mass of the body also, no? So therefore you can write moment of inertia about a center of mass multiplied by omega square. You can do like this also. Similarly, if a body is rotating about this axis, are you able to understand, ma? With an angular velocity of omega. Similarly, it is translating also. It is moving in a straight line also. Are you able to understand? It means this motion is a combination of translational motion as well as rotational motion. Then this body will have two kinetic energies. No? Kinetic energy because of moving in a straight line also will be there. Similarly, kinetic energy because of rotation also will be present. Okay. So therefore, what is the total kinetic energy? So total kinetic energy, how can I write? I can write it is half I center of mass into omega square plus half mv square. So I can write like this also. Are you able to understand, ma? So half I center of mass into omega square, this is what? This is kinetic energy because of rotation. Clear, ma? And this is the kinetic energy because of translation. So body will have both kinetic energies. Are you able to understand? So half I center of mass into omega square plus half mv square. Are you able to understand? So this is how I can calculate the total kinetic energy of a body. Understood? No? Make a note up to here. Clear, ma? Similarly, now let us see the same body, ma. For example, let us take a condition of rolling condition. Rolling. Okay, ma? What is meant by rolling we will study later. First of all, here let us see. Listen, ma, first of all, then you can write down. See, consider this is a disc, this is a sphere, this is a hollow sphere, anything. Are you able to understand? Consider a ring. Now see here, when body is rolling, what is meant by rolling? Rolling means the point which is in contact with the ground, this point. Are you able to understand, ma? The point which is in contact with this ground or the road on which this body is rolling, this point will be temporarily in rest position. Okay, ma? You should have seen rolling tires, no? So the point which is in contact with the ground, that point will be temporarily in rest position. టైర్లు రోడ్డు పైన రోల్ అవుతున్నాయి, స్లైడ్ అవ్వటం లేదు కదా. దే ఆర్ నాట్ స్లైడింగ్, దే ఆర్ rolling. So what is meant by rolling? This point which is in contact with the ground, that will be temporarily in rest position. So if I take velocity of this point P, then velocity of point P is 0. Okay, ma? But other parts of the tire, definitely it will be having some tangential velocity. But tangential velocity of this point will be how much? 0. That condition is called as rolling condition. Are you able to understand, ma? Now if you take the condition of rolling, so here I will write down. So what is the condition of rolling, ma? Rolling means the point of wheel in contact with the ground, okay, ma, is temporarily at rest position. Okay, ma? It is temporarily at rest position, this point. Other points, they have tangential speed. Okay, ma? For example, if you take this point A, this point A will have tangential speed in this direction, which I can call it as VTA. This point will have tangential speed in this direction. This is point B, which I can call it as VTB. Are you able to understand? But at this point, it will not have any tangential speed. It will be temporarily in rest position. That condition is called as rolling. Okay. So you should have seen a tires rolling on the ground, Nama. The point of the tire which is in contact with the ground, is it sliding? No, it is rolling. Road is in rest position, no? So therefore this point of the tire also must be in rest position. That condition is called as rolling condition. Are you able to understand, ma? Okay. Now in the case of rolling, can you say how can I calculate its total kinetic energy of this wheel, ma? Total kinetic energy of the wheel is how much? Can you say? Chappandi. So let us consider it is having an angular velocity of omega, and its velocity of center of mass is how much? Vcm. Velocity of center of mass is Vcm. Are you able to understand, ma? Now can you say what is its total kinetic energy? How can I calculate? Total kinetic energy is how much? Come on. How many kinetic energies it has? వినటం లేదు సరిగా, ఒకసారి వింటే మళ్ళీ మర్చిపోకూడదు, అలా వినాలి. హౌ మెనీ కైనెటిక్ ఎనర్జీస్ ఇట్ హ్యాస్? 2 kinetic energies. What are they? Kinetic energy because of motion in a straight line. This wheel, it is moving in a straight line, no? So it will have which kinetic energy? It will have kinetic energy because of translation. Translational kinetic energy it will have. Similarly, one more kinetic energy. Kinetic energy because of rotation also it will have, Nama. Both kinetic energies it will have. Okay. So what is the kinetic energy because of translation? Kinetic energy because of translation is half mv center of mass square. That's all, no? Kinetic energy because of rotation? So half I center of mass multiplied by omega square. Okay, ma? Now here what is meant by I center of mass? I center of mass means what? I means moment of inertia. Moment of inertia about which point? Moment of inertia about the center of mass. Clear, no, ma? Because already we studied that moment of inertia depends on axis of rotation, no? Are you able to understand, ma? About which axis we are taking moment of inertia? We are taking moment of inertia about this point, about center of mass. Ee wheel ki center of mass ikkade kada untundi. So around that center of mass, moment of inertia is ICM. Clear, ma? So therefore what is this one? Moment of inertia about what? About the center of mass. Are you able to understand, ma? Up to here it is clear, no? Okay. Now see, ma, in the case of rolling, temporarily I can consider that this total body is rotating about this axis. Okay. Now this body is rolling. Rolling means what? It has a translational motion also, motion in a straight line also. Similarly it has rotational motion also. Rendu motions unnai kada. It is moving in a straight line and it is rotating also. But when the body is rolling, okay. So see, ma, so therefore what is the total kinetic energy, ma? Kinetic energy of translation plus kinetic energy of rotation. Now see, ma. See, ma, when body is rolling, listen very carefully. When body is rolling, this point is in rest position, no, ma? Clear, no? So this point you can call it as the temporary axis of rotation. Okay, ma? Now we are considering two motions, no? Body is having translational motion also, body is having rotation. Rendu unnai kada. But if you take this point to be the axis of rotation, then I can consider body has only rotational motion. Are you able to understand, ma? If you take this axis, ide kada rest lo unna point and axis will be always in rest position, no, ma? So if you take this point to be the axis of rotation, it means if you remove this total rod, okay, ma? Then I can assume that this body is totally rotating about this axis. Then the body does not have translational motion. It has only rotational motion maatrame untundi. Clear, no, ma? So therefore what I say, for example, if this is the rolling body, clear, no, ma? Rolling with an angular velocity of omega, velocity of center of mass is Vcm. Okay, ma? This point I can take it as IAR, or you can call it as instantaneous axis of rotation. Okay, ma? Just, or you can call it as instantaneous axis of rotation. Okay, ma? IOR also you can call it as instantaneous axis of rotation. Instantaneous axis of rotation means what? I will assume that
temporarily body is rotating about this point. Okay, ma? So it means that if you remove this total roll, what will happen after some time? The body may be rotating like this. Okay, so it is moving around this point. After some time I can assume body is rotating like this. After some time I can assume body is rotating like this. Are you able to understand, ma? Actually, definitely it is moving on a road. But I will assume temporarily this I will consider to be my axis of rotation. If you consider this one to be the temporary axis of rotation, then body is not undergoing a translational motion, no, it is rotating about this point. Are you able to understand? Then in that condition, the kinetic energy of, or you can say total kinetic energy, I can call it as half I axis multiplied by omega square. So this is the equation for total kinetic energy in which condition? Where I take this point to be my axis of rotation. Okay, ma? And total kinetic energy here I have written in which manner? Kinetic energy because of translation plus kinetic energy because of rotation. This one, is it correct, or this one, is it correct? Edi correct in the loop? Both are correct. Clear, nama? Here you are taking a translation motion individually and rotational motion individually. But here what I am doing, I am taking this point to be my temporary axis of rotation. Are you able to understand, ma? And moment of inertia I have to take about which point? Here I have taken moment of inertia about center of mass, no? Okay, ma? Here I have taken moment of inertia about which point? About that point which is in contact with the ground. Ground to tire contact lo untundi kada. About that point I have taken moment of inertia. And this is again equal to kinetic energy because of rotation plus kinetic energy because of translation. Again same concept. Clear, number? So again kinetic energy of due to translation is half I center of mass into omega square plus half m v center of mass square. Both are correct. Are you able to understand? So you can take this one to be your axis and you can use this relation. Then you will get total kinetic energy. But if we want individually the kinetic energies, then you can take kinetic energy because of rotation separately, kinetic energy because of translation separately. Clear? That's it. Make it out. Kinetic energy of disk of mass 10 kg of radius 1 meter, center of mass moving with a velocity of 10 meter per second, and the disk is rolling. Disk is rolling disk. Okay, so let us. So therefore, consider this is the disk whose velocity of center of mass is how much? Velocity of center of mass is 10 meters per second. And what is the radius of the disk, ma? 1 meter. And it is rolling with a particular angular velocity which is not given. Okay, ma? So first of all, kinetic energy I will try to calculate in both the methods. We studied two methods of calculating kinetic energy, no, ma? We will try to use both of them. Okay. So method number one. So total kinetic energy, how can I calculate? It is half I axis multiplied by omega square. In this method I can calculate, no? What is I axis? This point. I can consider body is rotating about this axis. So this is IOR. What is IOR? Instantaneous axis of rotation. I will consider body is rotating about this axis and I will try to calculate its total kinetic energy. Okay, ma? Omega value, is it given? No. Therefore, how can I calculate? If omega is not given, how can I calculate? Chapandi. What is the angular velocity of this disk? Come on. Sima, V velocity of center of mass, I can call it as omega into r, no, ma? Velocity of center of mass I can call it as omega into r, or V tangential is equals to omega into r. This formula we know. Are you able to understand? Now see. Now if you take this point to be my axis of rotation, body is rotating about this axis. Now from the axis of rotation, if I start moving away from the axis, V tangential also increases, no, ma? Already మనం చదువుకున్నాం కదా, గుర్తుందా? Clear, ma? We have taken one body, clear, no, ma? Which is rotating about any axis of rotation. This is the axis of rotation. Okay. Then we have taken 2 points or 3 points, no? Point number 1 and point number 2. After some time, these points they reach up to here. Point number 1, point number 2. Okay.
this point covers less distance, point number 2 covers greater distance. It means whose tangential speed is greater? Tangential speed of point number 2 should be greater, no? Because it should cover greater distance. It means if I move away from the axis nunchi bayatiki velle koddi, tangential speed continuously increases. That's what we have studied now. Same point apply here also. So V tangential, this is the axis of rotation, no? So disk is rotating about this axis. Are you able to understand, no? So if I start moving away from the axis, tangential speed should continuously increasing, no? But total disk have same angular velocity, no? If you take point number 1 and point number 2, they will cover same angle in same time, no? So angular velocity of point number 1, angular velocity of point number 2 is same. So it means for total disk, omega value remains same. Are you able to understand, ma? So therefore, if I take this, if I want to calculate a tangential speed of this point, that is nothing but velocity of center of mass also, no? Are you able to understand, ma? So V tangential is equals to omega into R is equals to velocity of center of mass. Okay. Therefore, what is omega value? V center of mass divided by R. Vinal. What is the velocity of center of mass? 10. And what is this distance, ma? From the axis, what is this distance? This distance is nothing but radius 1 meter. So substitute 1 meter here. So 10 by 1 is how much? 10 by 1 is how much, ma? It is 10 radians per second. So this is the angular velocity of this disk. Understood now how I calculated angular velocity? So this total disk is rotating with how much angular velocity, ma? With an angular velocity of 10 radians per second. Is it clear how I have calculated? What about the tangential speed of this point? This point will have different tangential speed, but angular velocity remains same because every point will cover same angle and same time. Omega same untundi prati point. Tangential speed will not be constant. Already we discussed similarities and dissimilarities, no? Based on that concept, we are doing this calculation. Is it clear, ma? Okay, now see. So therefore, omega value I have calculated, which is 10 radians per second. Now what about I-axis? What is the moment of inertia of this disk about this axis? For example, if this is the disk, this is the center of mass of disk, no, ma? I center of mass is how much? Half mr square. This already we know, no? For a disk moment of inertia, half mr square. But I want about this axis, no? Okay. So axis will be like this. This axis also will be like this. So these two axes, are they parallel or are they perpendicular? Parallel. Therefore use parallel axis theorem. Gurtunna ivanni? Parallel axis theorem. What is parallel axis theorem? I is equals to, this is I, or you can call it as I axis. I axis is equals to I center of mass plus md square. This is parallel axis theorem, no? Okay. What is I center of mass? For a disk, what is I center of mass? Half mr square. So half mr square plus m into, what is this distance? This distance is d, no? Distance between two axes. D is nothing but r here. So mr square. So total how much, ma? 3 by 2 mr square. So this is I axis of the disk. Are you able to understand, ma, how we are calculating? So therefore calculate the total kinetic energy. Total kinetic energy formula is how much? Half I axis into omega square. So half of, what is I axis? So 3 by 2 mr square multiplied by omega. What is the omega? Omega value is 10. So 10 square. Clear now? So half into 3 by 2 into, what is the Ri here also? I will write omega only. Okay, ma? 3 by 2. What is the mass of the body, ma? Mass of the body is 10 kg. Radius is 1 meter. Angular velocity is 10 square, which is 100. Okay, so if you do this total calculation, 25 into 3 into 10. So how much, ma? 750 joules is the total kinetic energy. That's all, no? So this is by using which method, ma? By taking this point to be my axis of rotation. If I consider this total disk is rotating around this point. Are you able to understand? Instantaneous axis of rotation I have taken, and total kinetic energy is, it is having only rotational energy, no? If I consider like this, and rotational kinetic energy formula is half I axis into omega square. I axis how I have calculated by using parallel access theorem, and I have done the calculation. Okay. Now let us try to do in second method, and let us check whether I will get the same answer or not. Clear? Okay, ma? So we are doing in second method. Ma. What is second method? Considering translational energy separately, rotational kinetic energy separately. Clear, na? It means now which is my axis of rotation? This is my axis of rotation. Okay. Body is rotating about this axis and it is moving also. Previously we have taken this to be the axis of rotation. No? That is the difference. So kinetic energy of because of translation half mv center of mass square. Kinetic energy of due to rotation half I center of mass into omega square. Now disk is rotating about center of mass. No? So I center of mass into omega square. Understood now? So write down half into mass of the body 10 kg, no? 10. Velocity of center of mass is 10. So 10 square. Clear number? Plus half I center of mass. So moment of inertia about center of mass is half mr square. So half into mass of the body is 10. Radius is 1 square. So total how much? 5. So 5 kg meter square. So I center of mass is 5. Omega value is 10 square. So how much? 500 plus 250. 500 plus 250 is how much? 750 joules of energy. Okay. So in this method also I got the same energy, no? Are you able to understand? So like this you can do. So you can take this point to be temporary axis of rotation and calculate half I axis into omega square. So in that condition body has only rotational energy. Okay, ma? But if you take general condition where body is moving also, it is rotating also, and this is the axis of rotation, then you have to take translational energy separately, rotational energy separately. But whatever it may be, always you get the same answer. Okay. And what is this 500 ma? 500 is kinetic energy because of moving in a straight line, translational motion. Rotational energy means this is the energy because of rotational motion. Okay, that's it. Now see ma, here let us discuss the work done in the case of rotational motion. Clear? See here, first of all we will try to understand translational motion, then analogously we will try to derive rotational motion. See ma. So on a body, if a force is applied on a frictionless surface, then how much acceleration will be produced? A is equals to F by M. Clear now? Because of this acceleration, body will start movement. So it will move by a distance of S. So what is the work done in translational motion? Force into displacement. We know, no? We know this relation, no? W is equal to F into S. Clear, no? So or you can write F into S2 minus S1 also. What is S2? Final displacement. S1 is initial displacement or initial position. Okay. So S2 minus S1 will give again S, the final displacement of the body. Same concept if I try to study in rotational motion. Now see, this is a body which is rotating and I am applying a force on this body, tangential force. So this tangential force will make the body to accelerate. Angular acceleration will be produced. Here what acceleration is produced? Linear acceleration is produced. Here angular acceleration will be produced. So if I multiply this force with this perpendicular distance r, then it becomes a torque. Torque is equal to r into F. Are you able to understand? So we know that torque is equals to I into alpha, which is analogous equation of F is equals to M into E. This is the analogous equation of this one, no? Torque is equal to I into alpha. Already we studied all these calculations. Therefore, what is alpha value? Alpha value is equal to torque divided by moment of inertia. Again, these two, they are analogous. Clear? No? A is equal to F by M. A means acceleration, alpha means angular acceleration. Force produces acceleration, here torque produces acceleration. Mass is the measure of moment of inertia. Here I have mass is the measure of linear inertia and I is the measure of moment of inertia. They are analogous equations, no? Okay, now see. So therefore, here what is the equation of work done? Force into displacement. Same equation of work done in rotational motion. How can I write? Instead of force? Instead of force, torque. That's all, no? Torque and force, they are analogous, no? Instead of displacement, చెప్పండి, displacement. Angular displacement is given by theta. That's all. So here, by applying some force, body will move in a distance of s. Here when you apply force, body starts rotation. It will cover a small angle of theta. Are you able to understand? So here displacement, here angular displacement. So this is the equation of work done in the case of rotational motion. Just by analogy we are trying to remember. Analogy gurtunte chalu, equation also you can remember. Are you able to understand? Or instead of writing in this method, if I want to write in this method, how can I write? Work done in rotational motion is equals to torque into theta 2 minus theta 1. So this is the equation of work done. Are you able to understand? Similarly, I can write equation of power also. No, power is equals to, I can write force into velocity. This is the equation of power, no, in translational motion. Same equation of power in rotational motion, how can I write? Power is equals to torque. Instead of velocity, angular velocity. So power is equals to torque into angular velocity. So you can write like this also. Are you able to understand? That's it. Make a note of this one. In rotational motion. So in translational motion also we studied same equation. Work done is equal to change in kinetic energy of the body. And we have done many calculations also. Work done is equal to change in kinetic energy. Clear, Nama? And how many types of work can be done? How many types of work can be done, ma? Work can be done by conservative forces, work can be done by non-conservative forces, work can be done by pseudo forces, work can be done by other external forces. Total is equal to change in kinetic energy. Okay? We have done many questions on this one now. And in rotational motion, just we will get an additional kinetic energy, rotational kinetic energy also we will get. If body has a translational, it will get a change in translational energy. If body has rotational energy, there will be change in rotational energy also. Okay, so delta K represents what here? Delta K represents change in both translational as well as rotational energies. Are you able to understand, ma? Translational energy is also changing, rotational energy is also changing. Clear, no? So then we have studied work potential energy theorem also, no? What is work potential energy theorem? Work done is equals to, work done by conservative forces is equals to negative of change in potential energy. Do you remember this one? If a conservative forces will do positive work, then potential energy of the body decreases. We studied now already. If conservative forces does negative work, then potential energy of the body increases. Work energy theorem lo chadukunnam kada idi, same concept we are using here also. Okay. So therefore if I write, if only conservative forces are acting, if only conservative forces are acting, are you able to understand? If only conservative forces are acting, then this force is not there, this force is not there, this force also it is not present. So only which force is present, ma? Only conservative forces, if they are present, then this is equal to change in kinetic energy. Now instead of conservative forces, what I can write? Minus delta U. So minus delta U is equals to delta K. Therefore I can write delta U plus delta K is equal to 0. What is the meaning of this one? If only conservative forces are acting, change in kinetic energy plus change in potential energy is 0. It means finally kinetic energy also will not change, potential energy also will not change. In which condition? If only conservative forces are acting. Are you able to understand, ma? So, or you can say the sum of kinetic energy, potential energy will change, ma. But sum of changes will be how much? Sum of changes will be 0. So therefore what we say, total change in mechanical energy is 0. Sum of kinetic energy plus potential energy is called what? Mechanical energy. So total change in mechanical energy is not there. It means mechanical energy remains constant. Clear, no? So this equation also I can write U2 minus U1 plus delta K, I can write K2 minus K1. Total is equal to 0. Clear, no? So therefore I can write K1 plus U1 is equals to K2 plus U2. What is the meaning of this one? This is total initial mechanical energy. And what is this one? This is final mechanical energy. Understood? No? It means mechanical energy change doesn't happen. In which condition? If only conservative forces are active. Same equations we derived in work power energy also. Here also same equations. But what is the difference between in that chapter and in this chapter? Here I have change in kinetic energy, no? Here I will get additionally change in rotational energy also. అక్కడ లీనియర్ కైనెటిక్ ఎనర్జీ మాత్రం చదువుకుంటాం కదా. హియర్ ఐ విల్ గెట్ ఇన్ అడిషనలీ rotational kinetic energy also. That's it. Remaining everything is same. Okay, ma? So therefore, total change in mechanical energy is 0. It means initial mechanical energy and final mechanical energy, they are equal. In which condition? If only conservative forces are active. That's it. And what are the conservative forces? Gravitational force is a conservative force. Electrostatic force is a conservative force. Spring force is a conservative force. Remaining many of the forces, they are non-conservative forces. Friction, non-conservative force. Are you able to understand? Ma? Like a disc-shaped pulley, ma, a wire is surrounded to this pulley, and other end of the rope is connected to a mass of 4 kg. That is the given data. No? Now when I release this system, initial angular velocity is 0. I am releasing this system, and weight of this 4 kg body will pull this 4 kg number downwards. So disc starts unrolling. It starts unrolling the what you call that rope. Clear, no? So mass given, radius given, find the angular velocity of the disc after 10 seconds. It means this body, after it falls through a distance of 10 seconds, time of 10 seconds, then at that instant what will be the angular velocity of the disc? Okay, let us see. See ma, here let us write the free body diagram of 4 kg body. If I draw the free body diagram of 4 kg body, on 4 kg body how many forces are acting, ma? Its own weight 40 Newton will be acting in downwards direction, and tension T will be acting in upward direction. Here in the rope tension T will be there, no? So tension will be always in which direction? Away from the tied end. Okay, but body will accelerate in downwards direction, no? So therefore which force is greater than which force? 40 is greater than tension. So I can write 40 minus T is equal to mass into acceleration. So 40 minus T is mass of the body is 4, acceleration I don't know, so let it be my first equation. Understood, no? Now same tension will be pulling this rope in downwards direction. Already we studied tension is always equal and opposite. Tension is always equal and opposite in a massless string. If you take mass also to a string, then it is a different condition. But we are not taking mass of the mass of the rope or string we are not taking. Okay. Now what this tension will do? This tension tries to pull the rope downwards, no? It means it is trying to accelerate the pulley. It is trying to give angular acceleration to the pulley. Okay, ma? Therefore torque will be produced, no? Torque formula, R into F is equals to I into alpha. This is the equation of torque, no? Clear, no? So therefore radius is how much? Force is applied at what radius, ma? Tension ante force hai kada. Force is applied at what distance? At a distance of R is equal to 1 meter. So 1 meter multiplied by force applied is nothing but tension. So moment of inertia of a disc is how much? Half mr squared multiplied by alpha. That's all. So therefore tension is equals to half. Mass of the disc is 10. Radius of the disc is 1. Alpha value I don't know. So T is equals to 5 alpha. This is the relation which I got. T is equal to 5 alpha. Now what is A and what is alpha? See the unknown quantities. 1, 2, 3. 3 unknown quantities. But how many equations? 2 equations. It means I require one more equation. Third equation ekkadi nunchi vastund cheppandi. Already chadukunnavandi. Already we studied this kind of model previously. Third equation, from where can I get? Constraint motion. Okay. Sima, this is the pulley, no? Okay. Acceleration of the mass is how much? Acceleration of the mass is A. Acceleration of the rope is how much? Acceleration of the rope is also A. Tangential acceleration of the pulley is how much? That is also A. Because same rope is connected with the pulley. No? Pulley speed acceleration ఎంత ఉంటుందో rope acceleration కూడా అంతే ఉంటుంది. So ropes pulley's tangential acceleration is A itself. Okay. And what is the equation of tangential acceleration? R into alpha. So this is my third equation. Equation number 3. This is my equation number 2. Clear number? From both of them, I am supposed to find out A value. Because I don't know our omega value, can I calculate it directly? Okay, let us see. Clear number? So therefore, what I will do, take this alpha and substitute here. Instead of alpha, I can write A by R number. Instead of alpha, I can write A by R. So substitute here. So therefore, tension is equals to 5 into A by R. Okay. So 5 into A divided by radius is how much? 1 meter. So 5 into A. Are you able to understand, ma? Now solve these two equations. So 40 minus T. So this one I am substituting here, ma, don't be confused. Clear? So 40 minus T is equal to 4A, and I got tension is equals to 4A. So 40 minus tension is 5A is equal to 4A. So therefore 9A is equals to 40. So A is equals to 40 by 9 meters per second square. So acceleration I have calculated. Are you able to understand, ma? So acceleration of this body I have calculated. Same is the acceleration of rope also. Same is the tangential acceleration of pulley also. After how much time? Not how much time. The acceleration produced is this much. 40 by 9 is the acceleration. Are you able to understand? Okay. So therefore, now see. Now take the free body diagram of this. No need of free body diagram. No. Just I can use the relation S is equals to ut plus half at square. So distance after 10 seconds he gave no. So let us take a final velocity. I will take V is equals to u plus at. So final velocity of the body is equals to initial velocity is 0, acceleration is 40 by 9, and time taken is how much more? Time taken is 10 seconds. So 40 by 9 meters per second. So this is the velocity of this mass. Very carefully. First listen very carefully, then we can understand. Okay, ma? So what is the velocity of 4 kg body after 10 seconds? It has an acceleration of 40 by 9, no? So we are calculating final velocity. After 4 seconds, what will be the final velocity? V is equal to u plus 80, 400 by 9 meters per second. Again, we use the constraint relation. See here. Acceleration of the mass is, velocity of the mass is how much? 400 by 9. Clear, no? Velocity of the rope will be how much? 400 by 9. Clear, no? Tangential velocity of pulley will be how much? 400 by 9 meters per second. Rope ki anta velocity untundo, pulley kuda ante tangential velocity untundi. Is it clear? Once I calculate a tangential velocity of the pulley, it is equal to omega into r, no? Tangential velocity formula? Omega into r. So therefore V tangential, what I want omega, no? So V tangential is equal to omega into r. So omega value is V tangential divided by r. V tangential is how much? 400 divided by 9. Radius is 1. So omega is equals to 400 by 9 radians per second. That's all. That is my answer. Okay, ma? So this one I have done by which method? General method of solving. Okay. I have not used law of conservation of energy, no? So first of all, do in this method. Then we will study how to solve by using law of conservation of energy. అర్థమైందా ఎలా చేసుకుంటూ వెళ్దాము ప్రాసెస్? క్లియర్ నమ్మా? సో ఫస్ట్ ఈక్వేషన్ బై యూజింగ్ న్యూటన్స్ లాస్, సెకండ్ ఈక్వేషన్ బై యూజింగ్ టార్క్ ఈక్వేషన్. సో బట్ ఆల్ఫా ఐ డోంట్ నో, ఐ హ్యావ్ యూజ్డ్ కన్స్టెంట్ రిలేషన్, అండ్ బై సాల్వింగ్ ఆల్ ఆఫ్ దట్ ఐ గాట్ ఏ యాక్సిలరేషన్. Once I get acceleration, I can calculate final velocity of the block. Final velocity of the block is nothing but tangential velocity of the pulley. Once I know tangential velocity, I can calculate omega. So this is the process in which I have proceeded in the problem. Okay, that's it. So while practicing, try to calculate like this one. When you don't understand, you should ask the teacher. Batti kottakudu dene kuda. Clear? Law of conservation of energy. Law of conservation of energy. Are you able to understand me? Now see. So here on this system, external forces, are they present or not? Leave. Gravitational force ఉంది కదా. Gravitational force is pulling 4 kg body downwards, no? So gravitational force is present. So gravitational force is what kind of force? Conservative force. Any other forces? Tension is there, but tension is an internal force. Tension కూడా ఫోర్సే కదా, కానీ టెన్షన్ ఏ టైప్ ఆఫ్ ఫోర్స్? ఇంటర్నల్ ఫోర్స్. బయట నుంచి ఏం యాక్ట్ అవ్వటం లేదు కదా, ఇట్ ఈస్ ఇంటర్నల్ ఫోర్స్. యూ నీడ్ నాట్ కన్సిడర్ దట్. అండ్ వర్క్ డన్ బై టెన్షన్ ఈస్ ఆల్వేస్ జీరో. ఆల్రెడీ వీ హ్యావ్ స్టడీడ్. వర్క్ డన్ బై టోటల్ టెన్షన్ విల్ బి జీరో. So therefore, only gravitational force is acting. So I can use law of conservation of mechanical energy. I can use this law of conservation of mechanical energy. Okay. So what is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. This is law of conservation of mechanical energy. No? Okay. So what is K1? Initial kinetic energy. It means when I release this system, immediately there are no kinetic energies. No, this body is also in rest position, disk is also in rest position. So total initial kinetic energy is zero. Understood now? No. Then potential energy. Let us take this position to be initial potential energy. This position to be initial potential energy. Or you can take this reference to be zero potential energy reference. Are you able to understand, ma? Position of the disk will never change. No, disk will be present at the same position. But at this mass, it starts continuously moving downwards. Are you able to understand? So, zero potential energy, this reference I am taking. So, initial potential energy is how much more? Initial potential energy is zero. Because the initial position itself I have taken to be my reference of zero potential energy. Already we studied, no? Potential energy you can never define without a reference. రెఫరెన్స్ లేకుండా పొటెన్షియల్ ఎనర్జీని మనము డిఫైన్ చేయలేము. ఓకే. సో దిస్ ఇస్ ద రెఫరెన్స్ అండ్ అట్ దట్ పొజిషన్ పొటెన్షియల్ ఎనర్జీ ఈస్ జీరో. ఓకే మా. ఫైనల్ కైనెటిక్ ఎనర్జీ. సో లెట్ us రైట్ హియర్. ఓకే మా. సో K2 means what? Final kinetic energy. Now see, when this body, when it reaches up to a distance, this mass will have some velocity. Similarly, this disk also will have some velocity, angular velocity. Okay ma. So total kinetic energy is kinetic energy because of mass plus kinetic energy because of disk. Rendu kinetic energies kuda untayi kada. Mass will have which type of kinetic energy? Mass ki type of kinetic energy untundi? Translational or rotational? Translational kinetic energy. And what is the formula for translational kinetic energy, ma? VCM square. Okay. And disk will have which kind of energy? Rotational energy. What is the formula for rotational energy? Half I center of mass into omega square. These are the two energies. Are you able to understand? And final potential energy. So let us consider this mass, it reaches somewhere up to here. Okay ma? Mass reaches somewhere up to here. So it has come downwards by a height of h. That's all, no? ఈ మాస్ కొంచెం కిందకి వస్తుంది కదా, 4 kg body. And what is the height reached by the body? I don't know. So let us assume that height to be h. Understood, no? So therefore, final potential energy will be how much? Minus mgh. Very good. Why minus mgh? It has reached a negative distance, no? So zero potential energy reference is there. Above that reference, potential energy is positive. Below that reference, potential energy will be negative. So minus mgh. Clear, no? Now substitute in the total equation. So K1 plus U1 is equals to K2 plus U2. Initial kinetic energy is 0, initial potential energy is 0. Final kinetic energy is half mv square plus half I center of mass into omega square minus mgh. That's all, no? Okay. So from this total calculation, what I require? I require omega value, no? Are you able to understand, ma? Now see. So here, what is meant by V? V means what? V means velocity of the mass, final velocity of the mass. Velocity of the mass equal to velocity of rope, no? Velocity of rope equal to tangential velocity of the disk also, no? Again by using constraint relation. Are you able to understand? So V means velocity of mass, velocity of rope, velocity of disk also. Clear, no? I already chadukunnanu constraint portion. And V tangential formula omega into r. So instead of V, what I can write? Omega into r. So write down. So 0 is equals to
half into m into, instead of v I can write omega into r whole square plus half I center of mass into omega square minus mgh. So I got equation up to here. Okay ma? So I require omega. Omega ganagado నాకు కావాల్సింది. So m I know, r I know, I center of mass I know, everything I know, but h value I don't. H value I don't. What is the height reached by the body? Do I know that? I don't know. So first of all I have to calculate h value. So how can I calculate h value? Okay ma? So already in the previous condition I calculated acceleration, no? Are you able to understand ma? So can't I calculate s is equal to ut plus half at square? Okay. So h is equals to 0 plus half. What is the acceleration in the previous condition ma? 40 by 9 into time is how much? 10 square. Clear no? So therefore how much ma? Half into, I can write 20 by 9 multiplied by 100. Clear no ma? So 2000 divided by 9. So this is the height reached by the particle. Okay. So take this height and substitute here, then omega is the only unknown quantity, no? Calculate omega, that is my required answer. Is it clear? That's it. So therefore substituting here, what I will get? So 0 is equals to half into m into omega square r square plus half I center of mass into omega square minus mg into h. H value is 200. Or let us substitute all the values, no? All the values we don't know, let us substitute all the values. So 0 is equals to half. So mass of the mass is how much? 4 kg. And omega value I don't know. Omega square, radius. Radius is how much? Radius is 1 square. Okay ma? Plus half. What is the moment of inertia of a disc? Half mr square. So half into mass of the disc is 10 kg. Radius of the disc is 1 square multiplied by omega square. Okay ma? So minus again mgh. M means mass of the mass, no? 4 kg. G value is 10. Height is how much? Height is 2000 divided by 9. Omega is the only unknown quantity, no ma? So calculate omega, that is my required answer. Like this also I can. Understood now how we are calculating? Okay. So previously we have used the general method. Now this is the method of force method, previous method. This method by using law of conservation of energy. So understood now, say here. So here I will get 4 2s are 8 now, 8 2s are 16. So this side also I have multiplied by 2. Okay. And here if I take omega square common, then it is 5 plus 4 9, no? Again 9 if it comes to this side, 9 9s are 81. So root of 1,60,000 divided by 81 is nothing but, so 16 root is 4, root of 10,000 is 100. So 40 divided by root 81 is 9, 40 by 9. That's it. Okay. So this is the second method of doing the calculation. The first method we have calculated by using force method, and this method by using energy method. Okay. So this is the question. So this wheel has a moment of inertia of I m, radius is r. Okay, this is a mass which is attached to one end of this rope. Now when I release this system, this mass, when it falls by a distance of h, okay, then we are supposed to find out, well, what will be the speed of this block. Clear now? When it has fallen by a distance of h, what will be the speed of the block that I want to calculate. Okay. So can you say how can I do this calculation now? Law of conservation of which energy? Energy or mechanical energy? Law of conservation of mechanical energy I can use here. How can you say? See, this mass is being attracted by earth, no? So here gravitational force is acting, and spring will elongate, no? When mass falls down by a distance of h. Clear, no? When it falls by a distance of h, spring also elongates by a distance of h only. So x value will be equal to h. Elongation in the spring also will be h only, no? And spring will develop a restoring force. Are you able to understand? So because of restoring force, some potential energy will be developed in the spring. So spring force is also what kind of force? Conservative force or not? Spring force also definitely conservative force only.
Are you able to understand? So only conservative forces are acting, no? So gravitational force is a conservative force. Clear now? Spring force is also a conservative force. So if only conservative forces are acting, then what I can do? Then I can use law of conservation of mechanical energy, which says that K1 plus U1 is equals to K2 plus U2. So this is the equation now. Okay. Now let us do the calculation. So what is K1? Initial kinetic energy. Before this mass is released, so this pulley also does not have any kinetic energy, mass also does not have any kinetic energy immediately when I release the system. So initial kinetic energy is how much? K1 is equal to 0. Clear now? Similarly, let us take this reference. This reference to be 0 potential energy reference. Clear now? Initial position of the mass only I am taking as 0 potential energy reference. So therefore, initial potential energy is how much? U1 is also 0, because potential energy always depends on reference number. So this is the reference which I am taking. So definitely initial potential energy is also 0. So K2, what is K2? Final kinetic energy. Now can you say how much will be the final kinetic energy? Suppose half mv square. For which body? For this mass. When this mass reaches a distance of h, it will be having a velocity of v. Clear no? So therefore its kinetic energy will be half mv square. Completed. This pulley also will be rotating, no? Pulley also will be rotating, no? So if it is rotating, it will have what kind of energy? Rotational energy. So what is the formula for rotational energy? So by the time it reaches a height of h, let us consider it has an angular velocity of omega. Are you able to understand? No? This has an angular velocity of omega. So therefore I will write half I omega square. So this is final kinetic energy. Okay. What about final potential energy U2? Minus mgh. For which body? For the mass. So this has fallen by height of h normal. So it has covered negative distance. So potential energy also will be negative. So therefore minus mgh. Still. What about this pulley? What about pulley? Hello? So what about the potential energy of this pulley? Pulley, you cannot consider its potential energy because its initial position and final position is same. You need not consider. But what about the potential energy of the spring? Spring will elongate, no? When this mass, when it falls down by distance of h, spring also elongates by how much length? H length only. What is the formula to calculate potential energy stored in a spring? Half k x square. So plus half k, instead of x I will write h square. That's all. No? So potential energy stored in a spring. This is the formula, no? Half k h square. So therefore all the parameters we have calculated, no? Just substitute in this equation k1 plus u1 is equals to k2 plus u2. Then calculate what he is asking. Calculate this velocity of the block. V value you calculate, that is my answer. Okay. But omega value, is it known? Do you know omega value? No. Then how can you? Omega value I don't know, no? Torque. టార్క్ ఎంతో తెలియదు నాకు, ఫోర్స్ ఎంతో తెలియదు. తర్వాత we don't know tension also, no? We don't know time also. We don't know anything. So how can I calculate omega value? This is the only unknown quantity which we need to find out. Omega value, how can I calculate? Constraint relations are there, no? What is meant by constraint relations? Sima. If this mass has a velocity of v, this rope also will have how much velocity? Rope also will have a velocity of rope is equal to v. What is the tangential velocity of the pulley? Tangential velocity of the pulley is also v. That's all. Yesterday only we studied, no? Mass is having a velocity of v. Then rope also will have same velocity. Pulley also will have same tangential velocity or tangential speed. So therefore Vt is equals to V is equals to omega into, Vt is equals to V is equals to omega into R. This is the formula for tangential speed, no? Okay. From this can't you find out omega value? What is omega? V divided by R. So take this omega and substitute here. Okay. Now do the calculation. So find out V value, finally see what is the answer you will get. So K1 plus U1 is equals to K2 plus U2. Initial kinetic energy 0, initial potential energy 0. Final kinetic energy is how much? It is half mv square plus half I omega square plus final potential energy is minus mgh plus half k h square. Clear now? Now substitute all the values and find out V tangential or V value, that is my answer. Okay, ma? Instead of omega square, what can you write? I can write V by R whole square. Okay? That's it. Okay, ma? So this is the final answer which you should get. So root 2mgh minus kh square divided by m into 1 plus I by mr square. Okay? Check whether you get this answer or not. That's it. That's it. Okay. See ma, here these are two discs. This is one disc, this is another disc. So this is the common axis through which this disc can rotate, and these discs, they are welded together. Okay, ma? It means this is one bigger disc and this is one smaller disc. Are you able to understand? And this is the axis of rotation. Around this axis, this disc, they are rotating. So radius of one disc is 2r and radius of another disc is r. Clear? Mass of this one is 2m and mass of smaller disc is m. This is the given condition. Next, on the smaller disc, we are winding some wire. Some wire is wound and other end of the wire is connected to a mass of m naught. Are you able to understand? And this total system, it is released from a height of h from the ground. So first question is, what is the total moment of inertia of this system? Second question is, by the time this m naught touches this ground, what will be its velocity? What will be the velocity of the mass m naught? Understood now? Okay. Okay, let us do this problem. So can you say what is the total moment of inertia of this system? Moment of inertia of total system will be how much? Chapandi. Moment of inertia of total system will be moment of inertia of first disk plus moment of inertia of second disk. Ante kada? Are you able to understand? So moment of inertia of first disk plus moment of inertia of second disk. Okay. This mass is also there, Mama. Mass is not rotating. So only this is the total moment of inertia, I1 plus I2. Mass kuda undi kada ikkada. The system is moment of inertia of first disk plus moment of inertia of second disk. Clear nama? So what is the moment of inertia of first disk, bigger disk? Moment of inertia formula cheppandi disk ki. Half mr square. Half into mass of bigger disk is 2m and its radius is 2r no, so 2r whole square. Clear? Plus mass of the smaller disk, half into mass is m, radius is r square, half mr square. So do this total calculation, half into 2m into 4r square plus half into m into r square. So half into 8 mr square plus half into mr square. Clear now? Half if I take common, then it is 8 mr square plus mr square, 9 mr square. So total how much it is? It is equals to 9 by 2 mr square. That's all. No? So this is the total moment of inertia of this system, 9 by 2 mr square. Understood now? Okay. Now what I am doing is, now I am releasing this system. If I release this system, see now this mass m naught, it is suspended like this. No? This is how this mass m naught is suspended now. Wire is wound around this smaller disk and it is suspended. So if I release this mass, weight of this mass will pull this smaller disk downwards. So smaller disk rotates and smaller disk is welded with the bigger disk number. Bigger disk also will rotate. So therefore by the time it touches the ground, with what velocity it will touch? How can I calculate? How many forces are present? Only gravitational force is present, there is no other force. So if only gravitational force is present, what can we do? Law of conservation of mechanical energy. This is what I can use now. So what is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. That's all. Where forces will leave. So initial kinetic energy 0 because system was in resting position before releasing. Similarly, let us take this height to be 0 potential energy reference. Okay, ma? So therefore initial potential energy also 0. Now final kinetic energy means what? When this mass is about to touch the ground, so by the time it reaches here, it will have some velocity, no? Okay, ma? Its velocity is v. So therefore final kinetic energy is how much? Half m naught into velocity square, v square. That's all. No? Then what about rotational kinetic energy of this total system? Not only this mass is moving, system is rotating also, no? Disks are rotating also. Then they will have rotational kinetic energy also, no? What is the formula for rotational kinetic energy? Half I into omega square. So this is the total kinetic energy of the system. Clear, no? Then what about potential energy? Potential energy only for this mass. So negative potential energy, no, it has come downwards from the reference. So therefore it is minus m naught into g into h. That's all, no? So from this what he is asking to calculate v value. But do I know omega value? Omega value I don't know. So what can I do? Again constraint relation, same concept. Clear, no? So v tangential is equals to v is equals to omega into r. That's all, no? If velocity of this mass is v, velocity of rope is how much? Velocity of rope is also v. If velocity of rope is how much, tangential speed of the pulley is how much? Tangential speed of pulley is also v. Which pulley? Bigger pulley or smaller pulley? Smaller pulley is a tangential speed is v. Are you able to understand? So therefore v is equals to omega into r. R means smaller or 2r? Smaller only, no? Because rope is attached to smaller disc. So I will write small r. So therefore what is omega value, ma? Omega is equals to v divided by r. Okay. So take this omega value and substitute here. Okay. Then what is the only unknown quantity we have? Only unknown quantity is v. Calculate v value, that is my required answer. That's it. Okay. That's it. So if you do this total calculation, I am writing the answer, ma, what you should get. Check whether you get that answer or not. So v is equals to root of 4 m naught gh divided by 9m plus 2 m naught. That is the final answer which you should get. Okay. Side, ma. So see this question, ma. So this is a vertical rod, ma. Vertical rod means we know, no? Rod is like this and this is the axis of rotation. Clear? So we are slightly pushing this rod and we are releasing. Initially it was in rest position. We are slightly pushing and releasing. Then we are supposed to find out angular velocity as well as linear velocity of one end of the rod by the time it becomes horizontal. If I push this rod, after some time what will happen, ma? It will become horizontal, no? It will fall to the ground. So by the time it is falling to the ground, this particle will have some tangential speed, no? Similarly, total rod will have some angular velocity also. These two values I am supposed to calculate. Can you say how can I do the calculation? చెప్పండి, చేసినారు కదా ఇన్ని ప్రాబ్లమ్స్. హౌ కెన్ ఐ డూ? This is not straight line motion, or alpha value I don't know. Alpha value, do I know? Alpha value we have to calculate. Okay, ma? One method she is saying by using v square minus u square is equals to 2as. That is omega square minus omega naught square is equals to 2 alpha into theta. Clear, no? But here alpha value I don't know. Are you able to understand? And the torque acting on this rod also, it is not a constant. Okay. So by using integration process only, we can definitely calculate in this method, but we have to use calculus. Without calculus, how can I do?
So very simple now. What is the force acting on this rod? Why it is coming downwards? Because gravitational force is pulling the rod.
That's all. No? Gravitational force is what kind of force? Conservative force. Are you able to understand, ma? So because only conservative forces are acting, I can use this relation, no? K1 plus U1 is equals to K2 plus U2. Total initial mechanical energy is equal to total final mechanical energy. So when rod is released, what is its initial kinetic energy? 0. It doesn't have any kinetic energy, no, ma? Now what about potential energy of the rod, ma? Rod, is it having any potential energy or not? Rod ki potential energy unda leda? Undi. Where?
Total mass of the rod will be concentrated at its center, no?
Because this is a symmetrical body, no? So for symmetrical bodies, where center of mass will be? At its geometrical center. Understood, no?
So center of mass is present at a height of L by 2, half of the length. So therefore, what is its potential energy, initial potential energy? Let us take a ground to be my reference. I am taking this one to be 0 potential energy reference. Okay. So when compared to here, what is the potential energy of the rod?
How much?
Plus mgh, no? Plus mgh. It is above the reference.
Plus mgh. So final kinetic energy?
By the time the rod touches the ground, it will have a tangential speed of Vt. Are you able to understand, ma?
So therefore, kinetic energy means this rod is only rotating, no, ma?
Falling means what? This rod is rotating.
Rotating means it will have which type of kinetic energy? Rotational kinetic energy. What is the formula for rotational kinetic energy? Half I into omega square. Okay. And final potential energy?
It has reached ground, no? And ground only I am taking my reference of 0 potential energy.
So final potential energy is how much?
0.
Are you able to understand? So therefore, now do the what he is asking actually? Angular velocity as well as linear velocity. So mgh is equals to half into, now what is the moment of inertia of this rod? Moment of inertia.
Rod is rotating about one axis, no? At one end of the rod, axis is present.
When axis is present at one end of the rod, what is its moment of inertia? I is equal to ml square divided by 3. This is the moment of inertia, no? So substitute. So ml square divided by 3. Let us write all of them. They are given in capital letters, no? So ml square by 3 multiplied by omega square. Okay. So calculate omega value from this one. So therefore mgh is equals to ml squared by 6 multiplied by omega square. So m and m get cancelled. So omega is equals to square root of 6gh divided by L square. So omega is equals to root 6gh divided by L. So this is my omega value. Understood, no? So once I calculate omega value, how can I calculate linear velocity at one end of the rod?
Linear velocity at one end means what? What is this one?
Tangential speed. What is the formula for tangential speed? V tangential is equals to omega into R. Okay, ma? So V tangential is equals to omega value root 6gh divided by L multiplied by R.
R means what? R means distance from this axis, no, ma? So this length is again L. R is equal to L. Okay.
So multiplied by L. So L and L get cancelled. So V tangential is equals to root 6gh. That is my answer. Clear? That's it. Okay, ma? So here h value is not given in the data, no? H means what? Height where center of mass is present. This is called h, no? In mgh, h is nothing but L by 2, no, ma? So substitute that value. So h is equals to L by 2. So therefore V tangential is equals to square root of 6g into L by 2. Okay, ma? 6g into L by 2. So Vt is equals to root 3g L. So that is my answer. Okay. So see. So here this is a horizontal table, ma? And there is a friction between small m and this table.
And 3m is the mass which is suspended from
Other end of the rope. Clear now?
Then by this time this mass covers a distance of h. Okay, it falls down by a distance of h. Then what is the speed of these blocks that I am supposed to calculate? Clear now? And this pulley is also rotating. Moment of inertia of the pulley is I, its mass is m, its radius is r. Okay, but moment of inertia is given, other quantities are not required, just he gave. Okay, let me see answer he gave in moment of inertia only, so no problem. Okay, so therefore, anybody, can you say how can I do this problem? Can I use law of conservation of mechanical energy? Ma? This use cheyachcha? Law of conservation of mechanical energy I cannot use. Why? Friction is there, no? Friction is not a conservative force. Friction is a non-conservative force. So definitely law of conservation of mechanical energy I cannot use, but I can use law of conservation of energy, no? Okay. What is law of conservation of energy? Work done by conservative forces, work done by non-conservative forces, work done by pseudo forces, clear nama? Plus work done by other forces. Total should be equal to change in kinetic energy. This is called as work energy theorem, no? Or you can call it as law of conservation of energy equation. Okay. So are there any conservative forces? Ma? Gravitational force is a conservative force. No? So gravitational force is doing on which body? Work on this body or this body? 3m. Okay. Because this is the only body which is moving downwards. No? So gravitational force can do work only on 3m. So gravitational force, will it do positive work or negative work on this body? Adi kuda chudali. Whether it will do positive work or negative work. This body of mass 3m, when it falls by a height of h, gravitational force, is it doing positive work or negative work? Positive work. Why positive work? Gravitational force will be acting in downwards direction. Displacement is also in the same direction. So angle between them is 0, cos 0 is +1. Understood, Nama? Work done formula, do you remember? W is equal to Fs cos theta. Force is gravitational force. Displacement is in downwards direction. Angle is also 0. So it is plus Fg into S. Positive work. So substitute here. So work done by conservative force is, what is the gravitational force, ma? Gravitational force is nothing but 3 mg, weight of this body. Clear, no? Displacement is how much? H. And angle is 0, cos 0 value is 1. And work done by non-conservative force. Non-conservative force is what here? Friction. So work done by friction, first of all, friction is doing work on which body? This body, this body, or this body? Work is done by friction on this body. Positive work or negative work? Negative work. Friction will do negative work in this condition because displacement is in this direction, no? But friction always acts in opposite direction. So therefore I will write minus of work done by friction formula, frictional force multiplied by displacement. That's all, no? Work done force into displacement only, no? Which force? Frictional force. Displacement, let it be S. Pseudo forces. We are not taking any accelerated frame, so pseudo frame is pseudo, work done is 0, and work done by other forces is also 0. So this is equal to total change in kinetic energy. Okay. Total change in kinetic energy means I have to write a K2 minus K1 number, final kinetic energy minus initial kinetic energy. Now substitute all the values. So therefore 3 mg into H minus FL. Limiting friction formula? Mu S into M. So mu into N. N means what? Normal reaction. What is the weight of this body? Mg. Normal reaction will be how much? N. N is also equal to mg. Clear now? So mu S into mg multiplied by, what is the displacement of this M? When this falls by H, this also moves by H only, no? Clear? So H is equals to final kinetic energy. Final kinetic energy will be present for how many bodies? This will also have a velocity of v, no? This also will have same velocity, no? Because they are connected by same string. And pulley also will be rotating with a particular angular velocity, no? So all the three bodies will have final kinetic energy. Clear, no? So final kinetic energy of 3m, half into 3m into v square. Okay, ma? So by the time it reaches here, let its velocity is v. 3m into v square. This body, by the time it will reach here, no, ma? So it will be also have same velocity. Okay.
So therefore half into, what is the mass of this body? M. Again velocity is v square. Okay. Similarly, disk also, this body is also rotating, no? And it will be rotating with an angular velocity of omega. So therefore, what is its kinetic energy? Half I omega square. That's all, no? Kinetic energy of 3m, kinetic energy of m, and this is the kinetic energy of which body? This is the kinetic energy of this v, which is rotating. Minus initial kinetic energy, 0. Initially every body is in rest position, no? So every kinetic energy is 0. Clear? So speed only he is asking, no? It means he is asking v value. But omega is also there, no? Again, how can I calculate omega value? Again, how can I calculate Sima, velocity of this block is v, velocity of this rope is also v, tangential speed of pulley is also v only by constraint relations. Okay. So therefore v tangential is equals to omega into r. So omega is equals to v tangential divided by r, or just I can write v by r. So substitute this v value there. Now let us do the total calculation. So 3 mgh minus mu into mgh. Okay, ma? So this is equals to half 3m v square plus half m v square plus half I, instead of omega what I can write, v by r whole square minus 0. So calculate v value from this one. That is my required answer. Understood, no, ma? So I will give the answer of this, check whether you get the same answer or not. Okay. So final velocity which you should get is square root of gh into 3 minus mu divided by 2 into 1 plus I by 4m r square. Okay, ma? So here he gave us capital R, no, I will write capital R only. 4m into r square. So that is the final velocity which you will get. Is it clear, ma? Okay. Very, very easy, ma. Within 2 minutes, less than 2 minutes, you can do these calculations. But you should be clear about what is happening and what you have to do. Then very easily you can do. Momentum. Torque we have studied, no? Now we are studying angular momentum. So torque is an axial vector, theta is an axial vector, omega is an axial vector, L is also an axial vector. Angular momentum, it is represented by L. L is also an axial vector. It means what will be its direction? It will be in the direction of axis of rotation, either in upwards direction or downwards direction. Clear, no? Now see. So what is meant by linear momentum? For example, this is a body of mass m moving with a velocity of v. Then its linear momentum is mass of the body multiplied its velocity. Mass into velocity is called linear momentum. Clear, no? But we are studying angular momentum. Angular momentum means what? Momentum in the case of rotational motion. Okay, now see. So this is the axis of rotation. Around this axis, this is a body of mass m moving with a velocity of v. Okay, ma? This velocity is inside the board. It is not in the plane of the board. ఈ velocity ఎలా ఉంది? బోర్డు లోపలికి ఉందనుకోండి. ఇంకా దాన్ని బొక్కబెట్టి డ్రా చేయలేం కదా, అందుకని ఇట్లా డ్రా చేస్తున్నాను. కన్ఫ్యూజ్ అవ్వద్దండి. So this velocity is present inside the board. Are you able to understand? Therefore, what will be its angular momentum? So angular momentum can be written as, I can write r into p. I can write like this, where p is called as linear momentum number. Okay. So it means linear momentum multiplied by perpendicular distance from the axis of rotation. That relation we call it as angular momentum. P is called what? Linear momentum. This body has some momentum, no? It has some mass, it has some tangential speed. Okay, ma? V means with speed, tangential speed. So mass multiplied by tangential speed is called momentum. And its perpendicular distance from the axis of rotation, that is r. So moment means what? The product of radius and linear momentum of the body is called as angular momentum. Or you can call it as moment of momentum also. Another name for angular momentum is
moment of momentum also you can call it as. Okay, but moment of momentum means what? Momentum multiplied by perpendicular distance. Okay. Torque also we call it as momentum, moment of force. Torque ki inko muddu peremi, it is also called as moment of force. Why we call it as like that? Because force is multiplied by perpendicular distance, no? So wherever you multiply by distance, that is called as moment. Are you able to understand? So angular momentum is also called moment of momentum. Okay, ma? So therefore I can write what is R here. R is perpendicular distance from axis to linear momentum. Linear momentum, or you can call or velocity of particle. Velocity of particle. So R ante ఏ distance తీసుకోవాలి మీరు? Velocity కి perpendicular direction. In torque also we have done the same thing, no ma? We have taken perpendicular distance to force. Then we have multiplied radius vector and force, we got torque. Here also same concept. You take which distance? You take that distance which is perpendicular to velocity, and that is R, no? So R into P is called as angular momentum. Clear, no? P can be written as m into v also, no? So I can write R into mv also. This is another form. Are you able to understand? So this is called as angular momentum. So in vector form, how can I write? In vector form, same angular momentum can be written as L dash is equals to R dash cross P dash. I can write like this also. Angular momentum we studied, it is a vector quantity, no ma? So how to give its direction? This is the method in which you can find out the direction of angular momentum. R dash cross P dash. Are you able to understand? Or also you can write M if you take common, R dash cross V dash also you can write. Because M is a scalar quantity, no? Mass is a scalar quantity. You can take it outside. So just you can take the product of R dash cross V dash, cross product. Okay. Now see ma, for example, this is the radius vector and velocity is inside the board. Now can you say what is the direction of angular momentum in this condition? Angular momentum ఏ direction ఉంది చెప్పండి? Already we studied angular momentum is a axial vector, no? So either it should be in upward direction or either it should be in downward direction. Which direction is correct? Upward direction. How can you say? So place your right hand on R dash. This is the first vector, no? Place your right hand on R dash. Velocity is in which direction? Inside the board. So rotate your fingers inside the board. What is the direction of thumb? Thumb is in the direction of axis, no? Are you able to understand, no? So therefore I can say this will be the direction of angular momentum. Okay. So when velocity is inside the board, angular momentum is on the axis towards upwards direction. Are you able to understand, no? Angular momentum can be in this direction also, downwards also. Downwards in which condition? When particle is coming out of the board. When velocity is out of the board, then you have to do R dash cross B dash, no? Particle బయటకు వస్తుంది అనుకోండి, R dash cross B dash. Then thumb is towards the downwards of this axis. Now it is present on the upside of this axis. That's it. That is how you can find out angular momentum. Understood, Nama? Similarly, for example, if I take one body, let us take one case. Clear, ma? For example, this is a body of mass m at a distance of r, and consider velocity vector is in this direction. Okay? Velocity vector is in this direction. Then how can you calculate its angular momentum? So this is radius vector, no? So you can extend this radius vector here also, no? You can displace radius vector, no? In displacement of vectors we have studied, no? Vector can be displaced anywhere. Just its direction and magnitude should not change. Okay? So therefore, what is this angle? This is the angle theta between radius vector and velocity. So therefore, what you can do, split this velocity vector into two components. Split velocity vector into two components. Clear, no? Then this is velocity, no, ma? Which is the opposite side? V sin theta is the opposite side. And which is the adjacent side? V cos theta is the adjacent side. Now out of V cos theta and V sin theta, which vector we have to take? V sin theta. Why we have to take V sin theta? Because that is the velocity vector which is perpendicular to radius vector. Radius ki perpendicular ga unna vector ade kada V sin theta. Okay. Namaskar. Absent aithe atte untadi. So therefore, how can I calculate angular momentum? R into mv sin theta. Are you able to understand? Ma? So directly I can write R into P. In which condition? Ma? R into P I can write when radius and momentum when they are perpendicular. But when radius and momentum when they are at an angle of theta, you can use this relation. L is equals to R into mv sin theta, or just you can write mvr sin theta also you can write. But to find out direction, always you have to use this relation. R dash cross P dash. You should not use P dash cross R dash. P dash cross R dash use చేసినానంటే direction తారుమారు అయిపోతుంది. Clear ma? R dash cross P dash. Okay, this is the equation. So finally what we understand, we have to take those two vectors which are only perpendicular to each other. Radius and velocity vector, they must be perpendicular. Take only those components. Understood, no? That's it. So we are writing another equation for angular momentum. One equation already we have studied, no? One equation is R into P, or you can write mvr. Okay, ma? Now see here, this is a point mass moving with a tangential speed of v, and velocity is inside the board. And what is the perpendicular distance? Perpendicular distance is r. So these are the equations of angular momentum. And this is a point mass, no? For point mass, what is the moment of inertia? mr square. Okay. But here in this equation, I have only m into r only. But I require r square, no? So I multiply and divide by r. So will anything happen, ma? If I multiply and divide by r, nothing will happen, no? But here, m, r and r, it will convert into mr square. And additionally what I have v divided by r. And tangential speed, we know it is omega into r, no? So therefore omega is equals to v by r. So therefore instead of v by r, I can substitute omega. Instead of mr square, I can write moment of inertia I. So therefore L is equals to I into omega. This is another equation for angular momentum. Understood, Nama? One equation for angular momentum is mvr or mvr sin theta. And another equation is I into omega. So these are the two equations of angular momentum. For torque also we have written two equations, Nama. Torque can be written as R into F also, I into alpha also. This I into alpha is in terms of moment of inertia. Similarly, angular momentum also I can write in terms of moment of inertia, I into omega. Are you able to understand? So these two equations you should remember. Fine? Okay. Make a note. Okay, Seema. So next concept which we are studying is law of conservation of angular momentum. Okay. So before studying law of conservation of angular momentum, first of all let us revise law of conservation of linear momentum. Okay. What is law of conservation of linear momentum? Seema, on a body
if external forces acting are zero. Okay. Then according to Newton's second law, we have F net is equals to dp by dt. No? Rate of change of momentum of a body is directly proportional to net force acting on a body. Clear, no? If net force is zero, dp by dt is also zero. dp by dt can become zero only when momentum is a constant. Already we studied this one, no? Gurtunda? Okay, ma? If external force acting is zero, then momentum of the body will never change. It always remains a constant. That is called as law of conservation of linear momentum. Are you able to understand, ma? So, same concept if I apply in rotational motion, let us see how we can apply. See, ma. So, consider this is a disc. Are you able to understand, ma? Consider this is a disc rotating about this axis. So, it is rotating with a constant angular velocity of omega. It is rotating with a constant angular velocity of omega. Are you able to understand? If it is rotating with a constant angular velocity of omega, then it means what is the alpha value? Angular acceleration is how much? Zero. There is no acceleration. Angular acceleration is not there. Okay, ma? So you can write alpha is equals to d omega by dt. It is zero. It means omega is a constant. Are you able to understand? If alpha is zero, can I say net torque acting on the system is also zero, nama? Clear, no? What is the formula of net torque? I into alpha, or you can say R into F. Okay? If alpha is zero, then net torque acting on the system is also zero. Are you able to understand, ma? Okay. So if a net torque acting on the system is zero, then angular momentum of the system is a constant. Are you able to understand? Same concept we are writing here. Force, net force is zero, momentum is a constant. Compare chestu chudandi. Net force is zero, what is constant? Momentum is a constant. Net torque is zero, angular momentum should be constant. Are you able to understand, ma? So therefore what I write, if net torque acting on the system is zero, then angular momentum should be constant. Okay? How to prove this one? I want to prove also. Okay? So let us see, ma, same equation, how can you write in rotational motion? By using analogy. Instead of force I can write a torque, no? Instead of force I can write torque. Force and torque, they are analogous, no? Force produces linear acceleration, torque produces angular acceleration. So dp divided by dt, can I write dl divided by dt? That's all, no? P is linear momentum, L is angular momentum. So net torque is equals to dl divided by dt. This is the equation according to Newton's second law in rotational motion. Understood, no? Now write the equation. So if net torque is zero, then dl by dt also will be zero. If dl by dt is zero, it is possible only when L is a constant. This is the proof of this. So system paina torque emi ledanukondi, angular momentum lo marpu emi undadu. There will be no change in angular momentum. Understood, Nama? Okay. So from this same equation I can write, okay, first of all let us write the statement of this one. So what is the statement of law of conservation of angular momentum? If net torque acting on the system, net torque acting on the system is zero, then angular momentum remains what? Angular momentum remains constant. Able to understand, no? So just like linear motion lo చదువునాం కదా మనము, అదే కాన్సెప్టే మళ్ళీ rotational motion లో కూడా రాస్తా ఉన్నాం అంతే, పెద్దగా మార్పు ఏమీ లేదు. If net torque acting on the system is zero, then angular momentum remains constant. It means initial angular momentum and final angular momentum, they are same. Okay? क्या जी सुब्बाराव का चुप बैठे कब लिखती नोट्स हो? ఎతకయ్యా నోట్స్ చెప్పేటప్పుడే రాసుకోండి, మా తర్వాత ఈ రాయాలంటే టైం వేస్ట్ అంతా. కూర్చొని హరికథ వినడం కాదు, నోట్స్ నీట్గా రాసుకోండి. ఓకే, అండర్స్టూడ్ నామా వాట్ ఈస్ హ్యాపెనింగ్ హియర్? Now see. So, therefore, now let us take this equation once again. So, net torque is equals to, or we will do one thing. Ma? So, angular momentum is a constant. No? So, therefore, I have written L is a constant. Okay? L is a constant means what is the equation of L? MVR is one formula. I into omega is also one formula. No? So, therefore, if net torque acting is 0, then I can write m1 v1 r1 is equals to m2 v2 r2. Can I write like this? Can I write like this? If on a system, if torque is not acting, initial angular momentum, final angular momentum, they must be equal. Okay, how to apply this one in problems we will see afterwards. Definitely I can write like this, no? M1 v1 r1 initial angular momentum, m2 v2 r2 final angular momentum, they must be equal. Similarly also I can write I1 omega 1 is equals to I2 omega 2 also. Like this also I can write. This is another equation of angular momentum, I into omega. So I1 omega 1 must be equal to I2 omega 2. Like this also I can write. Are you able to understand? Okay. Now let us write one more equation for torque. Okay, ma? So already we have written, let us prove that one. See, ma, torque is equals to dl divided by dt. So d by dt of L can be written as I into omega. I is a constant, so take it out of integration. What is d omega by dt? Change in angular velocity by time is what? Alpha. So I into alpha. So this was the same equation we have been using, no? Torque is equal to I into alpha. This is the proof of this. How we got torque is equal to I into alpha. Are you able to understand, ma? So we know this relation. Net torque acting on a system is equals to dl by dt. L is I into omega. I is a constant. D omega d by dt is alpha. Clear, no? That's it. Now based on this we can frame many beautiful questions, ma. So whenever you see the question, you have to identify this question is based on which concept. Question అసలు దేనిపైన ఫ్రేమ్ చేసినోడు అది ఆలోచించాలి, అప్పుడు మీరు ప్రాబ్లమ్ని చేస్తారు. అర్థమవుతుంది కదా? క్వశ్చన్ ఏ చాప్టర్కి సంబంధించిందో ఐడియా రావడం లేదు, ఇంకేం చేస్తారు మీరు? ఓకే, ఓకే, అది ఓకే. So next topic is relation between rotational kinetic energy and angular momentum. So we studied about angular momentum, nama. So linear momentum multiplied by perpendicular distance from the axis of rotation. Are rendu multiply chesthe we get angular momentum. Clear? Now we are trying to derive a relation between rotational kinetic energy and angular momentum. Directly also we can derive, but we will try to derive with the help of analogy. Analogy తీసుకొని derive చేద్దాం. What is meant by analogy? So in linear motion, we know that kinetic energy is equals to half mv square, no? This is the equation for kinetic energy, no, in linear motion. Okay. Similarly, what is the equation for linear momentum? Mass into velocity. Are you able to understand? So if I divide both of them, then I will get k is equals to p square divided by 2m. This is the relation which I will get. Okay, k is equals to p square divided by 2m. This is one relation. Are you able to understand? Same equation, can you say how can I write in rotational motion? Same equation, how can I write in rotational motion with the help of analogy? K, what is meant by K? Kinetic energy. In which motion? linear motion. So instead of K, again I will write KR, kinetic energy in rotational motion. That's all now. And what is meant by P here? P is called linear momentum in rotational motion. Rotational motion lo em raskuntam. L, instead of P I will write L square. That's all now. So divided by 2, M means what? M means mass, no? Which is the reason for inertia. If mass is greater, inertia is also greater. And instead of M, here what I have to write? I, moment of inertia. So this is the inertia in linear motion, this is the inertia in rotational motion. So like this, by analogy also you can remember. Are you able to understand? Or you can write equation K is equals to half I omega square. Okay, ma? Then L is equals to I into omega. Then you divide both of them. Again you will get the same relation. Okay. Just here we are trying to write the relation by using what? By using analogy. Are you able to understand, ma? So K is equals to L square divided by 2y. That is the equation. Clear? That's it. Make a note of this. Okay, ma? So see this problem. So find angular momentum of a particle about point O of a particle of mass m moving with the velocity v parallel to x-axis at a distance of d. Okay, ma? Mass of the particle is how much? M. So it is moving parallel to x-axis. Are you able to understand, ma? Towards positive x-axis it is moving. And at what distance it is moving? It is moving at a distance of d. For this condition, first of all, we are supposed to calculate angular momentum. Then we will see the second condition. Okay, ma? So see the first condition. So where is the position of the particle, ma? So this is positive x-axis, no? So particle is moving along positive x-axis at a distance of d from the x-axis. It means let us consider particle is somewhere here. Okay, ma? Mass of the particle is m. And it is traveling with how much velocity? It is traveling with a velocity of v parallel to x-axis. Parallel to x-axis means like this only, no? It is traveling like this. And it is located at how much distance, ma? It is located at a distance of d from the x-axis. This is the question. Okay, ma? So particle is moving like this. So for this particle, can you say how can I calculate angular momentum? L value, how can I calculate? Can you say? Angular momentum, how can I calculate? You want to calculate with the help of K into K square by 2y. What is the kinetic energy of this particle? Half mv square. Okay. So what is the angle K square by L square by 2y? Angular. Okay. You want to calculate with that formula. Okay. Definitely you can calculate. Are you able to understand? Any other method? So first method is, we have already studied that rotational kinetic energy is equals to K is equals to L square divided by 2y. Okay. So this particle, is it rotating, ma? It is not rotating, no? It is moving in a straight line. Okay. But this is the equation for rotational kinetic energy. This is the equation for what? This is the equation for rotational kinetic energy. Are you able to understand? It is not rotating. This formula we cannot use. Any other formula? Any other formula, ma? So angular momentum is equals to mvr. This formula is also there, no? When it is moving with a tangential velocity of v, then L is equals to m into v into r. This formula I can use definitely. Are you able to understand? So mass of the particle is how much? M. What is the speed, tangential speed of this particle? V. And what is meant by r here? R means what? Which distance? Perpendicular distance. See, to define angular momentum, there should be some axis of rotation, no? What is the axis of rotation? About which point he is asking? He is asking about a point O, no? Are you able to understand? Ma? It means this is my axis of rotation. Okay? So from this axis of rotation, what is the perpendicular distance? Perpendicular distance is d only. This becomes the total distance. But I am not concerned about this distance. No? I am always concerned about perpendicular distance from the axis of rotation. Perpendicular distance is already given, no? D. So m into v into d. That is my formula. Are you able to understand? No? So this is the equation for angular momentum in this condition. Okay. Now the question is, angular momentum, is it a scalar quantity or a vector quantity? Angular momentum, is it a scalar quantity or a vector quantity? Vector quantity. So therefore, how can you find out the direction of angular momentum in this condition? How can you find out the direction of angular momentum in this condition? How? Direction, he may ask the direction. 1 minute. Seema, the direction, the representation of angular momentum in vector form. So L dash is equals to R dash cross P dash. This is the formula which we have written, no? L dash is equals to R dash cross P dash. What is meant by P here? Momentum, mass into velocity. Momentum is mass is a scalar quantity, no? You can take it outside. So R dash cross M into V dash. I can write like this also. Okay. So mass, you just take it outside because it is a scalar quantity. So R dash cross V dash. So this is the equation of angular momentum in terms of vector form. Okay. Now first vector is R dash, no? So place your right hand on R dash. Clear now? Which is my second vector? Second vector is V dash. So V dash is in this direction, no? So rotate towards V dash. Are you able to understand? Ma? So first vector is in this direction, no? This is the direction of first vector, R dash. Okay. Second vector is in this direction. Okay, velocity vector. So place your right hand on first vector, rotate towards the second vector. What is the direction of thumb? Ma? Thumb is perpendicular and it is inside the board. So what is the axis present inside the board? Z-axis. Positive Z-axis or negative Z-axis? Negative Z-axis. So therefore, how can I write this equation? So therefore, angular momentum is equals to, clear ma? So mvd minus k cap, that's all. Just I can write like this. Okay. Minus k cap represents it is towards the inside of the board and perpendicular to the board. Clear number? So therefore, L dash is equals to minus mvd k cap. So I can write like this. Are you able to understand? That's it.
Sir, upper velocity minus k z dash minus z dash velocity. Then we not square by 2.
Call. Okay, ma? So let us see this problem. Ma? A particle of mass m is thrown with a speed v naught at an angle of 30 degrees with horizontal. Clear now? It means the question is that particle is thrown like this. That's what he is trying to say, no? Mass of the particle is m. And what is its initial velocity? Ma? Initial velocity is v naught. Okay. At what angle? At an angle of 30 degrees with respect to positive x-axis. Then what this body will do? This body will trace a parabolic path, no? Any body traces a parabolic path. Okay. So this body is also tracing this kind of path. Find the angular momentum about the point of projection. So I want angular momentum about this point. Clear? Where when the particle is at the highest point of trajectory. After some time, body will reach the highest position, no? So when it is present at h max, when it is present at this position, maximum height, we are supposed to find out angular momentum. That is the question. Okay. So angular momentum formula L is equals to m into v into r only, no? So write down, mass of the particle is m. Velocity of the particle is how much?
0.
Abba.
0. H max at the velocity 0.
ఎక్స్పెక్ట్ చేశాను నేను అదే చెప్తారని, కానీ అది కాదు. See, at the highest point, particle will have how much velocity? Highest point దగ్గర అంతే అంటావు అయితే. ఫిక్స్ అయిపోయింది ఆన్సర్ అదే అని. సీమా at the highest point, particle will have only horizontal velocity. Already we studied nearly 1000 times. Clear now? What is the total velocity of the particle? Total velocity of the particle is V naught. Split this V naught into two components. This is 30 degrees, no? So this is V naught cos 30 and this is V naught sin 30. So this is the velocity along x-axis. This is the initial velocity along y-axis. So at the highest point, this total velocity will become 0. Velocity at the highest point will be 0. But which velocity? Vertical velocity will be 0. But horizontal velocity you can never change, no? This velocity can never be changed. Already we studied, no? Horizontal velocity of the particle never changes. It is always a constant. But when particle travels from here to here, vertical velocity continuously decreases. At the highest point, final velocity along y-axis will be how much? 0. Y-axis పైన ఉన్న velocity 0 అవుతుంది. But what about velocity along x-axis? Velocity along x-axis remains to be ux, which is equals to v naught cos 30. Already we studied, no? This velocity never changes. So even at the highest position also, particle will have how much velocity? v naught cos 30. చదువుకున్నామా లేదా? Okay. So therefore, instead of velocity, what I am supposed to write? V naught cos 30 multiplied by r. Now what is meant by r here? R means what? Perpendicular distance to velocity from the axis of rotation. అంతే కదా? So perpendicular distance to the velocity from the axis of rotation is nothing but h max. H max is the perpendicular distance, no? So substitute h max. So multiplied by h max. Okay. And what is the equation for h max? U square sin square theta divided by 2g. So substitute. So m v naught cos 30 multiplied by u square sin square theta, no? So v naught square sin square 30 divided by u square sin square theta divided by 2 into g. 2g. That is the equation for h max. Now just simplify this one. So m v naught cos 30 value is root 3 by 2 multiplied by v naught square multiplied by sin 30 value 1 by 2. So 1 by 2 whole square is 1 by 4 divided by 2 into g. That's all now. So therefore, now substitute. So m v naught cube multiplied by root 3 divided by 2 into 4g. Okay. So root 3 m v naught cube divided by 4 2s are 8, 16g. So that is my answer. Are you able to understand? Again, if he asks you the direction, what will be the direction? Direction of angular momentum. Again same, r dash cross p dash. It is present towards negative z axis. Clear now? So therefore in vector form how can I write? L dash is equals to, I can directly write minus root 3 m v naught cube divided by 16g multiplied by k cap. That is my answer. అవసరం ఉండదు. Okay. Now see this question. See ma, two balls, they are attached by a light rod. Masses are 2m and m. Clear ma? Light rod means what? Light rod means it is not made up of light energy or heat energy or sound energy. Light rod means mass of the rod you need not consider. Mass is very less, you need not consider. Clear now? And this system is rotating about an axis perpendicular to the rod and axis passing through center of mass of the system. It means first of all I am supposed to calculate what? I am supposed to calculate where is the center of mass of this system. Without the center of mass I cannot do this problem. Okay ma? Then about that axis what will be the angular momentum that I want to calculate. Clear? Okay. So first of all, see ma, this is a two particle system. Any particles unnai ikkada? Two particle system. And for two particle system, where will be the position of center of mass? For two particle system, center of mass ekkada untundi? Near to the heavier body, and it must lie on this line only. Clear no ma? That's what we have studied in two particle system now. For a two particle system, center of mass must lie on the line which is joining these two masses, and it should be closer to heavier mass. Okay. Then what is the formula? Let us consider this axis to be x axis. Then x center of mass is m1 x1 dash plus m2 x2 dash divided by m1 plus m2. So this is the equation of center of mass number. And to calculate center of mass there should be a reference, no? Already we studied, no? Because center of mass is a distance. Center of mass anedi position kada. To measure position there must be some reference. Which one shall I take reference here? I will take this body to be my reference, or you can take this body also, or you can take middle also, any point you can take. I am taking this body to be my reference. Are you able to understand? Because center of mass cannot be calculated without a reference. Moment of inertia cannot be calculated without an axis. Are you able to understand? Torque you cannot calculate without an axis. Angular momentum you cannot calculate without an axis. Center of mass you cannot calculate without a reference. Reference lekunda cheyalem kada. So this is my reference. Now do the calculation. Let us take this is m1 and let us take this is m2. Clear ma? So what is the mass of first particle? Mass of the first particle 2m. X1 means what? Distance of first particle from the reference. So from the reference, first particle is present at how much distance? 0 distance. So multiplied by 0. Clear now? Mass of the second particle? m2. So what is the position of second particle from reference? L. So L divided by m1 plus m2. So 2m plus m. Clear now? So therefore, how much it is? This is m, no? So m into L divided by 3m. So this is x center of mass. So m if you get cancelled, L by 3. Okay ma? L by 3 means where ma? Somewhere here, no? Total length is L. So L by 3 means somewhere here. Okay? So this distance I can call it as L by 3. So it means where is the axis? Axis is passing from here. This is the axis of rotation. Okay, arthamautundi kada? First of all, we have identified the position of center of mass. We have understood that it is present at L by 3. Clear, no? So from this center of mass, axis is passing and this total system will rotate. Now is it clear? So from the first mass, what is the distance of center of mass? L by 3. Then what will be this distance? L minus L by 3. So total distance is L nama. L once L by 3, this is the remaining distance. L minus L by 3. L minus L by 3 is how much? 2L divided by 3. So that is the position of center of mass from second body. Are you able to understand? From first body it is L by 3. Now do the calculation. So therefore, angular momentum of total system, I can write it as angular momentum of first body plus angular momentum of second body. Because here two bodies are there. First mass is also a mass, second mass is also a mass, no? So two masses are present. Why I am writing in vector form?
Directions.
Because angular momentum is a vector quantity, directions also we should be careful. Are you able to understand? So total angular momentum is vector sum of angular momentum of first particle plus angular momentum of second particle. Are you able to understand? So I can calculate angular momentum in two methods. Okay, let us do in both the methods. First method. Okay, first method, angular momentum is equals to mvr. I can calculate in this method also. So let us calculate angular momentum of first particle, let it be L1. So can you say how can I calculate L1? Angular momentum of this particle is how much? So this particle, it is rotating about this axis, no ma? This particle din chuttu rotate avutundi kada. So therefore angular momentum L1 is equals to mvr. This is the first method. Mass of the particle 2m. What is its tangential velocity? I don't know. What is its radius? Radius means perpendicular distance is how much? Perpendicular distance is L by 3. Are you able to understand, ma? Angular velocity, is it given, ma? Angular velocity, is it not given in the problem? Angular velocity, he did not give anything, ma? So let us assume it is rotating with an angular velocity of omega. So add that in the question, ma. Rod's angular momentum is how much? Sorry, angular velocity is omega. Angular velocity of the rod is omega. Are you able to understand? Okay. So now tangential speed of this rod, do I know, ma? So let us consider rod is rotating like this. So rod will have some tangential speed, no? See here, I will draw the diagram. So consider this is the circle in which these two rods are rotating. This is first mass, this is the second mass. They are connected by a light rod. So center of mass is somewhere here. So this rod tangential speed is Vt1, tangential speed of second one is Vt2. So this distance is L by 3, this distance is 2L divided by 3. Mass of this one is 2m, mass of this one is m. So I can write figure like this also, okay? This is the axis of rotation. Okay, so they are rotating like this. So Vt means what here? Tangential speed only, no? V means tangential speed only, no? So tangential speed, how can I calculate? What is the formula for tangential speed? Vt is equals to omega into r. Already we have studied. No? Tangential speed is the formula. Vt is equals to omega into r. So substitute here. So omega, angular velocity is omega, and r means perpendicular distance, no, from the axis. What is the perpendicular distance? L by 3 multiplied by again L by 3. Clear, no? So therefore m L square omega 2 divided by 9. So 2 ml square omega divided by 9. So this is the angular momentum of first particle, first mass. Similarly you calculate for second mass also. Clear, no? So second mass, angular momentum is L2. So L2 is equals to again same formula, mvr. Mass of the second particle is how much? Mass of the second particle is m, and its tangential speed is Vt2. And what is the perpendicular distance, ma? Perpendicular distance is 2L by 3. That's all, no? For second mass, perpendicular distance is 2L by 3. Clear, no? But what is the tangential speed? Again, what is the formula for tangential speed? Omega into r. So omega into, now again what is the perpendicular distance? 2L by 3 multiplied by again 2L by 3. Clear, no? So again what I will get? So m L square omega multiplied by 4 divided by 9. So that is the angular momentum of second particle. అర్థమవుతుందా ఎలా చేస్తున్నాము? వెరీ సింపుల్ కాన్సెప్ట్. ఓకే, Now the question is, here I have written in vector form, no? I have written in vector form. Okay. If I have written in vector form, it means I should find out the directions also, no? Now can you say what is the direction of angular momentum of first particle? And what is the direction of angular momentum of second particle?
Positive, negative.
Positive, negative. Abba, matalle. So this is the first particle, no? R dash cross V dash. If I am assuming that it is moving in this direction, R dash cross P dash. Direction is in which direction? Perpendicular and out of the board. Okay. For this one, R dash cross P dash. This is also perpendicular and out of the board only. Are you able to understand, ma? It means both angular momenta, they are in the same direction. If they are in the same direction, directly you can add them, no? Clear, no, ma? So therefore, what is the total angular momentum? Total angular momentum is L1 plus L2. Now no need of writing in vectors because they are in the same direction. Okay. So therefore, write down. So 2 by 9 m L square omega plus 4 by 9 m L square omega. So total how much, ma? 2 plus 4, 6. 6 by 9 m L square omega. So 6 by 9 means how much? 2 by 3 m L square omega. Okay, that's all. That is my equation of angular momentum. So have you understood why we have added them, ma? Why? Because both angular momenta, they are in the same direction. Okay, so make a note of that point. What is the note point here I have to write? Note point is that both angular momenta are in same direction. Okay. So therefore, if I want to write in vector form, how can I write, ma? So 2 by 3 ml square omega multiplied by k cap. Because it is towards positive z axis, no? So I can write k cap. Okay. So this is the first method of solving this problem. So first method I have calculated by using which method? L is equal to MVR method. Okay. Now can you say how conservation of angular momentum? Ma? First question. If radius of earth is doubled without a change in its mass, so what will be the length of a day? Are you able to understand? So we know the radius of earth is R, 6,400 kilometers. Mass is some 6 into 10 power 24 kg. Okay, ma? Mass is not changing. So just radius of the earth is becoming double. Are you able to understand? Then what will be the length of a day? Length of a day depends on what? Length of a day ante day 10 meterlu unda 20 meterlu unda ani kaadu. Length of a day means what? What is the time taken for earth to make one rotation? That is called as length of a day. Are you able to understand, ma? So this length of a day, it depends on angular velocity of earth, no? It depends on what? Angular velocity of earth. If earth is rotating very fast, length of the day will be very less. Clear, no, ma? If earth rotates very slowly, length of the day will be very big. Okay. Now let us see how we can do this problem. See, ma. So this is earth whose radius is R, and this is getting converting into a bigger radius, bigger sphere whose radius is 2R. Mass of this is m, mass of this one is also m, because he said that there is no change in mass, no, ma? Mass is not changing. Okay. Now what will be the length of a day? That is the question. Okay. So what is the formula for angular momentum of a sphere? Sima, consider earth is a sphere which is rotating about this axis. No? It is rotating about this axis. So what will be its angular momentum? Angular momentum will be I into omega. This will be the formula for angular momentum. No? I into omega, because this is a rotating body. Instead of MVR, I can use this relation I into omega, formula for angular momentum. Are you able to understand? Okay.
Now here just a radius has become double. Mass is not changing. Are we applying any torque here? To increase the angular momentum or to decrease the angular momentum, are we applying any torque? Torque we are not applying, no. Mass is increasing, radius of the earth is increasing by itself. Okay. So therefore I can say torque acting on this earth is 0. Torque is 0. We are not applying any force, we are not applying any torque. Okay. If torque acting is 0, then dl by dt also should be 0. No? How we got this relation? By analogy of Newton's second law. Do you remember? F net is equals to dp by dt. This is Newton's second law. No? Rate of change of momentum of a body is directly proportional to net external force acting on the system. Clear, no? Similarly, rate of change of angular momentum is directly proportional to net torque acting on a system. Clear? So therefore net torque is 0, dl by dt is also 0. dl by dt will become 0 in which condition? dl by dt 0 eppudu avutundi? Only when L is a constant. Okay, ma? If L is a constant, dl means what? Change in L. There is no change in L. Change in L is 0. So 0 divided by dt. 0 divided by dt will be 0. It means dl is not there. dl లేదు అంటే అర్థం ఏమి? చేంజ్ ఇన్ L is not there. చేంజ్ L లో చేంజ్ లేదు అంటే L is a constant. That is the meaning of that. So if L is a constant, then I can write L1 is equal to L2. Initial angular momentum and final angular momentum, they are same. This is exactly what is called as law of conservation of angular momentum. అదే కదా law of conservation of angular momentum. If net torque acting on a system is 0, total angular momentum always remains a constant. So initial angular momentum, final angular momentum, they are same. Okay. And what is the formula for angular momentum? I into omega. So therefore can I write I1 omega 1 must be equal to I2 omega 2. I can write like this now. I1 is the moment of inertia in the first condition, I2 is the moment of inertia in the second condition. Omega is the angular velocity in the first condition, omega is the angular velocity in the second condition, omega 1, omega 2. Okay? Okay. Now what is the moment of inertia of this body? This body is a disk, no? Disk, no? Earth is a solid sphere, no? So what is the moment of inertia of a solid sphere? Solid sphere. 2 by 5 mr square. 2 by 5 mr square. Mass of the body is m. And its initial radius is how much? R. So 2 by 5 mr square multiplied by initial angular velocity, let us call it as omega. Okay, let us call this one as omega, and angular velocity, let us call it as omega dash. Final angular velocity. Okay. So then I2 means what? Moment of inertia of same earth, but when radius is doubled. But mass is same, no? Mass is same. Formula remains same. So 2 by 5, mass is same, but what is the radius? Radius has become double. So 2r whole square multiplied by angular velocity also will change. If I value changes, omega also will change, no? Because total should be constant. I into omega constant ga undali kada, but I is changing. So omega also must change. Are you able to understand, ma? If moment of inertia increases, angular velocity should decrease, so that total angular momentum should be a constant. Total constant gaane undali kada. So therefore 2 by 5m, 2 by 5m get cancelled, r square and r square get cancelled. So therefore can I write omega dash is equals to omega divided by 4. That's all, no? This 2 square, if it comes to this side, then omega dash is equals to omega by 4. It means the new angular velocity has reduced by how many times? Reduced by 4 times. Okay. It means earth is further rotating very slowly. Earth at మామూలుగానే చాలా స్లోగా రొటేట్ అవుతుంది. Now it is rotating 4 times slower. 4 times slower means time period will increase by 4 times. No?
What is the time period of Earth? 24 hours. So 24 into 4? 96. That will be the time period. Are you able to understand? Because angular velocity has reduced by 4 times. Time period will increase by 4 times. Proof ఎలా చేస్తాం? So Seema. So we know that omega dash is nothing but 2 pi by t dash. That's all, no? And I can write omega is equals to 2 pi by t. This is how I can write number. So substitute. Instead of omega dash, I will write 2 pi by t dash is equals to omega by 4. Omega is 2 pi by t divided by 4. 2 pi get cancelled. So therefore I can write t dash is equals to how can I write? I can write 4t. So t dash is equals to 4 into t value is 24 hours. So t dash is equals to 96 hours. Okay. It means Earth completes a rotation in how much time? Earth completes one rotation in 96 hours. Okay. That's it. It means 48 hours will be day, 48 hours will be night time. So if time of this is this much, then I think all of you can get top rank in NEET examination. 45 గంటలు చదివితే ఇంకేముంది ఇంకా. Understood, Amma, how we have calculated? So by using which concept we have done? On this system, are we applying any torque, ma? Torque may act avatam. If torque is not acting, then angular momentum should be constant. So therefore I1 omega 1, I2 omega 2, they should be equal. That's all. Okay. No, I will explain you this question. Try to answer that. See what is the given question. So two disks of moment of inertia, I1 and I2, they are rotating with angular speeds of omega 1 and omega 2. So they are brought in contact with each other. Clear, no? It means that consider this is one disk, okay, which is rotating about this axis, and there is one more disk which is rotating about this axis. Okay, ma? So moment of inertia of this one is I1, moment of inertia of this one is I2. It is rotating with an angular speed of omega 1, this is rotating with an angular speed of omega 2. Okay. Now these two disks, they are brought together. It means their axes, they are made to join with each other. Clear, no? So if I combine their axes, then what will happen? Initially their angular speeds are different. Angular speed of this one is omega 1, angular speed of this one is omega 2. Now if I combine them, what will happen? If I combine, what happens? Axis becomes common axis, no? It means both of them, they start rotating with same angular velocity. That is the meaning of this one. No? So if I combine their axis, rotating with common angular velocity. Clear, no? So then we are supposed to find out what is that common angular velocity and what is the loss in kinetic energy. So when I try to combine these two axes, in between these two axes there will be some friction. Rendu axes la madhya koncham friction untundi kada. So to overcome that friction, some of the energy must be wasted also. So what is that loss in kinetic energy? That also I want to calculate. Are you able to understand? So therefore, what is the point here I have to write? If axes are combined, then disks start rotating. Disk starts rotating with a common angular velocity. Okay, ma? So what is that common angular velocity? How can I calculate? Can you say? ఆ కామన్ యాంగులర్ వెలాసిటీని మనం ఎలా ఫైండ్ అవుట్ చేయొచ్చు? ఎనీ ఐడియా? సో ఇనీషియల్ యాంగులర్ వెలాసిటీ ω1, ఫైనల్ యాంగులర్ వెలాసిటీ ω2. I am combining both the axes, then both of them they start rotating with a common angular velocity. So based on which logic can I solve this problem? Anybody? ఎలా చేయొచ్చు? Sima, when I combine these two axes, when I bring these two axes together, I am applying any external force? External force ఏమన్నా అప్లై చేస్తున్నానా నేను? చేస్తున్నానా లేదా? ఇవి రెండు గట్టిగా కంబైన్ చేయడానికి ఏమైనా ప్రయత్నం చేస్తా ఉన్నానా? నో, జస్ట్ ఐఎమ్ బ్రింగింగ్ దీస్ టూ యాక్సెస్ టుగెదర్ అట్ వన్ పాయింట్. ఓకేమా? సో దేర్ ఫోర్ ఐ కెన్ సే నెట్ ఎక్స్టర్నల్ ఫోర్స్ ఈస్ హౌ మచ్? 0. I am not applying any external force to combine both of them. If net external force is 0, torque also will become 0, no ma? Net torque also will become 0. Because only if net force is there, then only net torque also will be there. Because torque relation we know, no, R into F. There is no net force, there is no net torque. If net torque is 0, then dl by dt also will be 0, no? Then I can say L is a constant, no? Are you able to understand? No? Torque formula dl by dt according to Newton's second law. Are you able to understand? No? If dl by dt is 0, it means L is a constant. What is L? Angular momentum of this system is a constant. So based on which logic I am trying to do this problem? Law of conservation of angular momentum. సుఖంగా పెరగడానికి అలవాటైనారు మీరు, అట్లయితే చదువు రాదు. ఓకే, సక్సెస్ సాక్రిఫైస్ని కోరుకుంటుంది. ఎంత సాక్రిఫైస్ చేస్తున్నారు మీరు అని. మేము రూపాయి సాక్రిఫైస్ చేయం, మాకు మాత్రం అన్నీ కావాలంటే కుదరదు, జీవితం అట్లా వర్కౌట్ అవ్వదు. ఓకే, సో దేర్ ఫోర్ వీఆర్ సాల్వింగ్ దిస్ ప్రాబ్లమ్ బేస్డ్ ఆన్ విచ్ లాజిక్ మా? లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ యాంగులర్ మొమెంటం. If net torque acting on a system is 0, then angular momentum remains a constant. This is what we have studied in the last class. Clear now? So therefore, what I can say, therefore initial angular momentum is equals to final angular momentum, because net torque acting on the system is 0. Are you able to understand now? So initial angular momentum means what? Before combining them, angular momentum of first one was I1 into ω1. This is the formula for angular momentum number. Angular momentum of second disk was how much? I2 into ω2. Okay. Now if I combine both of them, what will happen? So both of them, they start moving with a common angular velocity ω. That's all. Clear number? So what is this omega? This is the common angular velocity. Rendu disk ఒకే velocity తో rotate అవ్వడం స్టార్ట్ అవుతాయి కదా, that angular velocity is omega. So for first one also same hoga, second one also same angular velocity. So therefore, what is the final angular speed? Final angular velocity is I1 ω1 plus I2 ω2 divided by I1 plus I2. So this is the final angular momentum. That is my answer. అసలు ఏమన్నా ఉందా ఇక్కడ సాల్వ్ చేయడానికి? Whenever a question is given, you have to identify question is based on which logic. ఇక్కడ ఏం అడగాలనుకుంటున్నాడు వాడు. Clear? So when you start combining the discs together, you are not applying any force. Torque also applied is 0. If torque applied is 0, then angular momentum will be constant. So initial angular momentum, final angular momentum, they are equal. Clear number? So that is my answer for first question. Then what he is asking second question. Okay. So loss in kinetic energy. So what is the loss in the case of kinetic energy? First of all, what is meant by loss in kinetic energy? Loss in kinetic energy means what? Clear number? It means initially kinetic energy will be greater, finally kinetic energy is lesser. So definitely there is some loss of kinetic energy because of friction. Okay, ba? So because of friction, there is some loss of kinetic energy. Are you able to understand? So therefore, how can I calculate the loss in kinetic energy? Loss is equals to initial kinetic energy minus final kinetic energy. That is how I calculate loss number. Loss in kinetic energy. Initial kinetic energy and final thesis, the loss in kinetic energy was. So what is the initial kinetic energy of the total system before combining? So half I1 omega 1 square plus half I2 omega 2 square. So this is the total initial kinetic energy, no? Before combining, minus after combining, both of them they start with a common velocity, no? So therefore half I1 plus I2 multiplied by omega square. Okay. So I1 plus I2, both moment of inertia I am adding, and what is the common angular velocity? Common angular velocity is omega square. Clear, Dhamma? And omega value already I have calculated, no? Substitute here. So therefore loss in kinetic energy is half I1 omega 1 square plus half I2 omega 2 square minus half of I1 plus I2 multiplied by omega. Omega is how much, ma? I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Clear, no? So try to simplify this one. So therefore loss in kinetic energy is equals to, so half I1 omega 1 square plus half I2 omega 2 square minus half of, so I1 omega 1 plus I2 omega 2. Okay. If you want to further simplify, you can simplify this. Are you able to understand? Is it clear, ma, how we have done the calculation? Very simple. So if you want to simplify, you can further simplify this one. See, ma, here this is square, no? I forgot to put square here. Omega square, no? Okay. So therefore, if I do this calculation, I will get half I1 omega 1 square plus half I2 omega 2 square minus of, so here one I1 I2, another I1 I2 get cancelled. So half of I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2. Okay. If you want to further simplify this one, you can simplify. So the final answer which he gave is loss is equals to half I1 I2 divided by I1 plus I2 multiplied by omega 1 minus omega 2 whole square. Okay, bro? So that is the final answer which you should get. This question here. So now this is a rod which is in rest position about this axis. Rod is in vertical position. Okay, bro? Rod is in rest position and this is the axis of rotation. It means a rod can rotate about this axis. Clear? So a bird of mass m moving with a velocity of v0, it is coming and striking this rod. At what distance? At a distance of L by 3 from the top of the rod. Clear now? Then after striking, the velocity of the bird has become 0. That is why it is falling to the ground. That is the data which is given now. After collision, bird drops to ground. It is falling to the ground. Clear now? So therefore, immediately after collision, a rod will gain some angular velocity. No? It starts rotating with some angular velocity. So what is that angular velocity? First question. And the rod, after some time, it will fall to the ground also. No? A rod will become horizontal. Okay. So when it is about to touch the ground, then what is the angular velocity of the rod? So these two values we are supposed to calculate. Okay. Now can you say how can I do this calculation? Okay, Seema. So what I will do is, I will take this total bodies as my system. Clear now? So bird and rod, both of them I will consider as a system. If you take individual bodies, for example, if you take a rod only, then on the rod, bird is applying force, no? రాడ్ మాత్రమే మీరు తీసుకున్నారనుకోండి, రాడ్ పైన బర్డ్ ఫోర్స్ అప్లై చేస్తూ ఉంది కదా. సో దేర్ ఫోర్ ఐ కెనాట్ సే ఎక్స్టర్నల్ ఫోర్స్ ఈజ్ జీరో. ఓకే, సిమిలర్లీ ఇఫ్ ఐ టేక్ ఓన్లీ బర్డ్, on the bird rod is also applying force, no, by Newton's third law, then also I can say external force acting on the bird is not zero. I cannot say. Are you able to understand? So what I do, I will take rod and bird as a system. Okay ma? So taking rod and bird as one system. Are you able to understand? If I take both of them as one system, then total external forces acting on the system is zero. That's all nama. ఇదంతా ఒక సిస్టమ్గా తీసుకున్నాను అనుకోండి. సో ఫ్రమ్ ద ఎక్స్టర్నల్ సరౌండింగ్స్ ఈస్ ఎనీ ఎక్స్టర్నల్ ఫోర్స్ యాక్టింగ్ ఆన్ దిస్ సిస్టమ్? ఏమైనా యాక్ట్ అవుతుందా? నో. సో ఎఫ్ ఎక్స్టర్నల్ ఫోర్సెస్ యాక్టింగ్ ఆన్ ద సిస్టమ్ ఈజ్ హౌ మచ్? ఎఫ్ ఎక్స్టర్నల్ ఫోర్సెస్ ఆర్ జీరో. ఆర్ యు ఏబుల్ టు అండర్స్టాండ్? If external forces are zero, net torque acting on the system is also zero. If a net torque acting is zero, angular momentum is a constant. That's all. Again same concept. Clear now? If total angular momentum is constant, then I can say L1 is equals to L2. Total initial angular momentum and final angular momentum, they must be equal to each other. Are you able to understand now? So initially, can you say what was the initial angular momentum before bird was coming and striking? Okay ma? What was the initial angular momentum? Initial ante eppudu before bird coming and striking, that is the initial angular momentum. Final angular momentum means after the bird has striken the rod, that is the final angular momentum. Clear? Initial angular momentum is how much? Initial angular momentum is possessed only by bird only. A rod does not have any angular momentum initially. Because rod is in rest position, no, its angular momentum will be zero. Okay. So which one I am taking my axis of rotation? This is the axis of rotation. No? About this axis, what is the angular momentum of the bird? Angular momentum of the bird is mvr. That's all. Or I will write separately. Okay ma? So first of all I will calculate L1. Okay, only bird has angular momentum. Initially which body is having angular momentum ma? Only bird is having angular momentum. About which axis? About this axis I have to calculate, because rod is also rotating about same axis, no? So you calculate angular momentum of the bird also about the same axis. Angular momentum cannot be defined without axis. Already చదువుకున్నాం కదా, angular momentum axis లేకుండా define చేయలేము. Are you able to understand? So therefore L1, so L of bird, so mvr. What is the mass of the bird? Mass of the bird is m. Velocity of the bird v0. So what is the perpendicular distance from the axis of rotation? Here what is meant by r? R is nothing but perpendicular distance from the axis of rotation, no? So this is the axis of rotation. From here, this perpendicular distance is what I require. This is R value here. How much it is? 2L by 3. So total is L value, no ma? So from L, if you remove L by 3, then what is the remaining distance? R is equals to 2L divided by 3. Okay. So multiplied by 2L divided by 3. So this is the angular momentum of the bird also, angular momentum of total system also. Okay. Now L2. L2 is what? Final angular momentum of total system. Okay ma? So here angular momentum of bird is this much, angular momentum of rod is how much? 0 initially. Finally angular momentum of bird is 0. Because after striking, bird is going into rest position, no? Rod to strike అయిపోతూనే bird silent అయిపోయింది అనమాట. Its angular momentum has become 0. Okay ma? So angular momentum of bird is 0 finally. But rod starts rotation, no? Rod rotate అవడం start అవుతుంది కదా. So angular momentum of rod is how much? So I can write I into omega. I into omega is one formula for angular momentum now. Okay. So angular momentum of rod, I value. What is the moment of inertia of the rod? Rod moment of inertia. Rod moment of inertia is ml square by 3 if it is rotating about one axis. Moment of inertia also when axis is present at the middle, then it is ml square by 12. But axis is present at one end of the rod noma, so its moment of inertia will be how much? ml square by 3. So what is the mass of the rod? 3m. m L square. What is the length of the rod? L only. So ml square divided by 3. Clear now? This is the angular moment. This is the moment of inertia of the rod. Multiplied by its initial angular velocity. I don't know. No, let it be omega. So 3 and 3 if I get cancelled, then angular momentum of the rod is of the total system is how much? ml square multiplied by omega 2. This is also equal to L2. What is meant by L2? Final angular momentum. Clear now? So therefore I can say that L1 is equal to L2. So initially only bird is having angular momentum. How much? mv0 into 2L by 3 is equals to, finally only rod is having angular momentum, and it is how much? ml square multiplied by omega. So mass and mass, L and 1L get cancelled. So therefore omega is equals to 2 by 3 V0 divided by L. That's all now. So that is the angular momentum of the rod just after collision. Okay, ma? Just when the bird strikes the rod will have this much amount of angular velocity. Okay, that's it. When bird just strikes the rod will start rotating with this much amount of angular velocity. Clear now? So, but with this angular velocity, rod starts rotation now. So this is the rod initially, and this is the axis of rotation. So bird starts falling. It starts falling with an initial angular velocity of 2 by 3 V0 divided by L. This is the initial angular velocity. So after some time what will happen? Rod will fall to the ground, rod will fall to the ground. Are you able to understand? And here let angular velocity be omega naught or omega dash anything. Omega, this one we have taken omega naught, this one let us consider it is omega dash. Okay. What is this omega dash? Final angular velocity of rod. Final angular velocity of rod when it is about to touch the ground. Ground ko touch ayetapudu inta angular velocity undu. Angular velocity definitely increases, because when rod starts falling down, external force is acting here. Gravitational force is pulling the rod. So because gravitational force is pulling the rod, definitely the angular velocity of the rod increases. Ekku velocity to the ground na touch out. Now can you say, how can I calculate this omega dash? Omega dash value, how can I calculate? Anybody? Huh? How? Torque produced. But torque is not a constant, my dear. By using torque also you can calculate, but torque is not a constant. Okay, but torque R into F. Angle between R and F is continuously changing. Torque is not a constant. With that method it is very tough. Any other method? Initial angular velocity is this much. Final angular velocity, how can I calculate? ఎలా చేస్తాం? See, already we discussed that law of conservation of energy. This I can use, no? Okay. ఇంకా మనకి ఏ దారి కనపడినప్పుడు గోదారే మీ దారి అని చెప్పినాను కదా ఆల్రెడీ మీకు. So when you don't have any other method of solving, then law of conservation of energy always you can apply. Are you able to understand? No? So what is that one? Total initial energy of the system is equal to total final energy of the system. Now if you see here, on this falling rod, which force is acting? Only gravitational force. And gravitational force is what kind of force? Conservative force. అంటే కన్జర్వేటివ్ ఫోర్సెస్ మాత్రమే యాక్ట్ అవుతున్నాయి కదా, ఓకేమా? సో ఓన్లీ గ్రావిటేషనల్ ఫోర్స్ ఈస్ యాక్టింగ్, ఓకేమా? అండ్ గ్రావిటేషనల్ ఫోర్స్ ఈస్ వాట్ కైండ్ ఆఫ్ ఫోర్స్? ఇట్ ఈస్ ఏ conservative force, okay? Because it is a conservative force, I can use the law of conservation of mechanical energy, no? K1 plus U1 is equals to K2 plus U2. In which condition I can use this formula? When only conservative forces are acting. Are you able to understand, no? So initial kinetic energy of the rod, initial kinetic energy of the rod. Kinetic energy means here translational kinetic energy or rotational kinetic energy? Only rotational kinetic energy about this axis. Are you able to understand, ma? So half I omega naught square, initial angular velocity omega naught square, okay ma? Initial potential energy, it is not zero. See ma, for this total rod, total mass will be concentrated at its center, no ma? This is the position of center of mass, no? Let us take this point to be our reference. Ground I am taking to be my reference. Without reference I cannot calculate potential energy, no? This one I will take it as zero potential energy reference. It means this is the point of zero potential energy. So from this point, what is this height? The height anta? L by 2. Clear now? So potential energy formula mgh only, no? What is the mass of the rod? 3m. Mass of the rod is 3m. mgh. What is the height here? Height is nothing but L by 2. Clear now? So 3m into g into L by 2. So this is the initial potential energy of the rod. Understood, no? This is equals to K2. Final kinetic energy of the rod. When it is about to touch the ground, then what is its angular velocity? Omega dash. Clear? So half I omega dash square plus final kinetic energy. Final kinetic energy is 0 because now center of mass is present here, no? ఈ రాడ్ ఇలా కింద పడినప్పుడు center of mass ఇక్కడ ఉంటుంది. It is at same height of zero potential energy, no? So final potential energy of the system is 0. Clear now? Plus 0. Now just calculate omega dash value, that is my required answer. That's all. Okay. What is I value of the rod? I value of the rod is again same, ml square by 3. ml square by 3 only, no? When rod is rotating about one axis. So mass is 3m, L square divided by 3. So it is ml square. This is the moment of inertia of the rod. So substitute all the values, calculate omega dash value, that is my answer. So the answer which you should get is square root of 4 square root of 4 V naught square divided by 9L square 9L square plus 3G divided by L. So this is the final answer which you should get, ma? Check whether you get this answer or not. So let us see this next concept, ma? Combination of translational motion as well as rotational motion. See ma, here consider this is a rigid body, disc, sea, sphere, solid sphere, anything. So it is just moving in a straight line. Okay, it is not rotating. So it's just if it is a disc is moving like this. Clear now? Then it is having which type of motion? Translational motion. No? What is its velocity of center of mass? VCM. So center of mass is just moving like this. For example, consider this is a rigid body. Idila veltundali. That's it. Clear now? Then you take another same rigid body. If it is rotating about this axis, Are you able to understand, ma? With an angular velocity of omega. It means, for example, if this is the rigid body, just it is rotating like this. Okay, about the same axis. Velocity of center of mass is not there. Velocity of center of mass is 0 in this condition. So in this condition, this is only translational motion. So angular velocity will be 0. It is not rotating. Okay, ma? This is what kind of motion? This is pure rotation. Pure rotation means what? Velocity of center of mass will be 0. Understood, no? Angular velocity is 0. Velocity of center of mass is 0. Now if I combine both of them, it means that if you add these two motions, then it is a combination of translational motion as well as rotational motion. Are you able to understand, ma? This rigid body is rotating also, and similarly it is moving in a straight line also. For example, you should have seen the tires of a car, tires of a wheel, tires of a bike. Tire is moving forward, no? Tire munduku veltundi, anduke bike kuda munduku veltundi. Similarly it is rotating also, no? Are you able to understand? That is an example of combination of translational motion as well as rotational motion. Are you able to understand, ma? So it is rotating also, it is moving forward also. It means like how, for example, if this is the body, it is rotating also, similarly it is moving forward also, like this. Rotate kuda avutundi, alage mundariki kuda veltundi. Both are happening here. Are you able to understand, ma? Okay, now see. Now if you see this rotating body, which is rotating with an angular velocity of omega, then it is rotating in this direction, no? Then if you take this point, let us call this point as point number 1. If you take this point, the topmost point, it will have a particular tangential speed, no? It rotate avutundi. This point, topmost point, it will have some tangential speed, no? And what is the formula for tangential speed? Okay, no? Tangential speed is equals to total radius of the disk is how much, no? R. So therefore this point is also present at a distance of r only, no? So tangential speed will be how much? Omega into r. Clear, no? This point will have a tangential speed of omega into r. Okay. Now what about this point? Let us call this as point number 2. This point also have tangential speed, but it will be in this direction, no? So tangential speed of this point will be how much? It is also omega into r only. Are you able to understand? Because radius of this point is also r only, no? And total angular velocity of the rigid body is how much? Omega into r. But here velocity will be in this direction, here velocity is in this direction. Clear now? Similarly, if you take this third point, point number 3, then this point will have tangential speed in which direction? It will have tangential speed in this direction. Are you able to understand? So how much this one? So this is Vt3, again it is omega into r. Are you able to understand? Similarly, if you take this point will have tangential speed in which direction? Let us call it as Vt4. So this is again equal to omega into r. Okay. So when a wheel is rolling like this, rotating like this, then these are the respective directions of tangential speeds. No? Are you able to understand? Okay. Now if you go to translational motion, center of mass velocity is how much? Vcm. It means total body it is moving like this. Okay. Now if you take this topmost point, again let us call it as point number 1. Then this point also will it have some velocity or not? Our point to put a velocity untunda undadu. It will, velocity will be definitely there, no? How much velocity? How much velocity? Same velocity. Center of mass kanta velocity untundo, our point to kudanu ante velocity untundi. So this is also having a velocity of Vcm. Are you able to understand? Then what about this point, point number 2? Same, this is also having a velocity of Vcm. All of them they are moving like this, no? Then what about point number 3? It will have how much speed? Again, in which direction? Same direction, velocity of center of mass. What about point number 4? This also will have same speed number. Again, same speed of velocity of center of mass. Understood? అర్థమవుతుంది కదా? ఇప్పుడు ఈ పెన్ రిజిడ్ బాడీ అనుకోండి, కన్సిడర్ దిస్ పెన్ యాస్ రిజిడ్ బాడీ. ఇట్ ఈస్ మూవింగ్ లైక్ దిస్. దెన్ వెలాసిటీ ఆఫ్ ఎవ్రీ పాయింట్ విల్ హ్యావ్ సేమ్ స్పీడ్. ప్రతి పాయింట్కి సేమ్ స్పీడ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? బట్ దట్ ఈస్ నాట్ ద కేస్ ఇన్ ద కేస్ ఆఫ్ రొటేషన్. Speeds may be same when points are present at same distance, but directions are different. Are you able to understand? Now if you combine both of them, what I am combining translational motion as well as rotational motion. Renditni combine cheste, then this is how I can draw the diagram. Let us draw a bigger picture. Are you able to understand now? So let us call this point to be point number 1. I am adding both of them. Are you able to understand now? I am adding translation, I am adding rotation. Now if you take this first point, this point will have two velocities. No? One velocity because of translation, one velocity because of rotation. Translation valla a velocity v center of mass. Because of rotation, which velocity? Tangential velocity. Are you able to understand? So at the first point, the body will have two velocities. And both of them, they are in the same direction in this condition. Are you able to understand? What is the first velocity? Velocity due to translation, VCM. And which is the second velocity? Velocity because of rotation. So this is rotational velocity is how much? Vt1, which is equals to omega into r. Okay. Therefore, what is the total velocity of this system of point V? Velocity of first point is how much more? Velocity of center of mass plus omega into r. Can I write like this? Both of them, they are in the same direction. No? Definitely I can write like this. Clear now? Now I will take second point. Second point has how many speeds? Two speeds. What are the two speeds? Velocity of center of mass is in which direction? Velocity of center of mass is in this direction. Translational velocity. Velocity because of movement in a straight line. Okay. And because of rotation, it has a tangential speed in this direction. And how much it is? Omega into r. So therefore it has one more velocity, which is called Vt2, and which is equals to omega into r. Okay. Now these two velocities, they are at an angle of how much? 90 degrees. No? They are present at an angle of 90 degrees. Okay. Therefore, what will be the velocity of point 2? Total velocity is equal to square root of Vcm whole square plus omega into r whole square. Can I write like this? When two vectors are at an angle of 90 degrees, then this is the resultant vector number. So velocity of this point will be this much. Or if you want to draw in the form of diagram, let us draw it. So this is what? This is Vt2, which is equals to omega into r. Then two vectors are joined tail to tail number. This is the resultant vector. Okay. So resultant vector is V2. So therefore V2 is this much. Are you able to understand? It means this point's velocity will be in which direction? This point's velocity will be in this direction. Because it has two velocities. Velocity because of translation also, velocity because of rotation also. Are you able to understand? Let us see third point, this point. Okay. What about third point? How many velocities are there? Again two velocities. What are they? Velocity because of center of mass. Okay. Center of mass is moving in this direction. Clear no? Then what about velocity because of rotation? Again same, Vt3 omega into r. So it will have one more velocity, which is Vt3, which is omega into r. Are you able to understand? Then what is the net velocity of point 3 ma? What is the net velocity of point 3? You cannot say it is 0. Why? Because did I say that velocity of center of mass and Vt3 are they equal? Magnitude wise are they equal, did I say? I did not say. Then how can you say it is 0? Just you have to subtract them, that's all. Clear now? So V3 is equals to velocity of center of mass minus omega into r. Okay? Or also you can write V3 is equals to, okay ma, omega r minus velocity of center of mass. Like this also you can write. They are acting in opposite direction, no? Just you have to subtract them. Are you able to understand? Now let us take velocity of point number 4. Point number 4 have how many velocities? This velocity. One velocity is velocity of center of mass. Okay ma? Velocity because of translation. One more velocity, rotational velocity. Rotational velocity is in which direction? Tangential velocity is Vt4, which is equals to omega into r. It is in this direction. So again they are present at an angle of 90 degrees. No? Are you able to understand? No? So therefore this is the resultant velocity. Velocity at point number 4. So therefore velocity at point number 4 is how much mass? Square root of Vcm whole square plus omega r whole square. That's it. So this is how, for example, this is a rotating body as well as it is translating also. Then each point will have different velocity. Okay. Now total how many points I have taken? 4 points. Point number 1, point number 2, point number 3 and point number 4. Out of all of them, which point has highest speed? Can you say? First point has highest speed. Why? Because both velocities we are adding them, no? Add just now direct. So this point has highest speed. Which point has minimum speed? This point number 3 has minimum speed. Because velocities we are subtract. Which point have speed in between maximum and minimum? Point 2 and point 4. They are not maximum, they are not minimum. Are you able to understand? So therefore, what is the conclusion I can draw here? Conclusion is that velocity of first point is maximum. Okay, ma? Velocity of third point is minimum. Are you able to understand? And speed of point number 2 and speed of point number 4, it is equal. But directions are different. Okay, ma? See ma, here, this velocity is in this direction, this velocity is in this direction. E point velocity E direction lo untundi, E direction lo. E point velocity E direction lo. But magnitude wise they are equal, no? Value wise they are same, no? So velocity of point number 4, sorry, speed of point 4 and speed of point 2, they are equal. Speeds are equal. Velocity is equal, ka? Because directions are different, no? Velocities are not equal, speeds are equal. So I can say speeds of 2 and 4 are equal. So understood now how to understand velocity of each point when bodies are undergoing a combination of translational as well as rotational motions. Rendu కలిపి జరుగుతున్నాయి ఇక్కడ. Okay? That's it. Okay? Make a note of this. Let us discuss about this point, point number 3. See ma here. So velocity of center of mass and tangential speed, they may be equal, they may not be equal. Equal undachchu undakavochu. Clear ma? So therefore what I can write here, I can write some cases ma, 3 cases. Okay. So the 3 cases which I can write is, okay, case number 1. I am writing for which point? Point number 3. Okay, ma? First case is that velocity of center of mass can be greater than tangential speed. It is possible, no? Thank you. Clear, ma? So this velocity, which is called translational velocity, may be greater than rotational velocity. Okay? Then net velocity will be in which direction? Net velocity will be towards positive x-axis. Are you able to understand? Ma? So in this condition, then VCM minus VT3 will be the velocity of point number 3. And it is towards which direction? Towards positive x-axis. Are you able to understand? Next, case number 2. The second case which is possible is tangential speed may be greater than speed of center of mass or velocity of center of mass. This is also possible now. This velocity may be greater than this velocity. Then what is the net velocity of point number 3? VT3 minus VCM. అంతే కదా, బిగ్గర్ లోంచి స్మాలర్ తీసేయాలి కదా. సో VT3 may be greater than VCM. Are you able to understand? Then this velocity will be towards which direction, ma? It will be towards negative x-axis. Are you able to understand? So if velocity is greater than this velocity, then net velocity will be towards positive x-axis. Otherwise it will be towards negative x-axis. Case number 3. Case number 3 is that velocity of center of mass may be equal to tangential speed. This case is also possible, no?
velocity of center of mass. What is meant by velocity of center of mass? Translational velocity. Vt3 means rotational velocity or tangential velocity. Both these velocity may become equal also, no? Okay, ma? If they are equal, then what is the velocity of point number 3, ma? Velocity of point number 3 will become 0. That's all. It means this point is temporarily in a rest position. Can I call like that? If this velocity and this velocity, if they are equal and opposite, then velocity of this point will be how much? 0. A point rest lo untundi kada. It means this point will be temporarily in rest position. And that condition is exactly what is called as rolling. A condition emantam manamu rolling condition antam. Okay ma? So case number 3 is a case of rolling condition. Wheels roll avutaya, slide avutaya, translate avutaya. Bike lo vellara leda eppudanna ఆ వీల్స్ రోల్ అవుతాయా, ట్రాన్స్లేట్ అవుతాయా, లేదా రోడ్డు పైన స్కిడ్ అవుతూ వెళ్తాయా? రోల్ అవుతుంది. రోలింగ్ మీన్స్ దిస్ ఇస్ ద కండిషన్. ఓకేనా? ఇఫ్ యూ టేక్ ద పాయింట్ విచ్ ఈస్ ఇన్ కాంటాక్ట్ విత్ ద గ్రౌండ్, సో అవుట్ ఆఫ్ 1, 2, 3, 4 points, which point will be in contact with the ground? This point will be in contact with ground. So this point's velocity, if it is 0 temporarily, then such motion I can call it as rolling motion. Okay? And what is the condition for rolling? Translational speed and tangential speed, they should be equal and opposite. Are you able to understand? So therefore this is the condition of what? This is the condition of rolling condition. Understood now? These two, they are not rolling conditions. Only this one is the condition of rolling condition. Okay? So right now. So therefore our next concept is what? Our next concept is rolling. Understood now? Rolling. So what is meant by rolling? So the point of wheel in contact with the ground, if it is temporarily at rest position, if it is temporarily at rest position with the ground, then wheel is said to be rolling. Wheel is said to be rolling. Are you able to understand? Wheel roll out undi ani artham. Clear? So therefore what I write here, velocity of translational is equal to velocity of rotational. Then the condition is called as a rolling condition. Okay, ma? Or you can say velocity of point number 3 is 0. Or also you can say velocity of center of mass is equals to tangential velocity of point number 3. So this condition is exactly what is called as rolling condition. Are you able to understand, ma? That's it. Okay. Understood now what is meant by rolling? The point which is in contact with the ground, temporarily it should be in rest position. Wheel anta motion untundi, kani aa point ki motion untundi. Is it clear? That point will be in rest position. Okay. Shall I rub this? It will be temporarily at rest position. Now see. So if I want to calculate kinetic energy of this rolling body, total kinetic energy, then this body is having two motions, no? So it is translating also, moving in a straight line. It is rolling also. So therefore total kinetic energy is kinetic energy because of translation plus kinetic energy because of rotation. Both energies will be there now. Clear now? So kinetic energy of translation is how much? It is half m v center of mass square. So this is the kinetic energy of a translating body which is moving in a straight line. Clear now? Kinetic energy of rotation is how much? Half I center of mass into omega square. This is the kinetic energy because of rotation. Half I omega square only. No? Are you able to understand? So kinetic energy because of translation, kinetic energy because of rotation. Okay. So therefore, Sima, I center of mass, moment of inertia of this body about the center of mass can be written as mk square also. No? Kinetic energy can be written as, moment of inertia can be written as mk square also. Do you remember? We have studied a concept called radius of gyration, no?
radius of gyration, where total body I will convert into a point mass and I will rotate at a distance of k. Then moment of inertia of original body and moment of inertia of point mass both should be equal. So I is equal to mk square also I can write. Are you able to understand? So therefore take this value and substitute here, then what I will get? So total kinetic energy is equals to, so half mv center of mass square plus a half, instead of I center of mass I can write mk square multiplied by omega square. I can write like this one. Are you able to understand? Next we know that Sima, I can write up to here. V tangential is equals to omega into r. This relation also I can write now. Tangential speed is equals to omega into r. This also I can write. Okay, now see. Now see here, let us consider this point to be our temporary axis of rotation. I can consider this also. Okay, I can consider this point to be my temporary axis of rotation. If I consider this point to be my temporary axis of rotation, then what will be the tangential speed of this point? What will be the tangential speed of this point? V center of mass will be how much? Are you able to understand? Listen carefully. See now. So, if point P is taken as temporary axis of rotation, temporary axis of rotation. Already we discussed this concept, no? So this point is in rest position, no? In rolling condition, this point is in rest position. So I can assume this total body is rotating about this point. I can assume like that, no? So this point I can also call it as instantaneous axis of rotation, IAR. What is meant by IAR, ma? Instantaneous axis of rotation, or you can call it temporary axis of rotation. Okay, so therefore I can call it as instantaneous axis of rotation. Instantaneous axis of rotation. Okay, అంటే టెంపరరీగా బాడీ ఈ పాయింట్ చుట్టూ తిరుగుతుంది అనుకోవచ్చు. Temporarily I can assume this total body is rotating about this point. That is why it is called instantaneous axis of rotation. Okay? Okay. Now, if I am taking this point to be my temporary axis of rotation, are you able to understand? This point I am taking to be instantaneous axis of rotation. And what is the angular velocity of this total body? Angular velocity is omega. Okay? అంటే ఈ పాయింట్ చుట్టూనే ఇది రొటేట్ అవుతుంది అనుకుందాం మనం. Are you able to understand? It means after some time body will travel like this, after some time body will travel like this. That is called instantaneous axis of rotation. Okay, now can you say what will be the velocity of center of mass? I will write here. So this point is point B, which is instantaneous axis of rotation, the point which is in contact with the ground, and it is rotating with an angular velocity of omega. Are you able to understand? Now this velocity is called V center of mass, no? Velocity of center of mass. If this is the axis of rotation, this is a tangential velocity also, no? If this is the axis of rotation, ఈ పాయింట్ దగ్గర tangential velocity ఎంత ఉంటుంది చెప్పండి? How much will be the tangential velocity at this point? What is the distance from the axis of rotation? Distance చెప్పండి. Distance of this point from axis of rotation is r. Then what is the formula for tangential speed? V tangential is equals to omega into r. That's all. Are you able to understand? So at this point tangential speed is omega into r, and that is nothing but velocity of center of mass. Can I call like that? అలా చెప్పుకోవచ్చు కదా. This point will have how much speed? Velocity of center of mass. And velocity of center of mass, if I write in terms of tangential speed, then how much it is? Omega into r, because total rod angular total disk angular velocity is omega. And what is the axis of rotation? Distance from axis of rotation is r. So I can write V center of mass is equals to tangential speed is equals to omega into r. Okay. Similarly, if I take this point,
if I take this point. Are you able to understand me? Let us call this point as point number 1. Now can you say what is the tangential speed of point number 1? Can you say? Tangential speed of point number 1 ఎంత ఉంటుంది?
Tangential speed of point number 1 will be how much? What is the formula for tangential speed? Omega into what? This is the axis of rotation, no?
So omega. But what is the distance from the axis of rotation? R plus R, 2R. 2R distance is there, no? So omega into 2R I have to write.
Are you able to understand?
Or also I can write it as 2 into omega R. Omega R is nothing but velocity of center of mass, no? So therefore I can write it is 2 times of velocity of center of mass.
Are you able to understand now what is happening?
If I take this point to be my instantaneous axis of rotation, it means if disk is rotating about this point, then this point will have a tangential speed of omega into R. This point will have a tangential speed of 2 into omega into R, which is equals to 2 times of velocity of
Center of mass. Is it clear? Okay. Now let us go to the same calculation here. So can I write Vt is equals to omega into R
is nothing but velocity of center of mass?
I can write no more. So therefore instead of omega what I can write? Can I write V center of mass divided by R? I can write no.
So therefore instead of omega I can write V center of mass divided by R. So take this value and substitute here.
Are you able to understand now?
Therefore what is the total kinetic energy? Clear now? So total kinetic energy is equals to half mv center of mass squared plus half mk squared multiplied by v center of mass divided by r whole square. I can write like this.
Are you able to understand?
So just instead of omega what I have written now? V center of mass divided by r. Okay. Now let us see what are the terms which are constant here. So half mv center of mass square, they are constant. Half mv center of mass square. And what are the terms I am left with? 1 plus k square divided by r square. Okay, ma? So this is another equation to calculate total kinetic energy of a body which is in rolling motion. Are you able to understand, ma? So this is the equation for what? In the case of rolling motion. Are you able to understand, ma? So when a body is rolling, what is the total kinetic energy I can write? Half mv center of mass square multiplied by 1 plus k square divided by r square. So while studying moment of inertia only, we discussed about k square by r square. Do you remember? K square by r square denotes shape of a body. Chadukunnam kada already. K square by r square denotes what? It denotes shape of a body. If k square by r square is 1, then it is a ring. K square by r square if it is 1 by 2, then it is a disc. K square by r square if it is 2 by 5, it is a solid sphere. K square by r square if it is 2 by 3, then it is a hollow sphere. Raskunnam kada already. Gurtunda? So to make the calculations easy only, we have tried to convert this total kinetic energy equation in this form. Is it clear now? Come on, make a note up to here. Okay. So therefore what we have studied, so total kinetic energy is equal to half mv center of mass square multiplied by 1 plus k square divided by r square. This is the equation. Why I have written in this form? Because for rolling bodies, k square by r square denotes shape of a body and nature of the body. So k square by r square denotes shape of a body. Shape of a body, instead of shape of a body, I better write type of a body. Okay, ma? So k square by r square if it is 1, okay, ma? Then that body is a ring. And that body may be a point mass also, but point mass cannot roll, no ma? So k square by r square value if it is 1, then it is which kind of body? It is a ring. Okay, ma? So k square by r square if it is 1 by 2, then it is what? It is a disc. Okay. So k square by r square if it is 2 by 3, then it is a hollow sphere. Okay.
Similarly, k square by r square value, if it is 2 by 5, then it is a solid sphere. Are you able to understand? So whatever may be the type of body given, just you take that value of k square by r square, substitute in this equation, then you will get the equation of total kinetic energy. Okay? Clear now? Now after this, let us do some more analysis on rolling bodies, which is very important. Okay, ma? Now see, now consider this is a rolling body. Okay, so therefore this point will have velocity of center of mass number, and this point will have two speeds. So tangential speed, velocity of center of mass, and it will have tangential speed also. So let us consider this is point P. So for rolling, what is the condition to be followed, ma? For rolling, velocity of point P should be how much? Velocity of point P should be 0. Okay, ma? It is possible in which condition? Only when velocity of center of mass and tangential speed, if they are equal. Okay. Now you take this point to be axis of rotation. Okay. Previously we have taken this point to be our axis of rotation number. Previously we have taken this point to be temporary axis of rotation. Now I am taking this point to be axis of rotation. This would rotate avutundi kada deen chuttu. Okay, this point to be my axis of rotation. Then can you say what is the tangential speed of this point? What is the tangential speed of this point? Minus r. Just you say the magnitude, no need of directions. Magnitude of tangential speed of point P is how much? Now we are considering this body is rotating about this axis. So what is the perpendicular distance from the axis of rotation? Perpendicular distance is r. Clear now? So therefore tangential speed of point P is how much? Tangential speed of point P is omega into r. Okay? And tangential speed of this point is nothing but velocity of center of mass. Are you able to understand now? Ante kada? So velocity of center of mass ఎంత ఉంటుంది velocity? It is also nothing but omega into r. అర్థమవుతుందా? At this point we have only VCM, no? At this point we have only VCM. Tangential speed is not there at the middle, because this point where it is present on the axis itself. Tangential speed will be 0. So this point will have only velocity of center of mass, and velocity of center of mass is equal to tangential speed. Tangential speed is how much? Omega into r. So therefore velocity of center of mass is how much? Omega into r. Okay? Are you able to understand? Now you take this point. Let us call this point as point number 1. This point will have how many speeds? This will have velocity of center of mass also. Are you able to understand, ma? This point will have tangential speed also. Are you able to understand? So what is the velocity of point number 1? Velocity of point number 1 is velocity of center of mass plus tangential speed. Okay. Now can you say what is the tangential speed of this point if this is the axis of rotation? This axis of rotation anukunte ee point ki tangential speed enta. What is the perpendicular distance? R only, no? Again how much? Omega into r only. So Vt1 is omega into r. So V1 is equals to V center of mass plus omega into r. V center of mass already we have calculated, no? V center of mass is how much? Omega into r. So V1 is equals to omega into r plus omega into r. Total how much? 2 omega r. So in the previous condition also same answers I got, no? Are you able to understand? చెప్పేటప్పుడు చాలా కేర్ఫుల్గా వినాలిరా, అన్ని పాయింట్స్ కవర్ అయ్యి ఉంటాయి. సో అండర్స్టూడ్ నమ్మా డిఫరెంట్ మెథడ్స్ ఆఫ్ క్యాల్కులేటింగ్ వెలాసిటీ ఆఫ్ డిఫరెంట్ పాయింట్స్. సో See, let us try to understand once again. See, so this is a rolling body. So in a rolling body, if I take this point to be instantaneous axis of rotation, this is my axis of rotation, then the body is undergoing which motion? Only rotational motion. It is not translating. Okay, ma? In this condition, only which motion? Only rotational motion. Why only rotational motion, ma? Because this axis, it is in rest position, no? This axis for a rolling body, ee point rest lo undali kada. It means this axis is in rest position. If axis is in rest position, it means only rotational motion. Body is not undergoing translational motion. Are you able to understand, ma? So therefore, no translational motion. Translational motion ledu. Okay. Therefore, if you take this point, it will have only tangential speed. Let us take this as v22. How much? It will be omega into r, because perpendicular distance is r. If I take this point as point number 1, are you able to understand, ma? Then what will be its tangential speed? Again omega into r. From the axis of rotation, what is the total distance? R plus r, 2r. So omega into 2r. Clear, no, ma? So 2 omega into r. So therefore, tangential speed of first point is 2 times of tangential speed of second point. So here I am taking, this is the first point, this is the second point. Okay, this is how I have calculated by taking which one to be my axis of rotation? This point to be my axis of rotation. Now it is clear. This axis of rotation ga తీసుకుంటే every point will have only rotational velocities only tangential velocities only. Are you able to understand? Understood, Nama? So if you are taking this one to be your axis of rotation, then every point will have only tangential speed. Velocity of center of mass is not there. Are you able to understand, Ma? Similarly, now if you take this one to be my axis of rotation, middle point to be my axis of rotation, then this axis of rotation is moving also. This axis of rotation is moving also. Are you able to understand, ma? So therefore, if I take this to be my axis of rotation, then rotational motion is also present, translational motion is also present. Are you able to understand, ma? So therefore, in this condition, what I have to write here, let us call this point as point O. If O is taken as axis, okay, ma? Then axis is also moving. Axis is also moving. Therefore, body has translational as well as rotational motions. So if I take this one to be the axis of rotation, then it will have translational motion also, rotational motion also. Are you able to understand me? Therefore at every point, both velocities means what? Velocity because of translation, comma velocity of rotation should be considered. Are you able to understand? No? If I take this to be my axis of rotation, then at every point, or if I take this point, body is rolling now in this condition. If I take velocity of point P, velocity of point P should be how much? Velocity of point P should be how much? 0. How I got 0? Because I have two velocities in opposite directions. Okay, are you able to understand, ma? Velocity of center of mass and tangential speed both are equal and opposite. That is why velocity of point P is how much? 0. And if you take this to be the axis of rotation, then what is the tangential speed, ma? This point ki tangential speed ఎంత ఉంటుంది? Tangential speed will be equal to omega into r.
because radius is how much? Radius is r. Angular velocity is omega. Omega into r. Are you able to understand? Now if you take middle point, this point will have only velocity of center of mass. So therefore velocity of point O is nothing but velocity of center of mass. And velocity of center of mass is how much? Omega into r. Okay? So therefore tangential speed and velocity of center of mass, both of them, they will be equal when body is rotating. At which point? At point P only. Are you able to understand? Similarly, if I take point number 1, here I should take two velocities, no? Are you able to understand now? So velocity of center of mass is in this direction, translational speed also in the same direction. Okay? So therefore velocity of center of mass is how much? Already I have calculated. Velocity of center of mass is omega into r. Now what is the tangential speed of this point? Again omega. What is the perpendicular distance? R only. So omega into r plus omega into r. So how much? 2 omega into r. Okay. So therefore what I can write? Velocity of first point, this point, is equal to 2 times the velocity of point O, which is point O, this point. Are you able to understand? R I can write it is 2 times of velocity of center of mass. I can write like this also. Okay. So here and here, understood the difference now? How we are doing the calculations? Here we are taking this one to be the axis of rotation, but axis is also moving. So at every point I have to take two velocities. Here also two velocities, here also two velocities, but here only one velocity, because here tangential velocity is how much? 0. మధ్యలో అదే rotate అవ్వటం లేదు కదా. So its tangential velocity will be 0, only velocity of center of mass will be there. But here what is the method of calculation? This I am taking to be my axis of rotation. So this point has tangential velocity, this point also has only tangential velocity. Then also I will get the same answers. Clear now? That's it. That is anybody? See ma here. So this is a sphere ma, which is rolling. Are you able to understand? So it is a rolling sphere. So on the rolling sphere, a plank is held by a man. On the rolling sphere, person is placing a plank. And when sphere is rolling, plank is also moving on the what you call this sphere, and a man is holding that plank. Okay. So by the time this sphere covers a distance of 10 meters, plank and the man will cover how much distance? If the sphere is rolling, plank also is moving along with it, and plank is not sliding. Plank is not sliding on the sphere. It is moving along with the sphere. Are you able to understand? So therefore by the time the sphere covers a distance of 10 meters, so what will be the distance covered by the man? That is the question. How can you answer? Chapandi. Okay, ma? So yesterday already we have studied, ma. See here. Consider this is a rolling body. What kind of body? This is a rolling body. Are you able to understand? So rolling body, if I take this one to be my instantaneous axis of rotation, then body is undergoing only rotational motion, no? It is not having any translational motion. Now if you take the center of mass of this sphere, then velocity of center of mass is nothing but tangential speed at the center, no? If it is rotating, it has only which kind of velocity? It has only translational velocity. Sorry, it has only rotational velocity if this is the axis of rotation. Are you able to understand? So what is the tangential speed of the middle point? Tangential speed entuntundaniki. Tangential speed, it is at a distance of r, nama, this point. So tangential speed formula is omega into r. Are you able to understand? So this point, middle point, where center of mass is present. So this is having a tangential speed of omega into r. Okay. Similarly, if I take the topmost point, the point where this plank is attached, are you able to understand, ma?
If you take this topmost point and let us call this is point number 1 and let it be point number 2. Then this point number 2, it will have a greater tangential speed, no? Because it is at a very large distance from the axis of rotation. So if point is present at a large distance from the axis of rotation, tangential speed will be greater, no? Clear now? So tangential speed of this one, let it be Vt2. So what is the tangential speed of this point? Omega into r. But what is r value? R value is r plus r. So this is another r number. So from the axis, what is the total distance? R plus r, 2r. So therefore tangential velocity is omega into 2r. This is what we have studied now in the last class. So therefore how much it is? 2 omega into r. It means that when compared to the central point, this topmost point has how much speed? It has double the speed to that of velocity of center of mass, or when compared to the middle point of the disk. Are you able to understand? No? What about the speed of this point? If I call this point as point P, velocity of this point will be how much? How much? 0, because this is the point which is in contact with the ground. No? For rolling bodies, the point which is in contact with the ground, it does not have any velocity. Okay. Now, by looking at this data, can you say, if a disk or a sphere moves by a distance of 10 meters, then Planck moves by how much distance? Yeah? 20 is the answer. Sima, distance moved by the sphere depends on what? Distance moved by the sphere depends on velocity of center of mass. Sphere is moving in a straight line with how much speed? With the velocity of v center of mass. Correct, no? But when compared to this velocity is double, no? Okay. So if the sphere moves by 10 meters, the Planck which is in contact with the sphere on the topmost point, it will cover double distance. Why it will cover double distance? Velocity is double. Are you able to understand, ma? So therefore what I can say, therefore Planck moves by how much distance? 2 into 10, 20 meters. Meters only now again. So therefore man also moves by how much distance? Man also moves by 20 meters. That's all, that is man's. Are you able to understand, man? Very simple concept. Okay? Because velocity of point number 2 is 2 times of velocity of point number 1. Okay? So therefore, distance travelled by point number 2 will be double of distance travelled by point number 1. And what is the distance travelled by point number 1? It is nothing but distance moved by center of mass. Distance moved by center of mass is nothing but distance travelled by sphere. Distance moved by sphere. That's all. Are you able to understand? Very simple point. Are you able to understand? So if I don't want to do in this method, can you suggest any other method? First of all, make a note of this one, then we will study the second. I will do by using this point to be my axis of rotation. In the first case, method number 1, I have taken this point to be my axis of rotation. Idi axis ga తీసుకున్నాను. So then body has only which kind of motion? Body has only rotational motion. Understood now? When I take instantaneous axis of rotation at the point which is in contact with the ground, then body has only rotational motion. But instead of that, what I can do instead of that, I can take this point to be my axis of rotation. Okay? Middle point of the sphere. If this is the axis of rotation, then the center of mass is also in momentum. My axis is also in momentum. Here axis is in rest position. Ikkada axis temporary ga rest lo untundi. But here axis is also moving. So here I write axis at rest. Okay. But here axis is in translational motion. Axis is in which motion, ma? It is in translational motion. If axis is also moving, then body has 2 types of motions. No? It has translational motion also, it has rotational motion also. That's all. Are you able to understand? Okay. Now if you take this point which is in contact with the ground, again this point will have 2 velocities. No? Okay, ma? One velocity is velocity of center of mass because of movement in a straight line, translational velocity. Okay, ma? And because it is rolling in this direction, it will have tangential speed also. This point will have tangential speed also. That's all. But the body is rolling, no? Body is rolling. Rolling means what? Velocity of center of mass and tangential speed, they should be equal and opposite. That's all. So therefore I can write tangential speed is equals to velocity of center of mass. And they're equal and opposite. So if I take this point as point P, then what is the velocity of point P? Velocity of point P is 0. It is not in movement. Are you able to understand me? Then what about the point which is present in the middle? It has only translational motion. This point is not rotating. No. Perpendicular distance from the axis of rotation is how much? 0. Axis దానిపైనే ఉంది కదా. Axis is present at point number 1 only. So therefore it doesn't have any tangential speed. Rotation వల్ల దానికి speed ఉండదు. Why? Because tangential speed omega into r. R is perpendicular distance from axis. No? What is the perpendicular distance from the axis? 0. Axis is there only. So it doesn't have Vt. Tangential speed is not there. Velocity because of rotation is not there. Which velocity is there? Only velocity of center of mass is there. Only translational velocity is present. Are you able to understand? So shall I write that point also? I will write that point also. Point number 1 does not have which velocity? Rotational velocity. Rotational velocity, in brackets you can write tangential velocity. Tangential velocity. What is the reason? That also I will write here. Okay. What is the reason of this one? Tangential speed of point number 1 is omega into r normal, but what is r value? 0. Omega into 0, so it is equal to 0. For which point? For point number 1. Axis నుంచి perpendicular distance ఏమీ లేదు కదా, అక్కడే ఉంది. So it is 0. But it has velocity of center of mass, no? But point number 1 has which velocity? Velocity of center of mass. Translational velocity is there, movement in a straight line. And velocity of center of mass is equal to how much? Vt. Okay, ma? Velocity of center of mass is Vt. Or Vt at point P, that is better. Tangential speed at point number P. Are you able to understand? And what is the tangential speed at point P? Tangential speed at point P, this is the axis of rotation. ఇప్పుడు axis of rotation ఇది. So this point is present at how much distance? At a distance of r. So tangential speed formula omega into r. Satisfied? So this point number 1 has how much velocity? Omega into r. This is the same answer I got by taking instantaneous of axis of rotation also. IAR తీసుకున్నప్పుడు కూడా ఇదే వచ్చింది కదా. Okay. Similarly, let us take point number 2. This is point number 2. Now point number 2 will have how many velocities? 2 velocities. What are they? So one velocity is velocity of center of mass because of translational motion. Similarly, disk is rotating also, no? So it will have which velocity? Tangential velocity at point number 2. Are you able to understand? Two velocities ఉంటాయి కదా. Because now this is the axis of rotation. Are you able to understand? No? So every point will have 2 velocities. Tangential velocity also, translational velocity also. Tangential velocity అంటే ఏమని? Velocity because of rotation. Tangential velocity means velocity because of movement in a straight line. Okay, ma? So write down. So velocity of point number 2 is how much? Tangential velocity plus velocity of center of mass. That's all, no? Now this point is present at how much distance from the axis? R distance. Clear now? So therefore what is its tangential speed? Omega into r. And velocity of center of mass already we have calculated, no? Velocity of center of mass is how much? Omega into r. So how much? 2 omega into r. Again I got the same result. But which one was easy? Instantaneous axis of rotation was very easy, no? By taking that point to be the axis of rotation, it means only body is undergoing rotational motion. Just you calculate omega r values, that is my answer. Okay, so whatever it may be, again I got the same result, when compared to point number 1, which is point number 1. When compared to point number 1, where I have calculated point number 1, this is point number 1, V1. Okay, this is not V1. V1 where I have calculated? Okay, I will write here. So V1 is nothing but omega into r. That's all. At point number 1, only velocity of center of mass is there, no? And that is equal to omega into r. But point number 2 has how much velocity? 2 omega into r. So it means definitely when compared to this point has double speed. So therefore distance mode also will be double. Again same discussion. That is my answer. So like this also I can do. Are you able to understand? That's it. So therefore V2 is equals to 2V1. Now again this total discussion you can write. So see this question. So this is a disk which is rolling, and it is rolling with a speed of 10 meters per second, and radius of this disk is 2 meters. Okay, ma? Then 3 points are given, ma. Point number 1, point number 2, they are present on the circumference, but point number 3 is present somewhere on the surface of the disk at a distance of 1 meter from the axis of rotation. Okay, ma? Then we are supposed to find out this point, these speeds of these points. Now let us see, ma, here. So disk is rolling with a speed of 10 meters per second. What is this velocity? Disk 10 meters per second speed to veltundante em velocity adi? That is the translational velocity of the disk. That's all, no? Translational velocity of the disk, which is also called as velocity of center of mass. Disk center of mass will be here, no? So center of mass is traveling with a speed of 10. It means the disk is also traveling with a speed of 10. That's it. Are you able to understand? So, and it is given as how much? 10 meters per second. Okay, now let us take, for example, let us take this point as point number 4. This is a rolling body, no? What kind of body, ma? Rolling body. Are you able to understand? So in rolling body, if you take, or let us call it as point number P, because previously also we called it as point number P, no, ma? Velocity of point number P should be how much? It is 0. Velocity of the point which is in contact with the ground, that is always 0. Okay. So this point will have two velocities too. This point will have two velocities. One is velocity of center of mass in the same direction. Because disk is moving in this direction, this same point will have tangential speed also. Both of them, they should be equal, no? So therefore what I write? So tangential speed of point number P and velocity of center of mass, they should be equal, and it is equal to 10 meters per second. Okay. So tangential speed at point number P I got. Are you able to understand, ma? So now let us take point number 1. Clear? Point number 1. Okay. So at point number 1, how many velocities will be there? Again two velocities. Velocity of center of mass will be in this direction. Disk anta translate avutundi kada. It means every point is moving in a straight line. Clear? Similarly, disk is rotating also, no? So because of rotation, it will have tangential velocity of point number 1. Okay, ma? See, ma, tangential speed of point 1 and tangential speed of point P both are same, no? Because both of them, they are present at same distance of r. Are you able to understand? So therefore, if I take point number 1, there are two velocities. One is velocity of center of mass, another one is tangential speed of point number 1. So therefore, what is the resultant velocity? This is the resultant velocity. So this is the total velocity of point number 1. Alage the resultant తీసుకుంటే. Okay, ma? Because they are present at an angle of 90 degrees, V1 is equals to square root of VT1 whole square plus VCM whole square plus 2 into VT1 into VCM cos 90. Because angle between the vectors is 90 now, so this total term will become 0 because cos 90 is 0. Okay. So therefore velocity of point number 1 is square root of VT1. VT1 is nothing but omega into r. This is present at a distance of r, no, tangential speed. So omega into r whole square plus velocity of center of mass whole square. Clear? So therefore no need of substituting this also, ma? So now see, VT1 I can write omega r also. VT1 and VTP both are same, no? Clear, no? I can say that
tangential speed of point number 1 and tangential speed of point number P. Similarly, tangential speed of point number 2, all of them they are equal. This point and this point will have same tangential speed, no? Because all of them they are present at how much distance? They are present at a distance of r. And angular velocity of every point is same. In similarities we have studied, no? In rotational motion, similarities and dissimilarities chadunam kada. Angular velocity of every point will be same, but tangential speeds will be different. So how much it is? It is equal to 10. So substitute 10 there. Directly I can substitute. So 10 square plus velocity of center of mass is already given. It is also 10 square. Clear? So therefore, velocity of point number 1 is how much? So how much more? It is 10 root 2 meters per second. That is my answer. Okay. And you can calculate angle also. So velocity of point number 1 is present at what angle with respect to horizontal or with respect to vertical? For example, if you take this angle as alpha and if you take this angle as beta, then tan alpha, how can I calculate? Tan alpha, how can I calculate? Tan alpha, opposite by adjacent. Opposite is nothing but VT1, no? And this is VCM. Clear, no? So VT1 divided by VCM, both are same, no? So I will get 1. So therefore alpha is equal to 45 degrees. If alpha is 45 degrees, beta is also 45 degrees. So you can calculate the angle of velocity, resultant velocity also. And this also questions can be asked. Are you able to understand? So I have calculated velocity of point number 1, now can you say how can I calculate velocity of point number 2? Velocity of point number 2. Come on. Point number 2 is present here, no? So here how many velocities are there? 2 velocities are there. What are they? Or just you can write it is a 2 omega r. Already we calculated, no? Or just you can say it is 2 times of velocity of center of mass. Already we discussed many times. So that's all, that is my answer. So velocity of point number 2 is how much? 2 into velocity of center of mass. So 2 into velocity of center of mass is 10. So it is 20 meters per second. That is my answer. Understood? No? When compared to this velocity will be double, no? Or you can write like this. So velocity of point number 2, it will have 2 velocities. What are the 2 velocities at point number 2? So one is tangential velocity of point number 2 and the another one is velocity of center of mass. Like that also you can write. But if you add both of them, you will get 2 omega into r. Okay? It means 2 times the velocity of center of mass. So therefore if its velocity is 10, velocity of this point is 20. Okay? Okay, up to here it is fine. Now I want to calculate velocity of point number 3, which is not present on the circumference, which is present at a distance of only 1 meter from the axis of rotation. And angles also, it is not 90 or it is not in the same direction, they are not in the opposite direction also. Okay? First of all, make a note up to here. Let us see this point number 3, see here. This is point number 3, no? This is the center of mass. So from the center of mass, point number 3 is present at a distance of 1 meter. Are you able to understand, So here also this point will have 2 velocities, no? One is velocity of center of mass, another one is tangential velocity. Clear, no? So this is the radius. So tangential speed will be always perpendicular to radius, no? Tangential speed along in the radius ki perpendicular ga untadi. Radius ki perpendicular. Clear, no? So this is the radius. To this radius it is perpendicular. So therefore what is the total angle between 2 velocities? This angle already he gave, it is 37. Oh. Which angle he gave 37, no? Sorry. So this angle he gave 37. This angle is given 37, no? If this angle is 37, this is 90. Here 90 degrees will be there, no? This angle will be 53. This angle will be how much? 53. Okay? And the angle between radius and velocity vector is 90. So 90 plus 53 total how much? 90 plus 53. 143. Clear now? Are you able to understand? So the total angle between velocity of center of mass and tangential speed is how much, ma? 143 degrees. Okay. Now, velocity of center of mass is how much? It is already given, no? Velocity of center of mass is 10 meters per second. Now, can you say what will be the tangential speed of point number 3? Tangential speed of point number 3 will be how much? What is the tangential speed of point P? Point P, tangential speed. Tangential speed is 10 only. Tangential speed of point number 1, 10 only. Tangential speed of point number 2, 10 only. Tangential speed of point number 3, it will be 5 only. 5. Why it will be 5? Because radius is half, no? When radius is 2 meters, velocity was 10. Radius is half. Tangential speed depends on radius. Already we have studied, no? What is the formula of tangential speed? Omega into r. If r is a 10 meter, tangential speed is 10. Sorry, if radius is 2 meter, tangential speed is 10. But radius is only half, 1 meter. So tangential speed also will be half, 5 meters per second. Understood, no? Now, this 10 meters and 5 meters, they are present at how much angle? 143 degrees. Now substitute the equation. So therefore, total velocity of point number 3 is how much? It is equal to square root of 10 square plus 5 square plus 2 into 10 into 5 into cos 143. Okay, ma? So do this calculation, that is my required answer. Clear, no? Cos 143 can be written as cos 90 plus 53. Okay, ma? It is sin 53. Sin 53. So sin 53 value, it is 4 by 5. But cos 143, it is present in second quadrant number, so I will get minus 4 by 5. So velocity of point number 3 is how much? Square root of 100 plus 25 plus 2 into 10 into 5 into minus 4 by 5. Now I hope you can do this total calculation. That is my required answer. Okay, ma? That's it. Cylinder. Carpet ను మడతేసుకుంటూ వెళ్ళాం అన్నమాట. ఎలా సిలిండర్ లాగా. So it became a cylinder finally. Clear now? So therefore let us consider, so carpet has become like this. It means it has been converted into a cylinder. Are you able to understand now? If I look from this side, ఇలాగే కదా నాకు కనిపించేది. So I have rolled this carpet like this. What is the initial mass of the carpet? Mass of the carpet is m and it is made up of inextensible material. So it became a cylinder whose radius is equal to r and is kept on a rough floor. It means there is no slipping. Okay, no? The carpet starts unrolling, okay, without sliding on the floor when a small push is given. So it is present on a ground. I have given a small jerk to this one. Okay, small push means what? This external force you can consider 0. Very small force. Then it started unrolling. Unroll avutundi kada carpet, so it started unrolling. So you are supposed to calculate what is the horizontal velocity of axis of the cylinder when it reduces to a radius of r by 2. It means that, so initially this is the carpet, so it started unrolling. Then after some time it had become a small cylinder. Unroll avutu unte dan radius taggutu veltundi kada. So its radius has become only how much? Its radius has become r by 2. By this time it will have some velocity, no? It will have some velocity of center of mass. Initially velocity of center of mass was 0, it was in rest position. But when it starts unrolling, then it will gain some velocity. So when it reaches to a radius of r by 2 from r, it will have a velocity of center of mass. So that's what he is asking, no? Calculate the horizontal velocity of axis. Horizontal velocity of axis means what? Velocity of center of mass. So that velocity of center of mass I want to calculate after it has unrolled to a radius of r by 2. Okay, ma? Can you say how can I do the calculation? Based on which logic I can do the calculation? Okay? Anybody? Omega, I don't know.
And unroll
అన్రోల్ అవుతే రేడియస్ తగ్గుతూ వెళ్తుంది కదా. So this is a carpet. It is unrolling. Then it will become like this. No? ఇక్కడ అన్రోల్ అవుతూ వెళ్తుంది, ఇట్లా ఓపెన్ అవుతూ వెళ్తుంది. When it starts opening, what happens to radius? Size తగ్గుతూ వస్తుంది. This radius I am discussing about. This is the carpet. I am discussing about this radius. Circular radius. That radius continuously decreases. No? So by the time it unrolls to r by 2, I am supposed to calculate what will be the tangential speed. Are you able to understand? See, very easily I can do this problem by using law of conservation of energy. Okay? Already we discussed, no? If you don't find any other method, then always you can go with law of conservation of energy. So on the system, first of all, you should see how many forces are acting. How many forces are present. Why it is unrolling? It is unrolling only because of gravitational force. That's it. Are you able to understand, ma? So, because initially center of mass will be present here, no, at a distance of r. Finally, center of mass is present here. It is present at a distance of r by 2. So, total mass has come down, no, ma? And it is possible only with the help of gravitational force. Are you able to understand? So, here only conservative forces are acting. If only conservative forces are acting, then what can I do? I can use law of conservation of mechanical energy I can use. Okay, ma? So because only which forces are acting? Only conservative forces are acting. Okay, ma? Only gravitational force is acting, other forces are not present. So law of conservation of mechanical energy. What is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. Okay, ma? Initial kinetic energy 0, no? Because when it was in rest position, there is no kinetic energy. Initial kinetic energy 0. Initial potential energy. Initial potential energy when it was present of the original shape and size. What is its initial potential energy? mgh. Its total mass is concentrated at center of mass, no? And what is its distance? This distance is r. So mg into r. That is the equation of potential energy, no? So plus mgr or minus mgr. That depends on the reference which you take. I will take ground to be zero potential energy reference. Ground I am taking to be zero potential energy reference. When compared to this reference, point is above this zero potential energy reference, no? So positive potential energy. So plus m into g into r. Okay, ma? Now when it has rolled by r by 2, now when it has reached to r by 2, now it has what kind of kinetic energy can you say? Translational is there or rotational is there? Both are present. It is unrolling, no? Carpet is rolling. That's why he said this is a rough floor. Rough floor means what? The carpet which is in contact with the ground, that is in rest position, because it is a rough floor. So carpet is unrolling. It means it is a rolling body. Rolling body means it will have translational velocity also, rotational velocity also. And total kinetic energy in the last class we studied, Nama, half mv center of mass square multiplied by 1 plus k square divided by r square. Already we discussed. This is the equation of total kinetic energy, Nama, for a rolling body. Are you able to understand? And the final potential energy, U2, final potential energy. Potential energy ekkada undi ikkada ippudu. Now mass is present at a distance of only r by 2, no? So m into g into r by 2. mgh, no? H means r by 2 here. But the problem is I have to write m dash into g into r by 2. Why I have written m dash? See, previously total mass of the carpet was bigger, but now carpet is only r by 2, no? Carpet's radius is only r by 2, so mass also will be reduced, no? Now m dash value is how much? Anybody can you say? M dash value, how can I calculate? M dash means what? Mass of the carpet when it is of a radius of only r by 2. Now what will be its mass? So in the carpet, mass is distributed in area or mass is distributed in volume. Carpet lo mass ela distribute ayi untundi. Mass is distributed in total volume, nama. And what is the volume of a carpet? Volume of a carpet. See ma, this is how carpet looks like, no? Carpet looks like a cylinder. Okay? So here I have area pi r square. This is area. No? Area multiplied by length. Area means length into breadth. Another dimension is height. Length into breadth into height, volume only. Are you able to understand? So therefore, pi r square into L. Volume of a cylinder is how much, ma? Pi r square into L. That is the volume of a cylinder. Are you able to understand? So substitute. So therefore, how I can write? I will take pi r by 2 whole square into L divided by pi r square into L multiplied by capital M. I can write like this. So this is the volume of final cylinder. Radius is only r by 2, no? But length is same. Okay, now this length remains same, no? Similarly, what is the volume of initial cylinder? Pi r square into L. So if you take the fraction of this, what you call volumes, you will get fractional volume. Fraction multiplied by total mass, fractional mass. Technique of calculating the mass of the remaining cylinder. Okay, ma? So everything gets cancelled. I will get m by 4. M by 4 only I will get, no? Pi r square, L, everything gets cancelled. 1 by 2 whole square is 4. M by 4 I will get. So what is this m by 4? This is the mass of final cylinder. Are you able to understand? So substitute that value there. So therefore substituting mgr is equals to half m v center of mass square multiplied by 1 plus. Now what is k square by r square value for a cylinder? Cylinder. This is a hollow cylinder or solid cylinder? Solid cylinder. ఎక్కడ ఉంటుంది కార్పెట్ రోల్ చేస్తే స్పేస్ ఎక్కడ ఉంటుంది మీకు? If you roll a carpet, it becomes a solid cylinder. Hollow cylinder ఎట్లా అవుతుంది అది? It becomes a solid cylinder. Solid cylinder moment of inertia is equal to moment of inertia of a disc, no? Moment of inertia of a disc, half mr square. Moment of inertia of a solid cylinder also, half mr square. Are you able to understand? So k square by r square value is how much? 1 by 2. Okay? Already we discussed, no? K square by r square value denotes shape of a body, type of body. So k square by r square value for a disc is 1 by 2. For a cylinder also, solid cylinder also, 1 by 2. Okay, ma? So plus m dash. M dash is how much? M by 4 multiplied by g multiplied by r by 2. This is my final answer. So from this what I am supposed to find out? Just VCM. So calculate that VCM. That is my required answer. Understood, Nama? That's it. So final answer I will write down. Check whether you get the same answer or not. So answer is root 14 gr by 3. So root 14 gr divided by 3. That is the final answer which you should get. So have you understood now the methods of calculation? So to do problems of physics, your previous knowledge also is very, very important. So that is why okay, ma? So see this question. See, ma, this is a hemispherical cup. So hemispherical cup. What is meant by hemispherical cup, ma? Cup made up of half of the sphere, hollow sphere, hollow sphere. So from the top of this cup we are releasing one solid sphere. Mass of the solid sphere is m. Okay, then it starts rolling down and it is reaching to the bottom of this, what you call this hemispherical cup. By the time it reaches to the bottom, its velocity cannot be zero, nama. It will have some velocity. So how much velocity we don't know. So let that velocity be some v. We don't know what is that velocity. Are you able to understand? Then by the time it comes to the base of this hemisphere, we are supposed to find out what is the normal reaction that is acting on this solid sphere because of the hemispherical cup that I want to calculate. Okay? Can you say? How can I do this calculation? How can I calculate normal reaction on this solid sphere because of the hemispherical cup? How can I calculate? No? Seema. So let us consider when it is present at the base of this cup, its weight mg will be acting in downwards direction. No? Weight of this what you call sphere, it will be acting in downward direction. And cup will give certain normal reaction. Cup oka normal reaction istundi kada. In this condition, can I say n is equal to mg? Normal reaction and mg, are they equal? Equal. They are not equal. Why they are not equal? N and mg will be equal only when body is moving in a straight line. But here body is moving in a circular path. Body is moving hemispherical cup. This is example of a circle. Clear now? So this sphere, it is moving in a circular path. Circular path means definitely body should have some centripetal force. No? Without a centripetal force, any body cannot move in a circular path. So who is providing centripetal force here? Centripetal force ni provide chestunnadi evaru? The difference of these two must be providing. Various forces evi levu kada. But only two forces which are acting is, one is normal reaction, another one is weight mg. So centripetal force should be towards which direction? Towards the center of the circle. This is the central circular path. So centripetal force should be acting towards the center of the circle. It is possible only when normal reaction is greater than mg. Already we studied in circular motion, again we are studying. Only when normal reaction is greater than mg, then only there will be some net force acting towards the center of the circle. Are you able to understand me? Okay. So therefore what I can write, n minus mg becomes the net force, no? Because n is greater than mg, n minus mg will become the net force. And what this net force is doing? This is providing the centripetal force. And formula of centripetal force is mv square divided by r. Okay, ma? So therefore what is n value? N value is mv square by r plus mg. Are you able to understand? So if I do this calculation, then I will get the normal reaction acting on that sphere because of the hemisphere, because of the cup. Okay. But the problem is, velocity, is it given? Velocity is not given. This is our assumed value. This value I don't know. So the question is, how can I calculate velocity? Velocity was there, I can do the calculation. I can substitute in this equation and I can get the answer. Are you able to understand? Whenever body is moving in a circular path, definitely you should remember that centripetal force will be acting. Are you able to understand? And centripetal force can be provided by that force which is acting towards the center of the circle. Now the question is, how can I find out the velocity by the time it reaches the bottom of the cup? ఎలా చేస్తాం? అదే కదా మనం డిస్కస్ చేసుకుంది కదా. We have to use law of conservation of energy. Are you able to understand? No? See, this sphere is rolling down because of which force? కిందికి ఎందుకు వస్తుంది? Only because of gravitational force, no? And gravitational force is what kind of force? Conservative force. Clear, Nama? So sphere comes down by which force? By gravitational force, and it is what kind of force? It is a conservative force. Are you able to understand? So because this is conservative force, I can use the law of conservation of mechanical energy. Law of conservation of mechanical energy. What is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. Okay, ma'am? So what is the initial kinetic energy? Initial kinetic energy of the system. Ball ni release చేసినప్పుడు, when I release the ball, is it having any kinetic energy? రిలీజ్ చేసిన వెంటనే kinetic energy ఉంటుందా? పుడతానే పెళ్లి చేస్తాం ఎవరికన్నా? చేయం కదా. రిలీజ్ చేస్తూనే it doesn't have any velocity. So initial kinetic energy is 0. Initial potential energy of the ball, that depends on the reference. Potential energy you can never define without a reference. Are you able to understand? Which one shall I take? I will take this one to be my reference of
zero potential energy reference. Understood now? So therefore, when compared to this position, now this one is present at a height of r no? ఇక్కడ నుంచి ఇక్కడ వరకు రేడియస్ అవుతుంది కదా. So this height is nothing but radius. So initial potential energy is mgh. Instead of h I can write r, mgr. Plus mgr only, no? Why? Because the ball is above the reference. If it is above the reference, potential energy should be taken positive. Clear now? So this is equal to final kinetic energy. Half? Abba. Final kinetic energy is how much? Is it a point mass? Sphere point mass? కాదు కదా, రోల్ అవుతూ కిందికి వస్తుంది. Because it is rolling, it will have both rotational kinetic energy as well as translational kinetic energy. రెండు kinetic energies ఉంటాయి. So therefore, what is the total kinetic energy? Yesterday we have written to half mv center of mass square multiplied by 1 plus k square divided by r square. This is the formula. ఇదే కదా నిన్న మనం డిరైవ్ చేసింది. This is the total kinetic energy, which is the sum of translational as well as rotational. Clear now? Plus final potential energy. Final potential energy. Now body has reached to zero potential energy reference, Nama. So final potential energy will be zero. Are you able to understand? That's all. So now what is k square by r square value for a solid sphere? 2 by 5. This is the k square by r square value for a solid sphere. Are you able to understand? Now substitute all those values, then you will get velocity of center of mass. Are you able to understand? So take that velocity of center of mass and you substitute here. Are you able to understand? Then I will get the required normal reaction. That's all. That is my answer. So first I have written equation for centripetal force. Then I have used a law of conservation of energy, calculated velocity. Once I calculate velocity, I can get the normal reaction. That is the process of solving. Clear? Come on. Okay, ma? So when you substitute velocity of center of mass here, the final answer which you should get is 17 by 7 mg. So check whether you get this answer or not. Clear, ma? That's it. Okay, now see. So see this question. So this is an inclined plane, ma, which is present like this, and on that inclined plane there is a hollow sphere which is moving with a velocity of v. Are you able to understand? And angular velocity is also given omega. Then we are supposed to find out what is the maximum height that this sphere can obtain on this inclined plane. See, by the time it starts moving, gravitational force will be pulling it downwards. No? So what happens to the speed of this particle? Speed continuously reduces, and after reaching some maximum height, its velocity will become zero. So at that position, I want to calculate what is the maximum height that this particle can reach. Okay? Anybody? How can I do? Come on. How can I do this calculation? How many forces are acting, ma? Only gravitational force is acting. So therefore, I can use law of conservation of mechanical energy. That's all. Initial kinetic energy. Which energy? Translational energy or rotational energy? Rendu unnai kadaya. It is moving also in a straight line. It is rotating also. So two energies are there, no? So therefore, what is the total kinetic energy? Half m v center of mass square multiplied by 1 plus k square divided by r square. This is the total kinetic energy. Sum of kinetic energy of translation, kinetic energy of rotation. Initial potential energy, I will take this one to be my reference. Zero potential energy reference. Therefore, what is initial potential energy? Zero. Clear now? So this is equals to final kinetic energy. So this hollow sphere, after some time, let us consider it reached up to here. Up to which height? Up to a height of h. Okay, ma? So this is maximum height, no? After reaching to maximum height, what will be its velocity? 0. Final velocity will be 0.
So translational velocity is 0 or rotational velocity is 0? Both are 0, no?
So both kinetic energies are 0. Okay, ma? Final potential energy mgh. So mgh max plus mgh only, no? Because it is above the reference. Now just this h value I am supposed to calculate. Height only, no, he is asking. H max. No, substitute the value. So what is k square by r square value for a hollow sphere, ma? For a hollow sphere it is 2 by 3. Clear? So substitute all the values. Mass is how much? Mass, did he give anything? Mass is not given. No need of mass also. So half m v center of mass square multiplied by 1 plus k square by r square value 2 by 3 is equals to mgh max. Clear, no? So mass and mass gets cancelled. So half v square 5 by 2, 5 by 3 is equals to g into h max. Okay. So therefore h max is equal to how much, ma? So 5 by 6 v square divided by g. So this is the maximum height this particle can reach. That's it. Okay. Angle of inclination is theta. Okay. So in this condition, first of all I want to calculate velocity with which it touches the ground. Okay, ma? So if I release this one with an initial velocity of 0 meters per second, then it starts rolling down. Okay, ma? It is not sliding, it is rolling down and it is reaching the bottom of this inclined plane. Then how can I calculate velocity? Let us see, ma. Again I will use law of conservation of mechanical energy. So k1 plus u1 is equals to k2 plus u2, because only gravitational force is acting. No? For pure rolling, friction is 0 now. For pure rolling, friction doesn't do any work in this condition. So you need not to take friction. But for rolling, friction is required. Body roll avvalante friction undali. But friction doesn't consume energy. Are you able to understand? So it means only force which is acting is gravitational force. So k1 plus u1 is equals to k2 plus u2. Initial kinetic energy 0. At this height there is no kinetic energy, no? 0. Initial potential energy, let us take this to be my 0 potential energy reference. Okay, ma? Then initial potential energy is how much? Mass of the sphere, let it be m. How much, ma? So mgh. This is not a sphere, ma? Any rolling body. Okay. Final kinetic energy. Final kinetic energy. So it will have both energies, no, ma? By the time it reaches to the base of this inclined plane, it will be rotating also and it will be translating also. Rotate kuda avutu untundi, mundariki kuda veltu untundi. That is called rolling, no? Clear, no, ma? So therefore total kinetic energy is half m v center of mass square multiplied by 1 plus k square divided by r square. That's all, no, ma? Final potential energy 0, because it has reached to this reference, no? Final potential energy is 0. Okay. So therefore mass and mass get cancelled. So velocity of center of mass is how much, ma? It is root 2gh divided by 1 plus k square divided by r square. So this is the equation of final velocity by the time it reaches the ground. Are you able to understand, ma? So v is equals to square root of 2gh divided by 1 plus k square divided by r square. Okay. Now let us carefully study this equation. Okay, ma? So velocity of center of mass is nothing but the translational velocity of this sphere, the velocity with which it is coming down. So that velocity, it is dependent on height, no, ma? Velocity is dependent on height. It means if height of the inclined plane increases, velocity also increases. Okay. Velocity of center of mass, it is dependent on k square by r square value also. Clear, no? It means if k square by r square value increases, velocity decreases. Are you able to understand? And we know different k square by r square values, no? So you see which k square by r square value is maximum. For that one, velocity will be minimum, because they are inversely proportional. Are you able to understand? So what are the note points I have to write in the case of velocity? Note points is that
as height increases, okay ma, as the height increases, what I can say, velocity also increases. Velocity also increases. Are you able to understand? What is the second note point? As k square by r square value increases, velocity decreases. Okay ma? Because k square by r square value is present in denominator. అది ఎక్కువగా ఉందనుకోండి, వెలాసిటీ తగ్గుతూ వెళ్తుంది. Is it clear ma? Now see. So k square by r square value for different values I will write down. Okay ma? So this is equal to 1 for which body? For I can say a ring. Clear na ma? So k square by value is 1 by 2 for disk. Clear? So k square by r square value is 2 by 3 for hollow sphere. Okay ma? And disk can also be called as solid cylinder also. Because for solid cylinder also k square by r square value is 1 by 2 1. Clear na ma? 2 by 3 for hollow sphere. Okay ma? And ring can also be called as hollow cylinder. So for hollow cylinder also k square by r square value is 1 only. Are you able to understand? 2 by 3 for hollow sphere and 2 by 5 for 2 by 5 for what? Solid cylinder. Are you able to understand now? So now you check their values. Which one is having highest k square by r square value? Which one is having highest k square by r square value? Ring or hollow cylinder. Are you able to understand now? So therefore from this inclined plane, if I release all those bodies, which body will come down at the last? చివరిలో ఏదొస్తుంది? ring వస్తుంది. Clear no? So in the last position ring will come down because its k square by r square value is maximum. Are you able to understand? And whose k square by r square value is minimum? Minimum. So 1 by 2 0.5, 2 by 3 greater than 0.5, 2 by 5. This one is least, no? 2 by 5 is least. So therefore 2 by 5 value, if it is least, then velocity will be maximum. Clear no? Because velocity is maximum, first solid cylinder will come down, then in the last ring will come down. So question can be asked on this information also. Are you able to understand? So therefore velocity of which one is maximum? Velocity of solid sphere is maximum. Why? Because its k square by r square value is least. Then it is followed by what? Then it is followed by disk, no? So therefore velocity of disk. Then it is followed by hollow sphere. Hollow sphere. Okay ma? Velocity of hollow sphere. And it is greater than velocity of ring, or you can call hollow cylinder. Okay, so check the sequence whether it is correct or not. Least value for this only, solid cylinder, sorry man, what I am writing, 2 by 3 solid sphere, not cylinder, solid sphere. Okay, so this is having least value, no? So therefore its velocity will be maximum. Next least value, 1 by 2 is greater or 2 by 3 is greater? 1 by 2 is greater, 0.5. This is only 0.66. So this one is value. So velocity of disk will be maximum. Next velocity. Okay ma? Then velocity of disk is greater than velocity of next hollow sphere, 2 by 3. Then the highest k square by r square value is for ring. Okay ma? Ring or hollow cylinder. So therefore its velocity will be least. So like this I can write the sequence. No? So when you release all of them, first one solid sphere will reach the ground. Then in the last ring or hollow cylinder will reach the ground. Are you able to understand now? So disk is also called as solid cylinder. Understood now? So this discussion is very, very important because questions can be directly asked on this discussion. Are you able to understand? That's it. Okay. So once I have calculated velocity and made a discussion on velocity, then I will calculate about acceleration of these particles. Are you able to understand? What about the acceleration of these particles? Okay. So let us see how I can do the acceleration. See, this is accelerated motion only, no? Net force is acting, no? Gravitational force is acting on the bodies. Definitely this is an accelerated motion. So therefore I will use the relation v square minus u square is equals to 2a. This relation I will use. Final velocity equation already I have, no? How much? Root 2gh divided by 1 plus k square divided by r square whole square. Clear, no? Initial velocity 0. So 2 into acceleration I don't know multiplied by displacement means this displacement only, no? This displacement is s. So how can I calculate s value? S value is it given? S value is not given. So what can I do? Yes, ఇవ్వలేదు కదా, ఏం చేయాలి మరి? Split this s into two components. Clear, no? Adjacent side is s cos theta, opposite side is s sin theta. Clear, no? So s sin theta is how much? Here only I will do, ma. So s sin theta is nothing but h, no? So therefore s value is how much? H by sin theta. Can I write like this? So instead of s what I can write? Instead of s I can write h by sin theta. Are you able to understand now? Which equation we are using? V square minus u square is equals to 2as. Okay. Now from this I want acceleration. Let us see. So 2gh divided by 1 plus k square divided by r square is equals to 2 into a into h by sin theta. Clear number? What are the terms which can cancel? H and h get cancelled. 2 and 2 also get cancelled. Okay, ma? So therefore a I will get g sin theta divided by 1 plus k square divided by r square. So that's it. This is my answer. Are you able to understand? So therefore the bodies, they start coming down with this much of acceleration. Are you able to understand? Now acceleration is depending on how many factors? Acceleration is depending on sin theta. It means if theta increases, acceleration also increases. Angle of inclination ఎక్కువ ఉందనుకోండి, acceleration కూడా పెరుగుతుంది. Clear number? And it is inversely proportional to k square by r square. If k square by r square value is greater, acceleration will be least. Again same condition. Here also same condition. So same condition you can write here also. Are you able to understand? So therefore what are the note points I have to write now? Note points are there. Acceleration depends on first one. Acceleration, or just I will write down. If theta increases, acceleration also increases. I can write like this one. Similarly, if k square by r square value increases, acceleration decreases. I can write like this also. Clear? Then write the same type of equation here also. Here what I can write? So acceleration of solid sphere is greater than acceleration of disk is greater than acceleration of hollow sphere is greater than acceleration of ring. Okay, ma? Disk can also be written as solid cylinder. Ring can also be written as hollow cylinder. Okay, because their moment of inertia remain to be same. Understood, number? So this is the discussion we have done based on what? Based on the equation of kinematics. V square minus u square is equals to 2as. Are you able to understand? Very simple concept. Clear, ma? Once you calculate 1 or 2 times, very easily you can understand what is happening here. Okay? See, my velocity should be greater, acceleration also should be greater, no? Velocity ఎక్కువ ఉందంటే మీనింగ్ ఏమి? యాక్సిలరేషన్ కూడా ఎక్కువ ఉందని. సో ఏ బాడీ త్వరగా కిందికి వస్తుంది? దేని వెలాసిటీ ఎక్కువ ఉందో అది త్వరగా కిందికి వస్తుంది. వెలాసిటీ ఎక్కువగా ఎప్పుడు ఉంటుంది, k square r square వాల్యూ తక్కువ ఉన్నాం. Are able to understand? No? And if velocity should be greater, acceleration also should be greater. That's it. Understood? No? Come on. So after this we will do one more calculation. No? Up to here it is clear, no? So this equation and this equation, if you can by heart them, then it will be very helpful for you. Because every time you can't do all this derivation, no? ప్రతిసారి ఈ డెరివేషన్ చేయాలంటే అదిరిపోతుంది అన్నమాట. Clear? So you are supposed to remember this equation as well as time equation also. Okay, no? Now let us see. So the final derivation which we are doing is, shall I rub this? Okay. One more derivation which we do is time. Time taken to reach the bottom. Time taken to reach the bottom of this inclined plane. Okay. Which equation I can use? I can use v is equals to u plus 18 omega. This equation I can use. Because I have equation of velocity also, I have equation of acceleration also. Okay, initial velocity is 0. Substitute here. So root 2gh divided by 1 plus k square divided by r square is equal to initial velocity 0. Acceleration is how much? Acceleration is g sin theta divided by 1 plus k square by r square multiplied by time taken. Clear, no? Now let us see what are the terms which can get cancelled. Here I have root of 1 plus k square by r square. Here I have 1 plus k square by r square. So here root g is there, here g is there. So I can do one thing. So root of 2h. Okay, ma? So root 2h will be remaining here. Root g and root 1 plus k square by r square get cancelled. So here I will get root g. Here I will get sin theta. Here I will get root of 1 plus k square by r square multiplied by time. Clear, no? So therefore t is equals to square root of 2h into 1 plus k square by r square divided by g multiplied by sin theta. Okay, ma? See whether it is correct or not. Divided by sin theta. Here just I have to write 1 by sin theta. Okay, ma? So this is my answer. Or if you want to write separately, you can write down 1 by sin theta multiplied by square root of 2h by g multiplied by square root of 1 plus k square divided by r square. Okay, ma? So this is the equation for time taken by the particles to reach the ground. Okay, ma? Now the question is, time taken depends on how many quantities? Time taken depends on how many quantities? Okay, ma? See, it is dependent on theta, no? It is dependent on height, no? It is dependent on k square by r square. Okay? If angle of inclination increases, time decreases. Are able to understand? Ante kada. Angle of inclination ఎక్కువ ఉందంటే బాడీ త్వరగా కిందికి వస్తుంది. ఓకే. Height increases, time increases. K square by r square increases, then also time increases. Understood, Nama? See, my if velocity and acceleration are greater, time will be lesser only, no? Velocity and acceleration, they are inversely proportional to k square by r square. Okay. Velocity పెరిగితే time తగ్గుతుంది కదా. So time is directly proportional to k square by r square. Directly we cannot say, but it is dependent on k square by r square. It means if k square by r square value increases, time will decrease. Sorry, if it increases, time also increases. Understood, Nama? So therefore, completed now this side. Okay, ma? So So therefore, what are the note points here I have to write? Note points are that time depends on how many factors, ma? It depends on theta, height and shape. Shape means what? K square by r square. So time is dependent on 3 factors. Understood now? So exactly opposite relation I can write. Okay? So T is greater than T is greater than T is greater than T is greater than. Okay ma? So which one will come in the last ma? అన్నిటికంటే కిందికి ఏది చివరిగా వస్తుంది? Ring, no? That's what we studied. So time taken by the ring will be maximum. Ring also can be called as hollow cylinder. Are you able to understand ma? And which one will come very fast? Solid cylinder. Clear no? So time taken by solid cylinder will be least. Okay? Then what was the sequence we have written ma? Velocity of solid cylinder greater than disk. So here a disk will come, or you can call it as solid cylinder. Okay ma? And finally this is for solid hollow sphere. This is solid sphere, no? Cylinder or sphere? Solid sphere. So this is hollow sphere. Understood now? So exactly opposite statements we have written for velocity as well as acceleration. Velocity and acceleration follow the same trend. Time will be exactly opposite to that, because as velocity and acceleration increases, time will decrease. So you can make a note of that also. Clear now? So as velocity and acceleration increases, time decreases. Clear? That's it. Which we are studying last concept in rotational dynamics now. So what is the minimum amount of friction required for rolling down an inclined plane? See ma, if I release this spherical body or circular body from here, it should start coming rolling downwards, and rolling is possible only if friction is there. ఫ్రిక్షన్ ఉంటేనే టార్క్ ప్రొడ్యూస్ అవుతుంది, టార్క్ ప్రొడ్యూస్ అవుతూనే బాడీ రోల్ అవుతుంది. ఓకేమా? ఇఫ్ దెర్ ఈజ్ నో ఫ్రిక్షన్, వాట్ విల్ హ్యాపెన్? కెన్ యూ సే? ఐ ఆమ్ రిలీజింగ్ అ సాలిడ్ స్పియర్, దెర్ ఈజ్ నో ఫ్రిక్షన్, దెన్ వాట్ విల్ హ్యాపెన్? Body doesn't roll down, body just it comes downwards, it comes sliding downwards, it doesn't rotate. Okay ma? So therefore for rolling motion definitely friction is required. But here in pure rolling, friction doesn't consume energy. In pure rolling motion, friction energy ni consume cheyadu. Endukala? Because work done by friction is what? Work done is equal to Fs cos theta nama. So friction is applying force, but displacement is not there. Why displacement is not there? Because the point which is in contact with the ground, that point it is not sliding, no? The point rolling ante condition, what is the condition of rolling ma? The point which is in contact with the ground, that point is temporarily in rest position, that is not sliding. Slide out the displacement untundi, sliding is not there, no? So friction is there, responsible for rolling, but it doesn't consume energy. So directly you can, that's the reason why we have used law of conservation of mechanical energy, no? K1 plus U1 is equals to K2 plus U2. In which condition I can use? Only when conservative forces are acting. But friction is also there, no? For rolling, friction is also there, no? But friction cannot consume energy. This is one point which you should remember. Are you able to understand? Now see. So therefore, because it is rolling, I can say that friction is producing torque. Friction is responsible for producing rotation, no? For example, I say this is the circular body and friction will be acting in this direction. Clear, no? Body kindiki ravalani chuste friction ఏ వైపు యాక్ట్ అవుతుంది? In opposite direction. So what is its radius, ma? Perpendicular distance from the axis of rotation is how much? R. So what is the torque formula? Torque is equals to R into F is equals to I into alpha. This is the equation for torque. No? Are you able to understand? No? And what is meant by alpha here? Angular acceleration which is produced in the disk or which is produced in the circular body. Are you able to understand? Now see. So we know that velocity tangential speed of the disk. So disk will be having some tangential speed, no? Clear? At this point tangential speed will be there. No? So tangential speed is equals to omega into R. Already we know this relation. No? And because it is rolling, tangential velocity is also equal to velocity of center of mass also. Are you able to understand? Because at this point velocity of center of mass will be there. So here also velocity of center of mass will be there. Already we studied in combination. No? So rolling means what? This point should be in rest position. Velocity of point P should be how much? 0. It is 0 only when tangential velocity and velocity of center of mass they are equal. So therefore tangential speed is nothing but velocity of center of mass. Are you able to understand? So therefore if I differentiate this one with respect to time, differentiating with respect to time, if I differentiate this one with respect to time, then velocity of center of mass differentiation with respect to time is equals to d by dt of omega into r. Clear now? Differentiation of velocity, acceleration, that's all. No? So therefore acceleration of center of mass is equals to r is a constant, differentiation of omega, omega means velocity, differentiation of velocity, acceleration, which acceleration? Angular acceleration. I can get this relation. Are you able to understand? No? So acceleration of center of mass, actually this is a tangential acceleration. This is what acceleration? Tangential acceleration. But tangential acceleration and acceleration of center of mass they are equal because it is what kind of body? Rolling body. Okay. So this is also equal to tangential acceleration, alpha into r. So instead of alpha what I can write? This is my first equation. So therefore instead of alpha I can write acceleration of center of mass divided by radius. So take this value and substitute here. Are you able to understand? So therefore what I will get torque is equals to r into f is equals to I into alpha. Instead of alpha value what I can write? Acceleration of center of mass divided by radius. This is what I can write. Clear no? Okay. So we are doing this calculation also because many concepts you will get cleared here. Concepts अन्नी मल्ली इंकोसारी clear out. अंते इंकेम लें. Clear? Now see. So moment of inertia of any body I can write it as mk square no? By using radius of gyration concept. K means radius of gyration only. No? Radius of gyration means what? Any body we are converting into a point mass. So moment of inertia can be written as mk square. Clear? So therefore instead of moment of inertia substitute that value. So r into f is equals to I, instead of I will write mk square multiplied by acceleration of center of mass divided by radius. Okay. Now you take m and a on one side. So m into a if I take on one side, then what I am left with? So this is r, this is also r. Okay, ma? So I can write f r square divided by k square. I can write like this one. So consider this is my second equation. Okay, ma? And what is mass into acceleration, ma? Mass into acceleration is net force, no? This is my second equation. Okay, ma? So therefore on this rolling body, what is the net force which is acting? Net force is f r square divided by k square. Questions were asked previously on this relation also. E relation paina kuda okasari question adigi. Mass into acceleration is net force only, no? So what is the formula of net force? F r square divided by k square. Up to here it is clear, no? Okay. Now this is what force, ma? Actually that force is nothing but a frictional force, no? Who is providing torque? Friction is providing torque. So here capital F is nothing but friction. Okay. So F is nothing but small f, friction. So substitute. So therefore I will write net force acting on the body is F r square divided by k square. Understand? Okay. Now, net force I can write in one more method also, no? Now see my here. This mg we have split into two components, no? Mg sin theta, mg cos theta. Same mg sin theta is acting here also, no? This is also mg sin theta. Are you able to understand? So mg sin theta minus friction gives the net force. Because when body is coming downwards, downward force should be bigger, no? Which is the downward force? Mg sin theta. Upward force? Friction. So mg sin theta minus, so this is translational motion. Okay, ma? So mg sin theta minus friction should be equal to mass into acceleration of center of mass. Can I write like this? Net force gives mass into acceleration. Okay, ma? So this is my third equation. Now second equation, third equation, both are same, no? This is also net force, this is also net. So equate both of them. 2 is equal to 3. Clear now? So what is 2 here? F, small f I will write here. Let us call this one as second equation, ma, instead of this one. So therefore I will write f r square divided by k square is equal to how much? Mass into, or I will write like this. This is equals to mg sin theta minus f. Clear no? Understood no? Now you take f common. So if I take f common, then it is 1 plus r square divided by k square. Okay ma? This is equal to mg sin theta. Understood no? So therefore what is the equation of friction which I got? Equation of friction is equals to mg sin theta divided by 1 plus k square divided by r square. So questions were asked on this relation also. Okay ma? So what is the amount of friction acting on a rolling body ma? Down an inclined plane? It is mg sin theta divided by 1 plus k square divided by r square. Understood no? Okay. Now still our calculation is not complete. So what he is asking, minimum amount of friction or minimum coefficient of friction also we will calculate. So this is the minimum amount of friction which should act, no? Are you able to understand now? What is this one? F minimum. Minimum amount of friction that should be acting on a rolling body down the inclined plane. Mg sin theta divided by 1 plus k square divided by r square. Okay. Now I will also calculate minimum coefficient also. Okay ma? Next what is my calculation? Minimum coefficient of friction. This also I will try to calculate. Okay. See ma, if coefficient, listen very carefully, if coefficient of friction is minimum, are you able to understand ma? It means friction has already reached the maximum value, no? Ante just అది స్లిప్ అవ్వడానికి ఎంత ఫ్రిక్షన్ ఉందో అంత తీసుకుంటాం మనం. ఇట్ మీన్స్ ఫ్రిక్షన్ ఈస్ మినిమమ్ మీన్స్ ఆల్రెడీ ఫ్రిక్షన్ హ్యాస్ రీచ్డ్ ద maximum value. And what is the maximum value of friction called? FL, limiting friction. Clear now? Friction is very less. It means just it is supporting the body for rolling. And the friction has already reached the maximum value. And what is the maximum value of friction called? Limiting friction. Okay. And what is the formula for limiting friction? Mu s into n. This is the formula of normal limiting friction. What is the normal reaction in this condition? Normal reaction in the condition. See my mg cos theta is the force with which this sphere is pushing the inclined plane. Then what inclined plane will do? Inclined plane also will give same amount of normal reaction. And what is the normal reaction? Mg cos theta. Understood now? So substitute. So therefore FL is equals to mu s into normal reaction is how much? Mg cos theta. Clear now? Now friction is minimum, no? And minimum is friction is nothing but FL, no? So substitute there. So therefore, what shall I call this equation? Let us call it as fourth equation. Let us call this one as fifth equation. Okay, ma? So therefore, 4 is equal to 5. Equate both of them. So mu s mg cos theta is equals to mg sin theta divided by
1 plus k square divided by r square. So mg get cancelled. Cos theta, if it goes to that side, it will become sin theta by cos theta, tan theta. Tan theta divided by 1 plus k square divided by r square. Okay, ma? So this is the minimum amount of coefficient of friction required for the body to continue rolling. Okay, ma? If coefficient of friction is less than this friction, then body cannot roll, it will slide downwards. Is it clear? Minimum friction is this much, minimum coefficient of friction is this much. Minimum friction is Lg sin theta divided by 1 plus r square by k, sorry ma, this is not k square by r square ma, this is r square by k square. Okay ma, here also I think we have done mistake. So it is r square by k square, and here also r square by k square. Understood, no? K square by r square denotes a shape. R square by k square reciprocal of that. Understood, no? So mu s is tan theta divided by 1 plus r square by k square. Minimum friction, minimum coefficient of friction. This is the net force Fr square by k square. So minimum these three parameters you should remember. Minimum ivi meeru gurtu pettukovali. Ivi second one, where is third one, fourth one and fifth one. These three results you must remember. Okay? It is lying on a smooth horizontal surface. It is pulled by a horizontal force acting tangential at the highest point. Find the distance traveled by the sphere by the time it makes one rotation. Okay ma? So adi oka rotation complete chese lopu enta distance ni travel chestundi. Okay? Try chestara kasepu cheyandi. So this is a solid sphere, radius is r, we are applying a force of F, and surface is frictionless, there is no friction. Now the question is what this force will do. You are applying force on the top of the sphere, no? Tangentially means what? You are applying force on the top of the sphere. Okay? Are you able to understand? Now the question is what this force will do. Ee force em chestundi? Pull the body. So pulling, will it produce translational motion or rotational motion? ఈ పుల్లింగ్ వల్ల డిస్క్ ట్రాన్స్లేట్ అవుతుందా, రొటేట్ అవుతుందా? రెండు జరుగుతాయి. దట్ ఈస్ కరెక్ట్. క్లియర్ మా? See here. So because of this force is pulling the body forward now. So body will move in a straight line. Translational motion will be produced. What is meant by translational motion? Moving in a straight line. So translational motion will be produced. Clear? So therefore I can write this is the net force in translational motion. In translational motion I can write F is equal to ma. Are you able to understand? No? That is the net force which is produced. Clear? So therefore what is the acceleration? A is equals to F by m. This is the acceleration which is produced in a straight line. So with the help of this acceleration, what will be the distance moved by the body? This is accelerated motion, no? Accelerated motion means how many equations we have? 4 equations we have, no? So use any one of the equation. I will use s is equals to ut plus half at t square. So let us consider I will use this equation. Initial velocity is 0, no? So ut is 0. So in a time of t, s is equals to half at t square. That will be the distance traveled in a particular time of t with this much amount of acceleration. Clear? Now if I study about rotational motion. Okay, ma? So this force, it is not acting on the axis, no? Force ekkada act avutundi? Axis paina aithe act avvatam ledhu kada, it is acting at a perpendicular distance from the axis, at a distance of r. So definitely torque will be produced, no ma? Torque will be produced. Torque formula is how much? R into F is equals to I into alpha. Okay? So this is the torque which is produced in this condition. Okay? R value is not 0, no? If a force is acting at the center, then torque will become 0.
because directly it is acting on the axis, then force cannot produce any rotation. But force is acting at some perpendicular distance from the axis of rotation. Axis nunchi oka distance దగ్గర act అవుతుంది కదా. So this force can definitely produce torque. So torque formula R into F is equals to I into alpha. And this is what kind of sphere? Solid sphere. So what is the moment of inertia of a solid sphere ma? Solid sphere it is 2 by 5 mr square. So this is the formula for solid sphere. Are you able to understand? So substitute here. So radius already he gave no. So R into F is equals to I value is 2 by 5 mr square multiplied by alpha. So this is the angular acceleration which is produced. Are you able to understand? So therefore angular acceleration, how can I calculate ma? So alpha value is equals to R into F into 5 divided by 2 mr square. So this is the angular acceleration which is produced. So with this much of angular acceleration, the body is rolling. Okay. Again I can use the same relation. No? S is equal to ut plus half at square. Already we studied that in translational motion as well as rotational motions, same equations are there. Okay. So again use the same equation. So S is equals to ut plus half at square. But how I will change the terms? Instead of S I will write a theta. This is a displacement, angular displacement. Omega. U means omega naught, no? Time is t plus half alpha t square. So this is how I can write the equation in rotational motion. Are you able to understand? Initial angular velocity is 0, no? So therefore how I can write? I can write theta is equals to half alpha t square. Clear? So this is my first equation and this is my second equation. What he is asking actually distance traveled only, no? It means he is asking S value. So what is the time here? Same time will be here also, no? What is the time travel taken for moving in a straight line? In the same time only the disk is rotating. This sphere is rotating. Okay. So I want S value, no? But I have two equations. So let us do one thing. Let us try to divide both of them. Divide చేస్తే ఏమొస్తుందో చూద్దాం. So S divided by theta is equals to half a t square divided by half alpha t square. Clear? No? So t square half and half gets cancelled. S divided by, and theta value how much he gave? By the time it makes one rotation. One rotation means how much angle? 2 pi radians. Degrees is not the SI unit. Degrees is not the unit of measuring angle. Radians is the unit. One rotation means how many radians? 2 pi radians. So instead of theta I have to write 2 pi. Clear now? So this is equals to A divided by alpha. Okay. A value F by M. Okay ma? Alpha value, where is alpha? Alpha value is R into F into 5 divided by 2 into M into R square. Clear now? So therefore this is also capital M only. So therefore S divided by 2 pi is how much? So F by M multiplied by 2M R square divided by Fm into 5. Is it correct, ma? Rf into 5. Rf into 5. Now see the terms which get cancelled, force and force, mass and mass will get cancelled. So therefore S by 2 pi is equals to how much, ma? So 2R square divided by R into 5. So 1R and 1R square will get cancelled. So therefore I will get S is equals to 4 pi R divided by 5. Options 4R divided by 5. That is the distance travelled by the body by the time body makes one rotation. Are you able to understand how we have done, ma? So very simple. What this force is doing? Force ఏం చేస్తుందో కనుక్కుంటే చాలు. Force is acting in a straight line, so body will move in a straight line. Force is not acting on the axis, so therefore it will produce rotation also. So write one equation for translational motion, one equation for rotational motion. Just solve both of them. That is my required answer. That's it. Okay. So let us see this question, ma. So there is a solid cylinder around which a wire is wrapped and from this roof it is suspended, it is released. Then what happens now? This wire it starts unwinding, no? Wire unwind avadam start avutundi and this solid cylinder starts falling downwards. Clear now? So the question is, what is the downward acceleration of this cylinder and what is the tension in the string? A value and T value we are supposed to calculate. Okay? See now, first of all, when you see this system, this is a solid cylinder. Solid cylinder means what? It is of this shape, no? It will be shaped like this. So wire is wrapped around this one and from this point it is released. This is what is happening. So the question is, it will unwind. Why it will unwind? అలా మనం వదిలేసి అట్లే ఉండొచ్చు కదా గాల్లో, కిందికి ఎందుకు పోతుంది? Why it is moving? Gravitational force is there. So where gravitational force will be acting? Gravitational force ఎక్కడ యాక్ట్ అవుతుంది? మాస్ పైన. మాస్ ఎక్కడ ఉంది? Center. So mass will be concentrated exactly at its geometrical center, no? Which is called the mass or weight of this solid cylinder, mg, it will be acting downwards. Clear now? And this weight, it will be pulling this rope, no? So therefore tension T also will be acting in this direction. So these are the forces which are acting. Are you able to understand now? Now what this mg will do? This mg is responsible for making this solid cylinder move downwards. కిందికి లాగడానికి ఉపయోగపడుతుంది. అంతే కదా? It means this mg is responsible for which motion? Translational motion, movement in a straight line. అంతే కదా? జస్ట్ కిందికి లాగడానికి ఉపయోగపడుతుంది. రొటేషన్కి యూజ్ అవుతుందా? అవ్వదు. బికాస్ ఇట్ ఈస్ డైరెక్ట్లీ యాక్టింగ్ ఆన్ ద యాక్సిస్. ఎంజీ ఎక్కడ యాక్ట్ అవుతుంది? ఇట్ ఈస్ యాక్టింగ్ అబౌట్ ద యాక్సిస్ ఆఫ్ రొటేషన్. సో ఎంజీ ఈజ్ నాట్ రెస్పాన్సిబుల్ ఫర్ ప్రొడ్యూసింగ్ టార్క్. ఇట్ ఈస్ రెస్పాన్సిబుల్ ఫర్ ప్రొడ్యూసింగ్ టు మేక్ ద solid cylinder move in a straight line. Clear now? So therefore, if I write equations of translational motion, okay, if I write equations of translational motion, what I can say, mg is the force which is acting downwards, tension is the force which is pulling the solid cylinder in upward direction. So mg minus t should become net force, no? And net force is equal to mass into acceleration. That's it now. Downward force, upward force. Resultant force will give net force. Net force formula, mass into acceleration. So let it be my first equation. Okay, ma? Any value we don't know tension, we don't know mass, we don't know acceleration, anything we don't know. Clear? Now, similarly take rotational motion. Okay. Now can you say, first of all, will this solid cylinder, will it rotate or not? Rotate avutunda avada? If I release this one, just ala kindiki vachestunda, rotate, roll avutu kindiki vastunda. Roll. Why it is rolling? Why it is rolling? Question is, why it is rolling? For a body to roll with some acceleration, there should be some torque, no man? To produce rotational motion, what should be there? Torque should be there. Acceleration produce cheyalante force undali. Angular acceleration produce cheyalante torque undali. Who is providing the torque? Tension is providing the torque. మరి అది చెప్పండి, వై అంటే కిందికి వస్తుంది? అన్సైంటిఫిక్ రీజన్స్ చెప్తే ఎట్లా? సో రీజన్ షుడ్ బి అకార్డింగ్ టు లాజిక్. క్లియర్ నమా? సో సీ హియర్. సో దిస్ టెన్షన్, ఇట్ ఈస్ యాక్టింగ్ అట్ ఎ పర్పెండిక్యులర్ డిస్టెన్స్ ఆఫ్ ఆర్, నో? టెన్షన్ యాక్సిస్ పైన యాక్ట్ అవుతుందా? నో, ఇట్ ఈస్ యాక్టింగ్ అట్ ఎ perpendicular distance from the axis. So this tension, it will provide a torque to this disc, to this solid cylinder. Are you able to understand, ma? So therefore what I can say, tension provides torque. Tension provides torque. Clear? So therefore torque formula, torque is equals to R into F is equals to I into alpha. Clear now? So radius is, I don't know that also, let us consider as R or capital R anything. Force is nothing but tension. Here only because of tension it is rolling, no? So tension. Moment of inertia of a solid cylinder. See, solid cylinder and disc, same moment of inertia, no? So therefore I will write half mr square multiplied by alpha. Okay? So this is my second equation, this is my first equation. What he is asking actually? Actually he is asking acceleration. Acceleration means which acceleration? Linear acceleration. Linear acceleration with which disk is falling down. Are you able to understand? Now see here. So let us consider this disk is falling down with an acceleration of a center of mass. Center of mass acceleration is SCM. Okay. Now this is an example of rolling body, Noma. This is a type of example, rolling body. How can you say this is a rolling body, ma? First of all, what is meant by rolling? Rolling ante em chadukunnam manam. Rolling means the point in contact which is with the ground, temporarily it should be at rest position. So here who is the ground? This wire itself is the ground. So with respect to ground, this cylinder, it is not slipping, no? Roll out. Slip out, no, it is rolling. It means that this point is temporarily at rest position. So this point should have two velocities, no? What are the two velocities? Because it is rolling like this, so one velocity is tangential velocity, another velocity is velocity of center of mass. Both of them, they should be equal. Clear, Nama? Similarly, the acceleration is tangential acceleration, another acceleration is acceleration of center of mass. They should be also equal and opposite. Yesterday we have derived this one. Are you able to understand, Ma? So therefore, what I am saying here, acceleration of center of mass is nothing but tangential acceleration, and tangential acceleration and center of mass acceleration, it is equal to A, and A is equals to tangential acceleration formula R into alpha. Clear, no? So therefore alpha is equals to AT divided by R, or just you can write A divided by R, because A, AT, A center of mass, all of them, they are equal. Rolling motion arthamaindi kada? Clear, nama? This point is temporarily in rest position. It is temporarily in rest position only in one condition. Tangential speed, velocity of center of speed, velocity of center of mass should be equal. Tangential acceleration, acceleration of center of mass, they should be equal. What is the formula for tangential acceleration? R into alpha, and that is equal to acceleration of center of mass. Acceleration of the center of mass, I have taken A. Okay, ma? So therefore alpha is equals to AT divided by R. Just you can write A by R also. So therefore take this alpha and substitute here. Are you able to understand, ma? So therefore, no, why I have to substitute here? Alpha is there, no? Already I have written, no, ma? So take this alpha, substitute here. Clear? So R into T is equals to half mr square multiplied by alpha. Alpha value is A divided by R. Okay? So this is my second equation. Now from first equation and second equation, I require A value and T value. That's what he is asking now. Acceleration and tension. So do one thing. From here, take a tension and equate tension here, you will get acceleration. Once you get acceleration, you will get tension also. That's it, no? So this is my second equation and this is my first equation. I can do here one thing, no, ma? R and R, another R and another R get cancelled. So therefore what I will write? I will write T is equals to half M A. I can write like this, no? So now instead of this one, let us consider this one to be my second equation. So I will do one thing, ma, take this tension and substitute in the first equation. So substituting T in equation number 1. Okay, this is my equation number 1. So therefore what I will get, mg minus, instead of T I can write half MA is equal to MA. Okay, ma? So therefore it is 3 by 2 MA is equal to mg. M and M get cancelled. A is equals to 2g divided by 3. So that is the acceleration which I got. Okay, ma? So take this acceleration, let it be fourth equation. So substituting 4 again in second equation. So T is equals to half into M into, instead of acceleration I will write 2g divided by 3. 2 and 2 get cancelled. So T is equals to mg divided by 3. That is the equation for tension. That's all. Okay. Understood, Nama? So we have used every concept here. We have used the concept of rolling also, translational motion also, tangential motion also, that is rotational motion, and the relation between tangential acceleration and angular acceleration also. Many equations we have used and finally I got the answer. So we have done this total calculation and I got the required answers. Any other method of solving the same problem? ఇది కూడా కైనమాటిక్స్ న్యూటన్స్ లా సార్. Any other method? Constraint relations already we have used. Any other method? See, yesterday we have derived some ready-made equations. Do you remember? Body rolling down an inclined plane. Chadunam kada? What we have studied? Body rolling. Chudandi enakala. Down an inclined plane. This we have studied, no? We have derived equations of velocity. We have derived equations of acceleration. We have derived equations of friction. We have derived equations of minimum coefficient of friction. ఇవే కదా derive చేసింది. So can't you apply the same rules here? చేయొచ్చా చేయలేము. This is also a rolling body, no? But inclination, is it present? Present, 90 degrees. Angle of inclination you can take 90 degrees, no? Are you able to understand, ma? So previously we studied this model, no, ma? Okay? Angle of inclination was theta. Body was rolling down this inclined plane. Now if you take theta value to be 90, then this is the condition which you will get. Ante kada? Theta 90 endante body itla avutundi. Then this is the condition. So acceleration only, now he is asking what is the equation of acceleration we derived yesterday? G sin theta divided by 1 plus k square divided by r square. Okay? Direct ga vastundi answer, panchayate ledhu. Okay ma? G value, G only. Theta 90, sin 90 value 1. 1 plus k square by r square. Sorry, r square by k square, no? A value. K square by r square, r square by k square. ఒకసారి చూడండి ఎందుకైనా మంచిది. K square by r square ఉండేనా? I forgot the equation. K square by r square. So 1 plus k square divided by r square. Okay. And what is the k square by r square value for a solid cylinder? Solid cylinder moment of inertia, disk moment of inertia, both is same, no? Half mr square. So G into 1 divided by 1 plus 1 by 2. Clear number? K square by r square value for a disk 1 by 2. K square by r square value for a solid cylinder 1 by 2. Okay. So therefore see this one. So G divided by 3 by 2. It is 2G divided by 3. That's all. That is my answer. So in a very single step I got this answer. No? Are you able to understand? Ma? So what do you understand? కొంచెం తెలివితేటలు కూడా వాడాలి. That's it. So now here what is happening, same solid cylinder. Okay ma? Previously in the last problem we were winding the same solid cylinder by a single string, no ma? Only one string was present. So here what will happen here, this is string number 1, this is string number 2, two strings are present. Okay, mass, moment of inertia, nothing has changed, no? So therefore acceleration also will not change. Acceleration, what was the acceleration in the previous condition? 2G divided by 3, same acceleration here also. Okay, or if you want to prove it, what is the this is also a rolling body, no? Even if you suspend by 2 strings or 1000 strings, it is a rolling body only, rolling at an angle of 90 degrees. So what is the acceleration? A is equals to G sin theta divided by 1 plus k square divided by r square. So d did not change, theta did not change, k square by r square also did not change. So acceleration also will not change, same acceleration, 2G by 3. 14 string lesna ade vastundi answer. Able to understand? But what is the difference between one string and two string? What was the tension in the last condition? Tension was how much? Mg by 3, no? Last condition tension was mg divided by 3. Because here only one string is supporting this cylinder. Here two strings are there. So tension becomes half. Not a double, half. Understood now? So tension in this one will become mg divided by 6.
Here also tension will become mg divided by 6. mg by 6 plus mg by 6, mg by 3. That's all. That is our calculation. Are you able to understand? So like this logically you can compare both of them and you can write the answer. మాకు ఇవన్నీ ఇష్టం లేదు, వీఆర్ లైక్ జగన్ అనుకుంటే you proceed in the same method. Which method? Sima. Again do the same calculation. So in translational motion, okay, weight mg is acting in downwards direction, no? Weight mg is acting in downwards direction, and which is the upward force? Tension, how much? 2 tension, 2t, because here also one tension will be there, here also one tension will be. 2 tensions are there, no? So mg minus 2t is equals to mass into acceleration. This is the difference. In the previous case, this is mg, this is tension. mg minus t is mass into acceleration, but here 2 strings are there, no? So mg minus 2t is equal to mass into acceleration. This is the equation of translational motion. Then what is the equation of rotational motion? Okay, ma? In rotational motion, who is providing the torque? Tension only. But how many strings? 2 strings are providing tension. Okay? So therefore torque is equals to R into F is equals to I into alpha. Okay? So R is capital R, force is nothing but 2t, moment of inertia is half mr square multiplied by alpha. Okay? Again we know A tangential is equals to A center of mass is equals to omega into R. ఇది తెలిసిందే కదా ఇంకా, సారీ ఆల్ఫా ఇంటూ ఆర్. ఓకే, సో దేర్ ఫార్ వాట్ ఈస్ ఆల్ఫా వాల్యూ? ఆల్ఫా వాల్యూ ఈజ్ ఈక్వల్స్ టు ఏ డివైడెడ్ బై ఆర్. సో అగైన్ టేక్ దిస్ వాల్యూ, సబ్స్టిట్యూట్ హియర్, దెన్ సాల్వ్ ఫస్ట్ ఈక్వేషన్, సెకండ్ ఈక్వేషన్, అగైన్ యూ విల్ గెట్ ద సేమ్ వాల్యూస్. ఓకే మా, వాట్ ఆర్ ద వాల్యూస్ యూ విల్ గెట్? యాక్సిలరేషన్ ఈజ్ ఈక్వల్ టు 2g by 3, టెన్షన్ ఈజ్ ఈక్వల్ టు mg by 6. దీస్ వాల్యూస్ యూ విల్ గెట్. అంతే. ఓకే, జగన్ రెడ్డి పాలన లాగా ఇలా చేయొచ్చు. Okay, so these are the